Hello everyone and welcome to this session on Cloud Security Full Course by Intellipaat. Preparing a business for future success starts with switching from on-premises hardware to the cloud for your computing needs. The cloud gives you access to more applications, improves data accessibility, helps your team collaborate more effectively and provides easier content management. Cloud data security is vital as you will want to be sure that your data is safe while stored in the cloud. Cloud security, also known as cloud computing security, is a collection of security measures designed to protect cloud based infrastructure, applications, and data. In this session, you will learn all about cloud security. So let's check the agenda for this session. First of all, we are going to start with the basics of cloud computing and data lifecycle. Moving further, we are going to talk about the risk and the threat of cloud computing and how we can design a secure cloud solution. After this, we will talk about the physical and environmental protection, audit mechanisms, and IRM in the cloud security. To sum up this session, we'll talk about the disaster recovery strategies, what is our trusted computing, and types of trust in cloud security. So that's all with the agenda. Now let's start the session. Before we begin, subscribe to Intellipaat and don't forget to press the bell icon to get more updates.
The five essential characteristics are first one is the on-demand self-service, then broad network access, resource pooling, which is also we can say that multi-tenancy or which leads to multi-tenancy, the rapid elasticity and major service. Now, depending on these characteristics, each one lead to some of the security issues we will discuss one by one. First one is on-demand self-service. So any person can access the cloud resources uh, directly without any human intervention. See, for example, there is an infrastructure as service cloud provided by an organization. There is some developer, there are some employees of the organization, and there is some IT. There are some IT operations people from the organization. Everyone can access that particular cloud environment. Now the question comes is, do you think if there is a cloud services offered by an organization, is it available for everyone, or is it available for only a small group of people? So here in this case, the access to this particular cloud provider, which is provided by a specific organization, is limited to only for their employees and IT operations people, which may or may not belong to the company. But if there is any independent developer who is not part of this workflow or organization, may not be able to access the cloud. So one of the depending on the basic characteristics of on-demand self-service, it if we are offering the services of this organization cloud to everyone, then that particular developer can also access the cloud, but we don't want that. So we have to apply some methods, we have to apply some techniques, so that any developer who is not a part of that particular organization or workflow may not be able to access the cloud services or offerings provided by that particular organization. Similarly, second one is broad network access. So it says that we can access the services provided by cloud using any particular means. We just have to follow some regular initial protocols such as HTTP or XML, but it does not depend on from which device we are accessing that particular cloud environment. What about private cloud? Because if there is a research organization which is handling some very strict data or some private data, and we don't want that data to be accessed, but if the organization can be accessed from anywhere, then their private data can also be available or can be accessible from somewhere else. So how can we handle this particular scenario, uh, which is created by the broad network access? Next one is any device with right credentials, say for example login ID and password, should be able to access the account. But this creates an issue. What if the device is compromised? Say for example, you have your university or company login from your mobile phone, but you lose your mobile phone. And if someone and if your mobile is kind of found by someone else, then that particular person, if he is able to unlock your screen or unlock your mobile phone, is able to access your email and all the information about that particular organization. So what happens, or how can we handle if the device becomes compromised? So that is another issue which is created by the broad network access. Next one is resource pooling. Resource pooling says that sharing is caring. So just share the resources. That increases the utilization of services provided. Also, reduce the resource wastage. We can share the resources between unrelated organization or people in the public cloud environment, within an organization in the private cloud environment, and with an umbrella organization in terms of community cloud environment. But in this scenario, who owns the resources? Who kind of manages the resources? Who is, or where which place all these resources are running? Who is able to access or consumes the resources? What are the security parameters provided in these particular environments? So these are the questions related to resource pooling. Let's see how we can, or what are the environment or available for public cloud environment. Say for example, if there is any public cloud environment, is it owned by an organization or a third party? Similarly, for manage, is it managed by an organization or third party? What about location? Is it located on premise, or is it located somewhere we don't know? What about the access? Is it trusted or is it untrusted? Can someone tell me about owning, like in public cloud environment, who owns the resources? So two is correct. Like it's owned by the organization. That's sorry, it's owned by the third party, but it is also managed by the third party. Say for example, if you are an organization, you are using the services provided by Amazon. So Amazon is, and I'm a client of this any particular company, then that particular, like my data or my services is not managed by your organization, because that particular organization is using the services which is provided by Amazon. So that is third party, that is not the organization. Other thing is, in terms of access, it's not trusted at all, because client or any particular employee, any particular user, that trust that trust the organization, and organization kind of trust the cloud service provider. But this is a kind of chain of trust. We can't directly say that it is fully trusted. There are many issues or many factors in terms of trust, which we will discuss later. Similarly, what about the private cloud environment? Is it organization, third party? What about management? That particular organization may own the cloud environment, or it may lease from a third party. But all those services are strictly owned by that particular organization, or strictly in complete control by that particular organization. Also, it may be managed by the organization, or if the organization is not very big, they may kind of lease the third party organization, third party management option. In terms of location, it is again either off premise if it is completely organized or completely owned and managed by the organization, or it may be off premise. In terms of access, it is considered to be trusted. I put a question mark. Usually people think that if it is a private cloud, it is trusted. In normal case, it is trusted, but there are so many scenarios where there is a question mark. We are not very sure whether it is trusted or not trusted. You kind of own a server, and you are managing the server, like how to handle, how to do the partitioning, creating the virtual machine and containers, giving the access to all your users and all. But what about the security policies? So like sometime what happens that you have to apply so many security policies to the server. Now if any of, like, lacking of any of the policy may lead to some vulnerability. uh, it may happen that your password may be leaked, or the admin password may be leaked, so third party or someone else, like intruder, may access uh, your server. uh, if it is a medium sized organization, then you need a separate location for a server, like data center, sorry. You need a separate location for the data center where you have all the servers located. Now in that particular scenario, what happens that how are you, like, which person you are allowing to get inside that particular server or data center? uh, who are accessing? which persons are going and patching the network, how are they accessing, whether it is like normal fence, normal building, or whether it is like card access, whether it is like simple access control, or whether it is like two level access control. All these factors can lead to some security issues, and again trust issues as well. So similarly, in terms of community cloud, it is owned by the either umbrella organization or third party. It is managed by, again, management is also by either umbrella organization or third party, or sometimes both. Location, again, it depends on, it may be either on premise or off premise. It is also considered to be trusted because it is accessed only by the employee or people of the umbrella organization. Next property is the rapid elasticity. uh, Again, there is, I think, you guys already studied about scalability and elasticity, and what is the difference between scalability and elasticity. So in terms of elasticity, it's good that cloud computing provides very fast elasticity, so you can increase or decrease the amount of resources required at runtime. Possibly not efficient for all applications. If the requirement is very high, or if the network bandwidth is very low or not that adequate, it may take some time. Now question comes is, how do you allocate more VM? There's more resources. How do you move or terminate competing VM on same hardware? And is there any other solution available? In terms of security implication, it says that since network is very dynamic, so it's hard to guarantee that rapid elasticity is provided. Second is, how do the cloud provider check whether all the requests, even for increasing or like scaling or unscaling or descaling the resources, is authentic or genuine or not? So that may lead to kind of denial of service or distributed denial of service attack, which we discuss a little bit later. Finally, we have this measured service. It is required that, I think you already know that cloud provider is a business model. It is made to make money. Then question come is, how do they make profit? So cloud provider are making profit, but how are they making profit? Second is, to provide better services, cloud provider need to know that what is the total amount of resources uh, the VM is using, for how long the resources is utilized by the VM, and how many customers are served by that particular data center or that particular uh, server. This may require some private information, and if the cloud provider know the private information, there is a chance that this information may got leaked. So all these basic characteristics of cloud computing leads to some of the vulnerability which need to be handled properly. Now the question come is, why we move to cloud? Previously we don't have cloud, we have less resource, like less security concerns, although we have some security concerns, but not as compared to when we plan to move to cloud. So say for example, if you are an organization and you kind of want that you want to move to cloud, so then you have to analyze whether is it a good choice to move to cloud. You have a meeting and then you decided, no, we want to move to cloud. Now uh, if you want to move to cloud, what are the steps that you need to do before going or moving to the cloud? So these are the information which is required before you plan to move to the cloud. First one is, identify and classify what are the information assets you have. So I will discuss all of these one by one. Next is, what are the risks and how are you managing the risk, or what are the strategy that you are managing the risk. then then you come that, okay, now we decided that we want to move to cloud. Now you have to plan how to design a secure cloud solution. So first one is information assets. So information assets is the main information asset any organization or company is the data or metadata. Now with each data, like with each data and metadata, we have some information. Now this information is, who may know this information, which people from our organization may know it, which information we need to send it to the cloud. Sometimes what happens, we can send all the information to the cloud, but sometimes we don't need to send all the information to the cloud provider. We can kind of distribute our information or data. We hold some of the information by our own, and then we send some of the information to the cloud. Now when we are sending some information, are we sending our information directly, or are we kind of encrypting the information and then sending the information to the cloud? Again, what are the privacy concerns? Nowadays we have a lot of security rules in India, in Europe, in China, and in United States. So we have to consider, is, are we kind of violating any of the privacy concern? If we are violating, then how do we manage those concerns, or how do we manage and kind of mitigate those concerns before sending our data to the cloud? Now talking about data, so we have different type of data. Say for example, if you're in an organization, you have files, you have user information, you have login ID, password, you have some logos, pictures, you have some papers, you have some code, you have a like, so variety of data. Now you can distribute the data in many ways, but here we are dividing the data type in just two types. One is structured data and other is unstructured data. In structured data, we can kind of save the data in a tuple format, like in a tabular format, so that we can have specific rows and columns. But in an unstructured data, we don't have any specific structure. Say for example, like image or tweet, or some of the pictures or video, audio. So those data, it's very hard to kind of define any structured format. So that's an unstructured data. Now structured data is easy to handle, because we already know, okay, this is the data, this is our data type, these are the, we may have number of rows and number of columns already defined. We can feed the data, and we can kind of save and act on that particular data. While if we have unstructured data, it's very hard to handle those data, because we don't know how much data we are getting, uh, what the processing we need to perform on that data, and how and where we are going to save that particular data. now now when we got the data, then each of the data, or all the data has some phases to pass before the data data is vanished or data is no longer required. Say for example, initially you don't have any data, now you are getting some data. So getting some data or generating some data is what, like creation of a data. So when we create the data, then we have to store the data. Then when we already have the data, then we have to process the data. We have to process the data. When after processing the data, again we have to store the data. After processing, we may have to, if we don't need the data, then we have to archive the data for later purposes. Finally, we have to delete the data. So these are the basic 6 steps. First one is to create the data. Now then, in this particular stage, an organization generate data either directly or it generate on cloud. Say for example, if you're running an application on cloud, then it will generate data directly in the cloud, and you have to kind of save your data in the cloud. while while if you have some, if this is a already established organization, then you have a lot of user information. uh, some user is running or writing their code on their own machine, or on the basic environment. So those data, so data can be either created directly on premise, or it can be created directly in the cloud environment. Saving or creating cloud data also include the VM information. So when we want to use the cloud, then we have to create a VM or container. So those particular data is also saved in the cloud, which is not normal data, which is a kind of metadata. Each VM, their logs. So when we are executing the VM, there is a background logs also created, what time we are accessing, what operations are performed on that particular virtual machine or container, what network access is performed, or how user is accessing that particular VM on the network. In addition to that, it also saves the CPU uses, memory uses, to runtime handle those particular virtual information. In addition to that, it also stores some of the monetary information, such as how much is your subscription, how many hours you have to run, how much money you need to put more, or using those information, it sometimes also create some further information which can be used for next month prediction, so that it will tell you some uh, smart information that, okay, last month you used this much information or this much resources, this month we are trying to provide you this much resources, to reduce your access time, especially in terms of elasticity and all. Second one is the storage. So when data is created, we have to store the data, otherwise data may got lost. We don't need to store all the data, because in many cases we are generating, like in the time series manner, we are generating data all the time. We don't need to store all the data. We have to kind of act or analyze which data we need to store and which data are not important to be stored. Yeah, so in terms of storage, there are many ways in cloud environment to store. So first one is raw storage. Raw storage is store the data directly in the way it is generated. Second one is ephemeral storage. So whenever we create a virtual machine, we kind of it automatically has a basic storage attached with that particular virtual machine or container, which stores the state information or the uh, default data which is created with the virtual machine. Whenever we stop the virtual machine, these data got deleted. We don't have to terminate the virtual machine. Just stopping the VM will kind of removes the data. Third one is we have to attach a volume sometimes. So for example, if you have some data that is required by the virtual machine, but you don't want the ephemeral storage, so then we have to create some separate volume, attach those volumes to the virtual instance, and make the cloud, or let the cloud instance use those particular data. So volume storage is very similar to the external hard disk, which can be attached to any particular virtual machine or any particular system. Next one is the object storage. In terms of object storage, so this is again when we are kind of archiving our data, when our data is no longer required, then we have to store it in some object storage, which can be like later used for the long term storage. Like long term storage is in terms of not only storing in that particular cloud environment, but also take out the data from that particular cloud environment and store in some low cost environment, where the access time may be a bit slow, but it will be very cheaper and very kind of efficient. Sorry, yeah, it will be very cheaper, and it can store a very large amount of data. Finally, the last one is I can say content delivery network. In many cases, especially when we are accessing the video on YouTube or Netflix or Amazon Prime, what cloud environment does is they kind of resave or saves the same amount of data at multiple locations, so that it can be accessed by many environment, or it can be accessed by based on the region wise. So each region can easily access those particular data. uh, this kind of reduces the access time for each of the user. Next one is use, how we are using the data. Now, how we are using the data can be used in multiple ways, uh, in terms of uh, in terms of performing an execution, in terms of creating some a payment slip, in terms of uh, using some AI technique, which accepts some data, or doing some mathematical calculation, high performance computing. Depending on which kind of application we are using, we are accessing our data, and we are manipulating it and creating some result. Next is after using and storing, sometimes in some cases we need to share our data. So how are we sharing our data? So data is often shared with other employees or customers and some other partners. Again, sharing is important, but also it creates some more security concerns, which we will discuss further. Next is archive. uh, so in terms of archive, when we don't longer use those particular data, we can save it in like long term storage repository for later use, in yeah long term storage, or which can be accessed whenever required, but the access time is little bit high. And the uh, that particular storage will store very large amount of data. Finally, we need to destroy the data. This is also very interesting. Whenever we store any data in the cloud, it usually doesn't destroy. It kind of overrides, or it deletes the how can I say, it deletes the access point, so that with which someone is accessing, that is just deleted. Remaining the data is not deleted, which is not good. Recently there are a lot of research and talking happening that if the cloud say that they delete the data need to be deleted, which cannot be recovered after some time. Say for example, in mobile phone, if you are deleting a data, it says that your data is deleted, but there are some ways you can access your even deleted data after some time. uh, some of the phone allow it to store the deleted data for 6 months. Some of the phone uh, delete in 1 month. But again, that particular deletion is if your information is already stored in the cloud, they just kind of remove your access, but the data is still there. So there are some specific techniques required uh, how to securely delete the data. So now we have to, so now we know, okay, this is our data. Now we need to know that what are the risks associated, or what are the threats associated with our data. So although there are a lot of risks and threats associated with our data and cloud environment, uh, I'm gonna discuss 12 of the main risks that that can be like those are like kind of one of the uh, most important risks associated. Since the cloud provider is not always uh, very spectacle about whether you want to delete or not. So sometimes what happens that they use your data, and they kind of create some apply some AI method, and then they kind of predict for your future requirement. So that's why, or they always not delete. Like most of the time they don't delete, because deletion is a very complicated process, especially for the cloud environment, because uh, as I told you, that there is no direct way that you can delete. You can overwrite the data, which we don't have our own control over the cloud environment. So we can't say that yeah, I agree that it should be good that someone, or there is a policy, there need to be a policy which can define that, okay, data should be deleted after 5 year or 10 years, or even if it like in 5 years it's too long. And if it's a big organization, then it create like huge amount of data. So even like 6 months, sometimes what happens that especially in terms of video recording of some who is coming, or this biometric access attendance, that is hold for 6 months. If there is nothing happened in 6 months, then they just remove the video recording or biometric attendance. In terms of biometric attendance they can have, but in terms of video recording it is very heavy, especially if they have kind of in the whole office, if they have like 500 cameras, then they can't store all those data for very long time. So these are the 12 main threats or risks. These threats are specified by the International Organization of Standards and International Electrotechnical Commission. First one is unauthorized access. So in terms of unauthorized access, if you have a, so the example is, say for example, if someone else is using your ID card to enter into the building, so since you have the authorization to enter into the building, no one else has the access to the building. But if someone else is kind of either using your card or tailgating, like just following you when you are entering in the building, so that particular is considered to be unauthorized access. So in terms of definition, uh, user gains access to and are able to view the data that they shouldn't have. So sometimes what happens in office that if you are working on some very security critical application, and someone else who is sitting next to you, they can kind of just look and see that, okay, you are doing on this particular data, or you are using this particular application which you don't want them to see. So that is also considered to be kind of unauthorized access, although they don't have authorization, but they are kind of accessing mm, that particular information. Next is unauthorized uses. So unauthorized uses is so in terms of unauthorized uses is that user is able to modify. Say for example, if someone else take your password, like login ID and password, and start posting on your Facebook profile. So access is just accessing, like getting the information. But if someone, like after getting the information, after getting hold of your information, if they start using uh,
Just a quick info, guys. Test your knowledge of cloud security by answering this question: which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
using your particular information, like sending mails to, if someone else get your login ID and password of your email, and if they start sending mail to someone else, so that's kind of unauthorized uses. You don't want anyone else to use your particular credentials or your particular authorization, and start using it for some other purpose, but regardless whether it is good or bad, that is considered to be uh, like security vulnerability. And that is very common in terms of cloud environment. If someone else uh, has your login ID and password for uh, any of your social media or cloud environment or some system, they can access and they can perform something. So unauthorized access and unauthorized you especially unauthorized access may be kind of left unnoticed for longer time if that particular person does not perform any unauthorized uses. So the time when the person start using the unauthorized uses, uh, you can easily visualize, or you can easily kind of analyze, okay, now your information is being like start being used for either like required or unnecessary purpose, or some threat kind of purpose. Next is like regulatory non-compliance. Uh, so what happens is that several application has some boundary, regulation boundary, especially in terms of credit card. Like you have a specific uh, you have a specific kind of limit on each credit card, and sometimes uh, if someone like use some method to exceed their particular limit, which is not considered, especially for now, since the credit card companies are very strict, you can't use that. But there were some time that particular person using the credit card, they can access the credit card to use for some purchase or withdraw some cash, and then they don't kind of comply with any of the regulations which is specific to that particular card. So it is necessary that all those policies and requirements should be audited regularly, and any necessary means should be taken to any person or who is kind of using this non-compliance, or who is performing something which is not uh, compliant by the policies or the rules specified. Next one is network security. Again, cloud environment network plays a very important role, especially for cloud environment, because we can access the cloud via network only. So there are so many vulnerabilities possible in terms of network. We need to make the network as secure as possible in terms of HTTPS or using the very specific like TCP IP protocol with SMTP and all in terms of messaging, in terms of accessing our email and everything. But even though there are some security issues, especially in terms of like distributed denial of service attack and denial of service attack, where either one user is creating a set of requests, or multiple users from different locations are kind of trying to overload the network or the virtual machine, so that the genuine or authentic requests may not be served, or it takes very long time to serve. 1 minute. Again, next is the man in middle attack. So since user is accessing via network, someone listening the traffic can use those information to gain access. There are multiple ways to do that. Like if someone is kind of accessing the network, they can easily hold those information and use the log to get the kind of what topic or what information is being passed. They can decrypt some of the information to know the login ID and password, or they can sometimes say that, okay, uh, my login ID is missed, I have the sorry, my password, I forgot my password, this is my login ID. And they can use those particular information to kind of gain access to the system. Not only that, they can also easily replay the previous information to say that, okay, this is the previous OTP, but I can't receive the OTP because my I lost my phone. So that can lead to some of the very important network security questions, which need to be handled very carefully. Next also is the corruption and destruction of data. So data in cloud is protected against unauthorized modification. So we don't want, if we are storing some data in cloud, we don't want it to be kind of updated either by cloud service provider or by any co-resident virtual machine user who is accessing the virtual machine, or a third party admin. Because we kind of trust the cloud service provider that although we are using cloud, but we don't want our data to be corrupted or to be uh, destructed or removed without our own access. uh, Again, this also leads to kind of data breaches and leakages. So sometimes, regardless of all the precaution, uh, either by our own mistake in terms of the program that we are writing or the application we are using in cloud, there may be possibility that our data may got leaked, or there is some breach in our data, which allow some unauthorized user to copy some of the basic or important information, which can be further used to either corrupt the data or access our virtual machine, or unauthorized execution of our own virtual machine in terms of cloud environment. Next one is theft or accidental loss. So if we lost our mobile phone, or if we lost our tablet, which kind of saves all the information. So if someone get hold of our mobile phone and kind of accessed, or get inside our mobile phone, they can access all our information. So how are we how are we gonna tackle those, or how do we handle those kind of accidental and theft loss? Similarly, in terms of malware, when we are executing our application, and it may be possible that there are some malware attached to that particular application or program that we are executing. Especially malware is left undetected for a long time, uh, again because we don't know whether our system contains any malware or not. Sometimes it may lead to corruption of our data or resources. Just they delete the data which is running in, or available in that particular folder where it is executing. Sometimes it can also like move from one virtual machine to other virtual machine which are co-resident on the same server. uh, so all those things need to be kind of checked very actively, and need to be acted upon uh, need to be acted upon as it is like recognized. Next one is improper sanitization. So again, this leads to the deletion of the data. So when the data is delivered, we don't want it to be when we say that we delete the data, we don't want anyone to kind of recover our data or resources in any way. We just want that, okay, if we say that we are deleting our image, it means it get deleted. It may not leave any memory footprint, so that it can be accessed later on by third party or any other user or even cloud service provider. The one is also is very important is virtualization security. I think you already studied a lot about virtualization. So virtualization comes with its own set of security concerns, regardless of whether it is a hypervisor or a container. They all are executing on the host operating system. So if there is any flaws in terms of security, either at the host level or at the VM or container level, it affects the execution of users application or data in that particular virtual environment. I already discussed a little bit about the VM co-resident attacks. So sometimes what happens that if there is any corrupted VM available on the server, it can kind of corrupt the other virtual machines available on the same server. Uh, Also, in terms of worm, if there are some worms available in one of the virtual machine, that can easily affect the virtual machine, the other virtual machine executing on the same server. It also got affected by some of the denial of service attack in terms of network. If our virtual network uh, is affected, if someone know that, okay, this is the network bandwidth they are using, so why not to use the same network bandwidth? Not even they are accessing our own server, but even if they are accessing some other server, but if the network bandwidth is shared, so that can also kind of affect the virtualization security. How to tackle these, we will discuss this later. The one also is account and service hijacking. So in terms of phishing, like either phishing mail or fraud or exploitation are used to gain access to users' credential, and then it can be used to compromise the whole system or one particular application executing on the system. Uh, this is very again very important to be addressed, that okay, we don't like open or use any phishing email ID. Especially, it need to be kind of some monitoring or a tracing method, so that it will check, okay, this mail is authentic, or this mail is, or this application or mail is authentic, or just phishing email. There are some disasters also can be possible, either in terms of natural disaster. Say for example, the place where we have our data center, and there is some flood happened, or there is some landslide happened, or there is some fire happen. uh, Sometimes because of the networking issue as well, sometimes because of some electricity issue. The other is in terms of man-made. So sometimes if we are writing our own application and we create some bugs that kind of consumes a lot of memory, uh, like fork bomb application. If you're running the fork bomb application, it kind of forks indefinitely till your whole system got shut down. So if there is any such kind of application executing, which is like not defined intentionally, but that happens when writing or executing the application, or sometimes using some high voltage short circuit or some water leakage, these all can affect the system, and also lead to some security issues, physical security issues that also need to be tackled properly. Any question till now? Okay, then we will move to the manage risks and threats. So now we know, okay, these are so now we know what are the threats and risks associated uh, with our cloud environment. So since we already know the risk, then we need to kind of assess that, okay, what are those risks, or how we are going to handle those risks. So there are three major variables for the risk assessment. First one is what is the risk or threat. uh, Second is how likely the risk or threat will happen in terms of vulnerability. Third one is what is the impact of that particular risk. uh, See, for example, if consider this example of natural disaster. So just natural disaster on premise. So our threat is that happening or occurrence of natural disaster. Now likelihood. In terms of likelihood, you need to see that um, what is the likely, what are the options, or how much percentage of chance of happening of, say for example, uh, some flooding in near to any data center location. So we need to analyze with the help of some previous environment data, some more weather data, and then we can come up with some likelihood that okay, there is 5% chance that there is a flood happening near to the data center that can affect either electricity or the location of uh, the servers which are executing on the data center. Using the threat and likelihood, we can create the impact that okay, uh, although we have 5% chance, but it can hardly impact the execution of our server because our server are executing on the first floor. uh, uh, we have some backup already available in terms of generators, so even if there is any uh, electricity outage, we will not go out of power.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
And so on. Again, we don't only have to analyze in terms of quantitative, like in terms of number, we also have to check in terms of qualitative by talking to the people or by getting some questionnaire with our customer that okay, these are the likelihood, are you fine with these cases, yes or no, because uh, the main thing is that if there is any risk happen, then the risk not only affects the organization or company, that will also affect the customers. And uh, since customer and the organization are bound by the service level agreement, the organization does not want to like either overpay or pay for any risks which they can't control. So it's better to kind of compute it qualitatively and discuss with their customers or their employees. Analysis should not just occur once but repeat whenever the system or context change. So this need to be repeated with each of the context for each of the data center. Sometimes this need to be performed regularly, like once a year or once in 2 years, and so on, so that there is no risk associated with any of the execution in the cloud environment. So first one is mitigate. So add additional control to lower the impact or vulnerability. So say for example, if you know that okay, there is any disaster happening or about to happen in this area, so there may happen electricity outage, so you can buy some additional generators. Or if you know that okay, your organization is prone to uh, some theft or some security theft from some other organization, which want to try to access your resources, so you can implement some multi-factor authentication, so that like multi-factor in terms of either two-factor or sometimes even three-factor authentication, so that no one will access your organization. So in this way, although you can't control the risk or you can't like say that okay, this risk will never happen, but you kind of reduce the amount of risk that can happen in your environment. So what happens that any organization, or say for example yourself, uh, you how do you know that okay, you are kind of getting like part of a theft, or what happens if your phone got lost? So losing a phone is a risk which has how much probability, like 2%, say for example. But if you lose your phone, that is a risk. So that in that way you need to take care that, okay, even if you lose your phone, how do you kind of handle anything which lead to or what are the event will happen when you lose your phone in terms of security. You don't want anyone else uh, to get a hold of your phone and access your data or perform something. So so that's how risk is associated with the security. So you have to kind of handle the risk to reduce the chance of any security implications which can occur because of that particular risk. So second one is risk transfer. Say for example, if you have any risk, say like consider an example of mobile phone. So when you buy a mobile phone or a laptop, then if you buy an insurance, you don't know when your laptop got crashed, when your laptop will be crashed. So it's better to kind of outsource your risk. So even if there is any crashing happened in your laptop, you are kind of sure that, okay, I don't have to worry because I already bought an insurance. So they will give me a new laptop, they will format my laptop, they will like get my data out from my previous laptop, and I will have the similar kind of environment that I had in my previous laptop. So in this way we are kind of outsourcing our risk to someone else. So for this we have to pay some money. Third is accept risk acceptance. Okay, just accept the risk. Okay, if this is going to happen, this is going to happen, we can't control this. So if the risk will happen, then we have to accept. Okay, if unwanted, if you're writing a program, it may be possible that we can create a bug. So we have to kind of keep attentive that, okay, we may not create a bug which consumes our memory, but it may happen. So we have to kind of accept that, okay, uh, if this will happen, then just I'm accepting, and whenever it happens, then I will try to see how I can handle this particular scenario. Next is avoidance. Okay, just try to avoid. So try not to use any, or try not to open any phishing email or any email which we don't recognize, or which ends with some other information that we don't know. In that way we can kind of avoid getting kind of any malware in our system. Say for example, if you get one mail, and if you're not opening the mail, you it may happen that it may be possible that there are some other ways you can get malware, but you're at least trying to avoid as much as you can by not opening the mail, so that your system is secured, at least for your sake, or at least for that particular mail that you have already received. Last one is risk difference. So the thing in this case is you can avoid, but you can't avoid like for all the time, until we can mitigate or transfer the risk. So in this case you can avoid till you can mitigate, or you can transfer the risk. So in this way, this requires a lot of work, so that you know already that, okay, how you can mitigate the risk, and you know how, like, whom you can transfer the risk. So this requires a lot of knowledge, especially in terms of current security operations. Sometimes we don't know in which form we are getting the phishing email, or uh, if there is any other way so that someone else can access our system. Like, say for example, if we are opening some website online uh, that does not require any information, but just executing or just opening that particular website gives them the access, right, so that they can kind of access our system. So we don't like this may not be possible for all the scenarios. So next topic is our to design a secure cloud solution. So now we know, okay, these are the threats we have to mitigate. These are the risks we have to mitigate those risks. uh, and we already know that what are the data, and we already know, you guys already know about cloud environment, that uh, service model, deployment model, and what are the essential characteristics of the cloud environment. Now, if like even after knowing the risks and threats, Now, if user want to deploy or use the cloud environment, then they need to find a secure cloud solution. Now, to get or to design a secure cloud solution, how or what are the steps required? So to design a secure solution, we can we can divide this whole designing step in 5 steps. Stage in 5 steps. First one is design a secure data center. We need to design or define a data center which is secured. There are so many factors of making a data center secure. Then we have to consider the security controls for the data center. We have to consider the information rights management, how we can define and how we can implement this uh, for like on a per customer basis or per organization basis, or depending on uh, the operations that is performed by the user. Next one is design and apply data security technologies. So we have to apply something which is specific to the data only, and what are the strategies required. Finally, even after this, even after applying this, if there is anything happen, then how we can like recover, or what are the disaster recovery strategy if there is any risk actually happening in the system or in the cloud environment. So first one is design a secure data center. Again, so designing a secure data center can be divided into three separate phases. First one is uh, we need to consider, like, first one is the logical design. How we can logically think that, okay, this is the way we can define our system or our data center to be secured. uh, Second one is physical design. So in terms of physical design, what are the physical components that we need to consider? And next one is the environmental design. So in terms of what are the environmental factors that can affect the security, or that can affect the performance of a data center in terms of security specific operation. So first one is, when we talk about logical design, it allows us to separate users and manage them as well as resources assigned to them. So say for example, if we have an organization, the organization is using the cloud environment, or decided to use the cloud environment, and cloud environment give them an access. So they don't give a separate access, they give just one organization access. Now it is the responsibility of the organization, or manager, or whoever is managing the cloud service or cloud access, to divide that particular access among different users. So they have to define, for each user can access their own, or each user has their own access rights, so they can access the cloud environment independently. They don't None of the employee want that what information they are accessing to be known to be by the other people. It is one of the key component of cloud security. Second one is access control. Now, even if that particular manager provides or gives each user an independent access, but if everyone has the same access, they can access the like collective information or common information, which we don't want. Say for example, in an organization, we have some employee, we have some developers, we have manager, we have some IT person, we also have some person like auditors. So auditors have access of all the employees work, in terms of they have some chart where they are kind of auditing and telling that, okay, which employee is working good, which employee is not working good. Auditor doesn't want that particular information to be visible by other employee at initial phase. Similarly, manager has kind of access of all the like basic information. They have all the employees uh, personal information. They also have kind of partial information about the auditor, that okay, what auditor is doing, or whether auditor is doing correctly or not. But they don't have the very detailed description about each employee. Each of the employee, they have their own environment where they have their code. they have their personal information, and some of the information, like company specific information, like a fixed calendar invitation, or when some meeting is happening and something like that. So in terms of that, it is very important or necessary to divide the access in such a way so that each of the tenant or each of the component of the organization have their own access right. So that's why we need to consider the access control in such a way, so that manager has the kind of wholesome access of the whole organization, like almost whole organization. Auditor has, again, auditor has all the auditing information. They don't have the salary account access. They don't have the code access, what each employee is coding and all. Employees has their own environment where they have their personal information, their coding information, and some of the physical, some of the generic information. So that particular access control need to be defined very strictly. uh, Not following this particular scenario can lead to a lot of problems and issues in the organization. So next one is in terms of physical design. So in terms of physical design, we need to consider where we are kind of setting up our data, where we are setting up our data center, including the space, resources, location. We don't want the data center to be in location where it is prone to either earthquake or flood, or even heat. We also need to consider uh,
Just a quick info, guys. Test your knowledge of cloud security by answering this question: which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
where we are if we are not owning our own land, or if we are not owning the building, then what is the cost, what is the time, how are we maintaining our resources, uh, who else has the access of that particular building and all in terms of acquisition. So we need to consider this physical design when we are considering to create a secure data center. We also need to consider some environmental factor in terms of temperature, since heating is one of the most energy uh, consumptive like money related operations in a data center. So we need to kind of maintain our server's temperature. We also need to consider how we are managing the air management, we don't want the whole server room to be filled with hot, so that anyone who is coming for patching some of the network related operation, or someone who is kind of checking the uh, single server is just got hot. We have to consider the heating, ventilation, and air conditioning, as well as the network connectivity. Again, since all the servers are connected via network, so we need to consider the networking to be very strong, uh, soundproof, so that uh, even if we have any issue with the basic network, we need to have one supporting network, so that if, say for example, if our network cable got destroyed somehow because of heat or something, we have a supporting network associated attached to the system, so that uh, if one of our network got lost, we can access the system via some other network cable. uh, Also, it is not always in terms of wired. We also need to consider some wireless networks, so that the system can be accessed not only from the organization, but also from inside the cloud data center. Also, it is very important that there is some mechanism in terms of connectivity, so that so that the performance of all the systems executing in the data center is known to some server, so that any fault can be localized, and some necessary actions can be taken on time. So our next one is design and plan security control. So how we are controlling and like how we are designing security control of a cloud infrastructure. We can divide into 5 categories. First one, as we discussed the previous challenges, we can again come here. Physical and environmental protection, how we can protect in terms of like just where our server is running, and what are the environmental effect that we need to set up. In terms of system and communication protection, how we can protect our network communication, how user can access. In terms of virtualization system, so here what you were asking previously, that even if our resources are virtualized, how we can protect our virtualization system. Also in terms of identification, authentication, and authorization. Finally, do we add some audit mechanisms, and if we are, then how we are controlling those, the result of the audit, and how we are incorporating them for performing the security related operation. So starting from the first one, physical and environmental protection. There are several ways which we can protect our system, such as data center includes its building surrounding. So for example, first one is in terms of security. If you are running your server or running your cloud in a building, then you need which people are accessing that particular building. uh, is there any way someone just kind of tailgate you, or the employee who are getting in the server room? Is there any way that can control the electricity, the heat, the network of that particular server? Also, there are some regulations in terms of like HAPAA, which is Health Insurance Portability and Accountability Act. There are this like CIP, which is Critical Infrastructure Protection. Uh, what are the protection mechanisms specified or defined for this particular environment or this particular cloud? This PCI DSS is payment card handling. Sorry, payment card handling uh, data security standard. So, is these regulations followed by that particular data center or not? Also, if someone is accessing, so say for example, if someone lose their card, using that particular card, can someone enter? uh, if that can enter, then the building is, although the building is secured with the card access, but it is not very secured. So sometimes they have to add like multi-factor authentication in terms of how they want them to access. Again, multi-factor authentication is in terms of like biometric, or is in terms of some app based or mobile based, taking the token or taking the code on their mobile phone, or email. Again, email, if that is email, then which email, like the general like Google Mail or Yahoo Mail, or their organization specific email ID, which requires another level of password, so that requires like 2 level or 3 level. So these physical and environmental protection need to be considered before designing any cloud data center. Again, I already talked about electricity feed, that we need to check whether the electricity feed are continuous, or is can it be like interrupted by someone, because if the electricity is coming from the the electric pole, which is a little bit far, then is there any possibility someone is kind of, they can handle and they can cut the wire because of any other issue? Similarly, for cooling system, whether it is cooling, what is the substitute if the fan got interrupted or fan got damaged at any particular period of time? uh, so to monitor this, we also need kind of some cameras installed everywhere, or some other kind of IoT devices installed with, like, say for example, fan. So we can monitor the fan. If the fan speed is going down for like 10%, then we can think that okay, this fan is like, in future it may go and get bad. Again, network cabling, I already talked previously that network, since network is one of the most important parameter for the cloud environment. So we need to have some way so that there are multiple network cable attached to the system, so that if one cable got fired or got cut or got damaged, then we don't interrupt our system execution. uh, Also, in terms of staff, we need to check the backgrounds, whether if they are hiring someone, whether that particular person is uh, has some criminal background, or that particular person can steal some of the hardware stuff, which are very expensive in terms of server. Not only that, is there any special security awareness required for the employee who are executing or who are running those particular server or not? So if required, then we have to provide those special trainings later. Next one is system and communication protection. In terms of system and communication protection, we can define like three groups. First one is automation. Then automation define like how to automate the system, which in multiple cases kind of reduce the errors or problems which is generated by the user, especially in terms of security. Second is responsibility. Who will be responsible if something get bad, or how we can define the responsibility. Okay, if something is happening, then uh, okay, this is the person who is responsible for everything. Next is data lifecycle. So we already studied about the sixth phase of data. Now now all those six phase, how we consider, okay, our data is secured at all the time or not. So let's discuss with automation. So automation of configuration allows for a more granular control over changes. So if there is any changes happening, uh, and if user is like attached with that particular changes, it may be possible that there may be sometimes that user kind of misses to log some information, or misses to add some flag at some particular period of time. But if it is automated, then any of those event or operations can be logged properly, or any of the flag can be easily flagged if that particular operation happens. In terms of a time, if it is automated, it is very fast, so that any response can be instantly made whenever the that particular operation or that particular threat or whatever is happening in the system. So automation is considered to be one of the most important operations in terms of system and communication protection. Next one is responsibility. Again, I think we already had discussed a little bit about this, that what happens if the government change a rules in terms of governance. What happens, and who will take care of the risk? What happens, is this customer's risk? So again, this is one of the biggest kind of factor. So depending on the application, sometimes some of the responsibility is for the user, some of the responsibility is for the organization, and some of the responsibility is for the cloud service provider. um, like when a user is accessing an organization data, then it's the responsibility of user to kind of enable multi-factor authentication. Not only that, store their password securely, try to have their like multi-factor authentication way. Say for example, if this is mobile phone, they want to have those mobile phone with them, or in their belongings, in their, they don't want to lose those multi-factor authentication based device. If it is an organization, then organization need to consider that they have multiple locations for their data, for their clients data, or for their users data or customers data. uh, if they are storing in the cloud, they need to consider whether they are sending all the data to the cloud, or they are considering the say for example, this GDPR rule. They don't send all the data to the cloud, they are saving some of the personal information in their own local data center, and sending the remaining data to the cloud by anonymizing or masking, which we will discuss a little bit later. uh, so and in terms of cloud service provider, they need to provide as much security as possible, as defined in the SLA contract. They need to consider everything to be satisfied, or they also want to kind of provide as best service as possible. So there are some other third party monitoring environment or third party monitoring organizations available, like uh, ISA organizations, that like International Security Alliance. So they kind of provide some questionnaire that each cloud provider has to answer in terms of these factors, whether it is satisfied by each cloud service provider or not. So that's how we can kind of divide the responsibility. So it's not just the user's responsibility, or it's not just the cloud service provider's responsibility. It is the responsibility of each of the individual entity to take care of their particular belonging or their particular tasks which is assigned to them. Next one is data lifecycle. So we already know the data lifecycle. Data can be created from creation till their deletion. So during from creation till deletion, data can also move in different ways. So sometimes if the data got created and then stored in a database, or in an ephemeral storage, uh, or any other like hard disk, so that time we consider data in a rest. So in that particular case, we can kind of encrypt our data, and if the encryption is strong enough, like SHA-256 or SHA-512, then we can consider our data is kind of secured. If uh, someone else doesn't know someone else doesn't have the password. Also, there are some trusted mechanism provided by the system in terms of like trusted platform module, where you can encrypt your data, but you don't have the it can be decrypted only on the system, that we are going to discuss in next lecture about the trusted platform module. So it's easy to kind of protect the data when the data is at rest. Second one is data is at motion. So data in motion is that data is transferring, data is like moving from one device to other device using the network. Also, it can consider like data can moving from one one service zone to other service zone. Say for example, if you are accessing some data from Facebook, then you may have like your server uh, maybe in Silicon Valley or somewhere in US. It may not be possible always, but in some cases it may be possible. So we have to consider that if the data is in motion, then how you are controlling or how you are protecting your data. So data protection in this scenario is via different kind of network protocols. So you have to specify that, okay, which kind of network protocol we are using for our like communication scenario, and how our data is being handled in the network. Is someone kind of uh, in the middle, like man in the middle attack, who is kind of listening to our data, or they want to do some replay attack later on. So we have to consider all these scenario. So even in the communication, we can kind of encrypt our data and send it the or use the network. And again, if someone doesn't know the decryption password, then our data is kind of secured. Finally, third one is data is in process or data in use. So like manipulating the data to perform or to achieve some of the operations. So in this case, although there are some techniques which we can like process our data in the encrypted form, but that takes longer time. Also, in some of the scenarios, it may not be possible to perform all the operations when our data is kind of encrypted. So in this scenario, we have to kind of rely on the infrastructure, whether it is cloud. Especially in cloud environment, we have to rely on the infrastructure. We can consider some kind of like web service, or we can consider we can define some digital signatures for that particular server or services. Again, digital signatures are not always safe in terms of which kind of signature authority you are considering. If the signature authority is generally available, they can generate self-signed certificate, which is available in some scenario, but which is not good for or secured for all the scenarios. So we have to consider uh, how we are processing our data. when our data is in use. So this is the most important a factor for the data, how to protect our data when our data is in use. There are a lot of research still happening how to protect the data in use, as encryption or certification may not help all the time. Next one is virtualization system protection. So again, since in cloud environment, all the resources which we receive are in terms of virtualized. So it is one of the most important but most overlooked security aspect. All virtualization components such as compute, storage, and network are by the management plane, which is managed by the cloud service provider. Uh, if there is any issue happening at any of these, like compute, storage, or network, we need proper alerting and auditing of these actions. Uh, we also have to consider some specific security considerations, as like affecting the hypervisor or affecting the virtual machine which are executing on top of that particular hypervisor, can lead to the problems for not only one VM but all the virtual machine uh, which are running nearby on the nearby which are running on the same server, as sometimes attack may sometimes the security issues like such as worms or viruses may affect some other server, some other virtual machine or virtual environment executing on the same server. So for virtual, here we need to consider some virtual network security. Sorry, I got some question. In terms of virtualization system, we also have to consider some good image quality. If we are using some image, also we have to consider the most updated or most updated version of the virtual machine, which has good patched network, and which is kind of free of any network related or system related issues. We also can attach some of the extra, like auditing mechanism that I'm going to discuss next, to kind of monitor what is happening with our virtual machine. So here, before discussing this identification, authentication, and authorization, so these three are the kind of main ways to access the resources, but it seems very linked but not the same. I'm giving another example. Say for example, you want to travel to some country like abroad. So now you want to travel. So what you are doing is you already purchased ticket, you have your passport, you have your visa and everything. Now you are going to the airport. So on airport they will check your passport first. So passport is your kind of uh, all the information which is written on the passport, like your name, who are you, where you born, your address, and everything is your identification. So now you identify yourself as your name. All those information belongs to you. So that's how you identify yourself. Now authenticate. So your passport, since you are having or you are holding an Indian passport, so the passport, the thing is, how do someone know that, okay, you say that I'm saying that I'm Devki, but how do someone else know that I'm Devki? So they need some kind of authentication, that okay, someone they trust, or someone whose trust is already known to everyone. So what is done is that, since you are holding an Indian passport, and the stamp and everything on the passport kind of authenticate that, okay, you are you are who you are saying. So that's way your identification is kind of verified. And then you have a visa. So say for example, you are traveling to Singapore. So you have a Singapore visa. So Singapore visa is the authorization which allows you to travel to the Singapore. So that's how, like, identification is all the information which is written in the passport, or if you are in terms of cloud, so all the cloud like access information you have is your identification. Authentication is like when you enter your information like email ID. If you have a like organization email ID, so at a rate of organization.com is your authentication. So they check that, okay, you are who you are saying, or whatever. Like if you're using Gmail, so they trust Gmail. So Gmail is kind of authentication. And then authorization is that if you are an employee, then you can access the employee database, or you can access the calendar, like shared calendar. But you can't access all other information, or you don't say, for example, if someone has a visa for travel to Singapore, they can't travel to Malaysia, or they can't travel to Europe, any country like Spain. So that's how it is different, like identification and authentication and authorization. I think it's clear. Okay. So there are several aspects of, sorry, I got some message. There are several aspects of identification, authentication, and authorization in cloud infrastructure. Cloud, these are like, question is like, when you have the passport, how do you manage, like, uh, how do you manage the authentication? How do you manage the identification? How do you manage the authorization? Mm, how to make the access decision? How to manage the identity and access management? Also in terms of how do you account for resources? So these are the six important factors in terms of uh, IAA. So first one, in terms of managing identification, this involves creating and asserting validity of an ID or a token. Say for example, when you want to create your passport, then you need to provide information. You have to fill an application, you have to submit your documentation to say that, okay, this is how, like, this is what I am previously, with some of the information, like basic information. And then it will create an ID or token, which is kind of valid. Next one is managing authentication. There are several ways of authentication, especially in terms of when we, if you go for passport, then they provide the passport, then they check your previous validation, check your like degree certificate or birth certificate, and then give you the access. In terms of cloud, previously it was like basic login ID and password, which was not safe. Then we can create kind of more specific in terms of like MFA, multi-factor. So they always kind of, you have to provide your email ID, password, then they will send you a message, and then you have to provide again, either if it is a code, then you have to provide the code, or if it's a app based, then you have to kind of tap on the app with your biometric, either thumb or your picture. So sometimes it's random, like sometimes they ask for OTP, sometimes they may not ask for OTP. But if you're using some specific secured application, such as banking based application, they always ask for OTP. But if you're using GitHub, then they, most of the time, they ask for password. But rarely, like at random, they ask for you, they send you that, okay, validate using your either email ID or your phone number. So they send you OTP on your phone or your email ID, and you have to type those OTP. So next one is managing the authorization. So in many organization, authorization is performed using a federated identity model. So again, if you have visa, then you are kind of identified that, okay, you have this access. In terms of a company, they already have the background model where it's defined that, okay, this particular user has access to this particular resources only. If you want to access the banking detail, or if you want to access some customer data, especially in terms of personal information, you don't have access. So this is implemented in the background side, uh, where uh, where this authorization is defined in terms of accessibility for each of the employees or users. And then we have this accounting for the resources. It measures the resources, sorry, measures a resource, the resources a user consumes during the access. That includes like billing, trend analysis. So now, in especially in terms of cloud, this is very important that we need to know how much we are analyzing, because cloud uses this pay per use basis. So we can get the bill, get the trend analysis. Cloud also uses these information for providing resources in the future. So they already know your current uses as well as your past uses, and they will predict the future uses. So sometimes even if you are accessing uh, like 16 GB VM, uh, 16 core VM, and based on your previous uses, if it seems that you want like 32 core VM, then cloud automatically like enables your system on a 32 core system, so that like when your user or when your use increased, it instantly you can easily kind of scale up without even changing the virtual machine. So it all depends on your previous uses and how resources are accounted in the cloud environment. Next is this managing identity and access management that we are going to discuss a little bit later. That how we are registering, how we are provisioning and deprovisioning users to allow their identity check, like identification, authentication, authorization, and how much access we are providing for each of the user. So one of the manager, they can specify, IT manager can specify for each of the employee depending on their requirements. Finally, making access decision, like again this is somehow linked with this IAM role that allow to make a decision that okay, which user is going to access which resources in terms of control matrix, if how much permissions we are giving, or what time permission we are giving. Sometimes it's time oriented, sometimes it's space oriented. Like sometimes we ask or we give employee to access the resources only uh, from the office device. Sometimes we allow them to access from any device, but they have to use the VPN, and VPN is allowed based on the IP address of particular network, a network based location. So all these are required for defining this access decision making.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
Again, when we are using all these information, then we have to audit. Again, I previously also said that it is very important in terms of security to know if our system is in the right state or not, or not only that in terms of security, but also in terms of performance, if our system is performing correctly or not. uh, like in terms of security or in terms of performance, it can happen only by auditing.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So if we are monitoring our system continuously, then only we are able to know that the system is in right state or not. It also allows like transparency and assurance. If auditing can be happened or can be performed by the organization or by a third party which which is trusted by uh, all the components like customer, organization, and cloud service provider. Uh, it also kind of assures that the service level agreement is satisfied while while considering the quality of service parameters or quality of service requirements. It makes sure that security and other requirements are being met. And if it is not met, then at what time or for how long the service is unavailable for the users. It also makes sure that the regulations are being compiled all the time in terms of like GDPR or any security rules depending on the location of the country. uh, so how the question comes is how to perform the audit. So auditing can be performed easily depending on the logs, like system log, reading the system log continuously, or capturing the network packet. uh, so these are the kind of metadata information that got generated whenever any operation is performed on the system in terms of success, warning, error, or any time. It also captures or stores uh, login is performed at what time, who accessed the system, or who entered the building. Uh, if someone else entered the building, what is the uses pattern, and using all these information, it can be used to kind of deduct whether the system state is secured or in future is going to be secured or not. In terms of packet capture, it also kind of interrupt the network and captures the packet. Recently, there are some new technique in terms of extended Berkeley packet files are available uh, that captures the network, or that captures the system performance without affecting the system performance at very low level, especially at the hardware level. uh, those information got captured, and that can easily be sent to some web application for easy visualization. Although although we can audit these mechanisms, but untrusted auditor or unsecured auditor may leak these information, which can create or increase our uh, security framework or security based environment for some of the cases. So we need to be very specific to choose the auditing mechanisms and to choose the background information and auditor for our services and cloud environment. Next is design and implementation for the information right management, which is also known as IRM. This is again one of the most important ways to kind of restrict the access for each of the user uh, or customers of the cloud environment, especially for an organization. Uh, when the organization is accessing the cloud, one of the IT manager can allow the remaining employees, or they can allocate the resources to each of the employee while controlling the access rights in terms of security, sorry, in terms of resources, in terms of visibility, in terms of accessibility. IRM can be yeah uh, it protects the sensitive information from unauthorized access. It can be defined, or it can be understand in two ways. First one is objective. What is the objective behind behind IRM? And second one is what are the tools for using the IRM. So in terms of objective, it kind of protects the data right. It gives the data right. Data right give people authority over their data. So their data is so they have the access to their data, and they are responsible for their data. So if anything is happening with their data, that particular person's data, it is their responsibility. It is not it does not belong to the organization or the cloud service provider. In terms of provisioning, using IRM, we can easily provision the resources to different users. Also, it allows the access model. So any access model defines users can access the data based on factors such as roles, as I already discussed in terms of permission. If they have the IT manager role, they can access a whole virtual machine information. But if they can start, they can create the VM. But if they have the access right only to execute the VM, they can't shut down or they can't delete the VM. They can only execute the VM by while running the application. The remaining access right belong to some other, depending on the type of application or depending on the scenario where this is executing. uh, Tools is it like specialized tools are used to issue cryptographic certificates which securely specify users identity and tasks that they are permitted to do in terms of so we can associate some uh, certificate to each of the resources, and we allow each of the user to kind of follow those certificates, and their access right or their identification can be defined by these certificates. These certificates can be provided by the cloud service provider or some third party, depending on the application and how the IRM is defined. We can easily like create a certificate. We can also revoke or a kind of deactivate the certificate either for some time or forever, depending on the requirements. Also, the certificate can be replicated. Say, for example, if we are running our application on one server and the server got crashed, or there is an issue in the server, or their requirement increased. So we have to kind of scale up their virtual machine. So in that particular scenario, we can replicate their certificate from one machine to the other machine, and that's how we can so using IRM we can easily perform that. So the next small section is design and apply data security technologies and strategies. So here we talk about the data security specific issues. So data security is to secure the data. The simplest way is to encrypt the data and hold the key. So we have some plain text. The data which is generated or which is available from the customer or user is in the plain text. We want to apply some encryption algorithm to convert the data into some ciphertext. The algorithm uses a key. Now the key is depending on the encryption method, whether it is symmetric encryption or asymmetric encryption algorithm. We have one key, or we have like public key and private key. Public key is available to everyone, while private key is specific for the signer or for the authenticator. The data can only be decrypted to the plain text again in if that particular machine or that particular entity has the key. Again, in terms of hashing, if the data is too big to handle or to save, then we kind of use some hashing mechanism. Hashing mechanism, just we pass the data to a hashing mechanism, and we create a hash. So we can easily access the data using that particular hash. Again, hash cannot be converted to the data, so it's considered to be very secured. Even if someone know the hash, they can't access just the data, because they need the data to be available. We can implement some security parameters to hash. See, for example, just encrypt the hash rather than encrypting the data. So even if someone has the data and the data is so big that it's hard to get some of the, like, some particular information from the data, so using the hash we can so someone who has the hash as well as the key can only access some part of or useful information in the big data. Other people, they can't access the the useful information. The other thing is masking. I think we all know about masking. Is that in terms of masking, is that to kind of limit the visibility of some of the information, especially in terms of email ID or pass or telephone number. When we save our data in the database, some of these values are masked. Now this masking can happen in some specific ways. So there are multiple algorithms for masking these information. These masking can kind of protect the data from the commercially sensitive, especially when we are typing our bank account details, when we are kind of ordering something online or buying a pizza or something like that. Then if we are providing our bank, like our email ID or other information, most of the time some of the information got masked, especially in terms of bank detail, like first digit or last digit is available, remaining all the information is masked. So that is also very important strategy for data security. Address the disaster recovery. So what happens if there is any disaster? If there is any disaster happen in terms of either physical or or in terms of like system failure or any other issues. So we need to pay some attention on what happens or what should we do if there is any disaster happens. So we divide the disaster recovery in two parts mainly. One is on premises and other is in cloud, or we can say in public cloud. So when we have this on premises infrastructure, then we need to consider that uh, how the risks is like higher or how the risk is lower. Similarly in cloud, whether the risks are higher or whether the risks are lower, or how can we handle the most important considerations or most important parameters of risk when we are executing in the cloud. So when we talk about on premises, then say for example, if you have your own private cloud or server, then there may be cases when some failure happens, like server failure, when there is a breach happen in terms of your machine got lost, or there is a possibility that there is no electricity. So to consider those things, we need to consider some alternative providers. Say for example, if we have one server, or if all our server are at one location, then we may need to consider that our server or our copy of the server is also located at some other location, at some distant location, so that if there is any environmental or human made kind of risk or disaster happens, then we don't kind of shut down our whole server center, but we can provide, or we can allow the uses of resources and the application deployment from our other location. We can also think about kind of using from physical to virtual. So if one of our machine got a damage, or if one of our machine is not working properly, then we can kind of migrate our application from that particular machine to some other machine. But if we are not executing in the virtual environment, like either virtual machine or container, then we can't migrate our application. We have to restart our whole application from scratch, which is time consuming, and also we lose our information and data if there is a server failure is if there is any server failure happens. We must also need to consider what is the speed of recovery. See for example, if you are already running your application in a server, and if there is any loss, although you can restart your server, and you can reach that the same state, but it may take some time, especially if you are running some web application, then the server failure or downtime is very effective and costs a lot of money for the application provider, or the web application uh, server, who are getting revenue and money depending on the execution, application execution, or user interface. So if your user interface is not working at that particular period of time, there are a lot of users who 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 just leave without taking the service, and they may never come back to use your services. In terms of in cloud, we can consider like a primary disaster recovery, or we can consider an alternative disaster recovery. In terms of primary disaster recovery, it includes the steps which need to be performed on the cloud when your application is where your application is currently executing. Say for example, if you have all your server in one region or availability zone, and sometime what happens that in that particular region there is some failure happen, then you need to consider how you can restore that particular applications executing in, especially in that particular availability zone. So to consider this, if you're again similar to the on-premise system, uh, if you are executing your application, or if you have a copy of your application in different availability zone, then if there is any outage in one availability zone, your application will not get affected, especially at least too much. You can start working on some other availability zone in case of any failure. Second is in terms of provider. Sometimes what happens that the downtime of one provider may lead to loss of your application. If all your application is executing only on one cloud service provider, it may be possible that the cloud service provider monopolize the price in terms of VM execution, or in terms of network providing either download or upload. Sometimes they kind of limit the upload and download limit, so that your application becomes very slow when you want to access your application in cloud. So to avoid these things, it's better to consider multiple cloud service provider rather than executing on just one cloud service provider. Also, since we can't control the applications executing in cloud, so it's better to have some load balancing functionality, which can kind of check uh, whether your application is getting proper resources or not. If you say, for example, requested for a 6 core machine, they said, like, cloud service providers say that, okay, they are providing 6 core machine, but sometimes they provide you at sometimes they don't provide you 6 core machine, especially if your uses are not up to 6 core, if your application does not require 6 cores at any instant of time. What they does is they kind of increase the amount of resources provided depending on the increasing or decreasing requirement. So that also need to be considered in if you have a load balancing functionality, then you can properly check that, okay, if the load is increasing, just increase whether the cloud is increasing the resources in an elastic manner or not. Finally, we also have to consider some regulatory reviews. So say, for example, each country applies or pauses some of the border specific rules that is specific to only that particular country. Like in Europe, they have this GDPR, which allows or which prevents the saving and storing the data, especially personal data of European people outside Europe. But some of the applications they don't consider, especially in terms of uh, copying the data at different availability zone. uh, this may not happen, so they have to consider, uh, even in same zone, they have to consider how do they save the data, or how do they handle the data, so that if there is any disaster happens, the user's data may not got lost completely. In terms of alternative disaster recovery, it includes steps to perform how we kind of move our workload from one cloud provider to a different one. Usually, this is not a general case, because uh, especially if you are working in a big company, or when there is a big company you want to deploy their application, they kind of make a contract with one cloud service provider that, okay, I'm going to execute my, like, all of my application on this cloud service provider. And now just tell me how, like, what are your rules, or when they kind of make a contract, especially in terms of service level agreement, cloud service provider give them a lot of benefits in terms of reduced access price, fast recovery, or reduced downtime, fast higher network speed and all. So they are like, the application or the company is bound to the rules which are specified in the service level agreement provided by the cloud service provider. So it is very hard to kind of break that particular break that particular SLA, or break that particular contract and move to some other cloud service provider. So they need to consider some recovery technique, that, okay, what happens if my application got some downtime, or if my service level agreement, especially in terms of uh, network uh, network access time, or service downtime, what happens if any of these happens, what are their strategy, or what is the cloud service provider strategy. So these need to be considered before actually deploying, or before making a contract between the client or company and the cloud service provider. Also, it need to be reviewed, not just depending on functionality, but also depending on uh, some future based risks, which is not at least known now, but which may be not which may present or may be available in future. It also need to consider some we also need to consider some portability and interoperability. Sometimes what happens that if our application is specific to Amazon cloud service provider, and we want to deploy the same application on Azure or Alibaba cloud service provider, uh, the basic environment provided by Alibaba and Azure is not exactly same as it is on Amazon cloud service provider. So we kind of make our application in such a way so that it can be portable and interoperable between more than one cloud service provider in case of any disaster if happens in future. So if you define trust, it is the kind of Oxford Dictionary say that it's a firm belief in the reliability, truth, or ability of someone or something. So it's a belief. So if you say it's belief, is it a psychological state? So say for example, you believe that someone believe that Earth is flat, or someone believe that Earth is round. So is that a belief? Is it a like kind of who are true? Whether it is Earth is flat or whether Earth is round. There are so many people who still believe that Earth is flat. Uh, Second definition say that it's a acceptance of the truth of a statement without evidence or investigation. So you don't have to do any, there is no evidence available and there is no investigation or experiment. uh, then since actually is there no evidence to kind of trust or to say that okay, this is what this is. Say for example, this is computer, I say this is computer, but someone else is saying no, this is not computer. So is there any evidence to say that this is computer, or is it just kind of random? Okay, someone is saying that this is computer means this is computer. So these are some of the definition that this is provided by trust. But what is actually trust? What is trust? So so now we can define trust in multiple ways. So usually we can define trust in terms of computational trust, or we can define trust in some other way in terms of like relational trust. So we so how do you trust someone, or how do you trust to use? Why we are discussing trust is because why we are discussing trust is because when user is kind of offloading their application for storage or computation to cloud, uh, should we trust, or do you think we should trust to cloud for our data, for our application, or for like generic in terms of application everyone is using nowadays, like Facebook or some other social media such as WhatsApp or Instagram or Twitter. So is it okay to use those application, or is it we shouldn't use those application? So we can define trust in terms of computation. So say for example, the opinion to buy a bad product. So one time you went to Amazon and you ordered a laptop. Later on, when you start using the laptop, you felt the laptop is not from a genuine company. The laptop is bad, or the delivery takes very long time. So based on your operation, or your interaction, you make a kind of belief that okay, uh, the product I bought from Amazon is bad. Now some if someone talked to you, then you can say that oh, I bought one time on Amazon and the product was not genuine. So next time if you want to buy, you will try not to go to Amazon to buy similar kind of product or some other product. But again, second time if you kind of by mistake if you buy and you felt that next time you bought, to say for example a headphone, and the quality of headphone was very good, the delivery was fast. So now you have a mixed opinion. You can say that okay, although first time it was not good, second time it was good, again third time again, following the first two instance, you again went to Amazon and bought another product, and third time the product was not bad. So now you have a kind of mixed opinion. So sometime it can give you good product and sometime it may not give you the good product. So using your interaction and experience, you can tell to other people about your experience, and other people, if they trust you or if they kind of have a belief on you, they may utilize that particular uh, information or your interaction or experience uh, to make their own decision. So first one is like simple opinions are based on evidence. So since you bought your laptop, then you got to know that okay, Amazon is a bad service provider. Uh, if you have like if you bought for like 3 4 times even without uh, without interacting or without thinking about your previous experience, then for all 4 times if you got bad, then you kind of have a confidence that okay, Amazon is always bad, and now you are 100% uh, sure that the product that you bought from Amazon is bad. Although Amazon, I'm not telling Amazon is bad, I'm just giving an example. So don't rely on that. Second is like there are sometimes that there are complex opinion, like in terms of you talk to one of your friend who has a good review about a website. Say for example, I will not tell Amazon, I will say that ABC is a website. So when you talk to one of your friend, he said that ABC is very good website. I bought from there, the product was good, the delivery was on time. When you talk to your other friend, they say that no, my experience was very bad, the product was not good, and I didn't have uh, they didn't have a like refund policy, I want to refund, so I kind of lost my money. So you have to kind of merge those operations. Sometimes you have other thing, like in terms of uh, chain is you trust your friend whether trust or not trust the cloud service provider. uh, so we can kind of perform or apply or make some logic depending on different kind of opinions. So in computational trust, it is used to make some decision. Do we trust a party enough to rely on them? And how to combine with the how to combine this computational trust with security and privacy. Especially when we talk about privacy, it's not always uh, depending on like evidence. Sometimes it also depends on how you think whether your information is private or not. So it is like in one way it is also a kind of trust. So the motivation behind trust is that like kind of threat model and a chaining. So in terms of threat model, it is to what extent do we trust the cloud service provider. uh, Say for example, if you are interacting with the service provider and you already know that the service provider is compromised or cloud service provider is bad, then it's pointless to add any encryption or like end-to-end encrypted communication, because you already know that the other end is already compromised. So trusted is a kind of opt out. You can't force trust on anyone. It is uh, you have to have some trust to use. Otherwise you can't use.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Next, in terms of chaining, so user may trust the cloud consumer. So uh, if I am a user and I kind of want banking service, so I trust State Bank of India to deposit my money. Now State Bank of India is how State Bank of India is using my money, that because I trust Bank of India, so I'm kind of satisfied that my money, which is in State Bank of India, is always safe, and whenever I want, I can withdraw that money. I'm also getting some interest on my money. So I have my trust in the State Bank of India. Now, how State Bank of India is using my money to generate more revenue or more money, that depends on State Bank of India and their investment. So State Bank, say for example, State Bank of India has invested their money uh, in uh, in some airline company, and if the airline company is in loss, then my money is so. So now it depends on, I have a I need to have a trust on that particular airline company, but since I don't know whether what is the airline company or where my money got invested, so I am a kind of consumer for the State Bank of India, and State Bank of India is a kind of consumer for the airline company where they have their own investment. So this makes a kind of chain of trust. Like I have to trust, talking about cloud service provider, especially in terms of company or industry. So I kind of rely on a company or industry for my data, and that particular company rely on cloud service provider, say for example AWS, for their data or process. Now, so in one way, I am kind of trusting the cloud service provider. So it depends. Am I trusting the cloud service provider or not? So in terms of what is the application is outsourcing computation, which is very complex. There are multiple parties needed to be trusted on different kind of things, uh, whether it is computation, whether it is in terms of service level agreement satisfaction, whether it is in terms of quality of service compromise, whether in terms of how many clients they have and how they are treating their client, uh, how many employees, or whether what are their what are their employees doing, how they are kind of saving our data in cloud service provider and all. Need to reason about referral and trust chain. So uh, sometimes what we does is we kind of consult the consultancy services for our application uh, outsourcing. So how much we are trusting that particular consultancy, then consultancy, how much consultancy is considering or trusting that particular another company, and that particular company is again trusting uh, the cloud service provider or some private cloud or server. We also need different type of assurance and experiences. uh, Today we will try to unify trust reasoning somewhat. So we kind of unify uh, in one way that okay, so there is a kind of unitary relation between me and the final and where the actual processing is happening. When we talk about on demand self service, decision to use a service are made on fly. Sometimes what happens that uh, if we are working uh, on a big company, or if we are working on, say for like what we were discussing previously in terms of scalability. So if our application requires more service or more virtual machine, at runtime it makes a decision to allocate our services or part services on some new virtual machine. Now we don't know so many properties about those virtual machine in terms of cloud service provider, the physical layer, what other services are shared by that particular physical server is another question. So computer must be able to reason about this, that on runtime, if my application is going to execute on some other virtual machine, then whether that particular virtual machine is on the same server or whether that particular virtual machine is on some other server. uh, in terms of security and privacy, whether my services are running in the same zone, or sometimes if the decision is made on fly, uh, then our server may be or our service or virtual machine may be started on some other location, other geolocation, which may have higher price, which may have a larger response time, or may have some outage and all. So we need to kind of make a trust based access control. So so we can define trust in many ways. So here I'm defining trust in terms of like two way. First way is there are two types of trust. One is functional trust, other is referral trust. So functional trust is consider an example of buying a bread. So Good Bread is a company. So Bob already have used the bread from Good Bread company, and he know that okay, yeah, the Good Bread company has very nice bread. So since Bob already have consumed the good bread, so there is a functional relation. So Bob can say that okay, the bread from good bread company is very good, while Alice doesn't actually used the bread of Good Bread company. She bought some cake of Good Bread company, and she felt, or she bought cookies from a Good Bread company, and realized that okay, the cookies are very good. So see, kind of imagine that since cookies of good bread companies are good bread company is good, it means uh, uh, there is a very good chance that the bread is of good bread company will also be good. So there is no direct kind of function, but indirectly C kind of assume that uh, good bread has very good bread. Second is in terms of referral trust. So now now if you see this, like in terms of Bob, uh, we replace Bob here with Chuck. So now Chuck already have a relation with something else, and Alice kind of trusts Chuck. Chuck is Alice's friend. So Alice trusts Chuck, and since she trusts Chuck, and then whatever Chuck trusts, if we again give the example of bread, so if Chuck trusts the good bread company, uh, saying that okay, good bread company has very good bread. So now since Alice trusts Chuck, so she can, like in terms of refer, she can also say that okay, good bread company has good breads. So in this way, like in this situation, since Alice has a trust on someone else, and that particular person is kind of referring that okay, do go ahead for the bread of trust bread company, good bread company. So in that way, so this is a kind of referral trust. This referral trust is very important when some company is outsourcing their application uh, for in terms of consultancy. So if you are like consulting someone, and that particular consultancy is saying that okay, you can rely on us. So your company, or you as a company manager or company head, is relying or has a referral trust on the that particular outsourcing company, which can uh, which allow you to use the services provided by some other company. In terms of other trust, there is a direct trust. Again, I already discussed about direct trust, that Bob already have consumed the bread, and that way he can say that the bread of good bread company is good. Alice's has consumed some cookies of good bread company, so she kind of rely that okay, if the cookies are good, then the bread will also be good. While in terms of compound trust is Alice have Alice kind of consumed the cookies of good bread company, while Alice also trusts Bob, and Bob is saying that the bread of good bread company is good. So now Alice can kind of combine her own experience along with Bob's experience to define trust. So this is again, this can be used for execution of your application in cloud environment, whether you are trusting any cloud service provider or not, in terms of direct or indirect or compound uh, trust chain. So now trust is defined like there are two component of trust. First one is like there are two component of trust opinion or any opinion. First one is how much you trust someone, and second one is how much is the uncertainty with that particular trust opinion, or uh, with that particular person, if you are considering the referral trust. So so you can define any opinion in terms of the percentage or percentage of trust as well as percentage of uncertainty. So if you are not very certain, again consider an example uh, of buying a product from a website called ABC. So first time you bought a product, and the product was good, so you have 100% trust, 0% uncertainty. A second time when you bought a product, the product was bad, so your trust become kind of 50%, and your uncertainty also become 50%. Third time when you bought, your product was good, so now your trust again increased to 66%, while uncertainty reduced to 33%. So depending on these two parameters, we always make a decision to kind of uh, make some opinion, or make some decision in terms of going ahead with the service or not going ahead with the service. Again, when we have this compound trust, so in this presentation, we are going to discuss more about compound trust, because this is the one we are going to use in real environment. We don't have direct trust or indirect. If there is any user, or if there is any application developer, they kind of or company, they kind of rely on some other company for their deployment or storage. uh, and that particular company may have their own deployment, or they again have a chaining, performing deployment on one server, performing storage on some other server, or some other cloud service provider. So compound trust is again divided into three types. First one is atomic trust. So in terms of atomic trust is source of direct functional trust. So here there is an evidence. So say for example, since Bob already have consumed the bread from Good Bread Company, so there is an evidence. Okay, he know that the bread I consumed was good. So there is a direct functional trust. Atomic trust is based on just one piece of evidence. If there is any piece of evidence available, it means there is a atomic trust available. Now, how do you obtain a trust opinion from evidence? Again, it depends on the representation of trust opinion. Depends on the domain, standard value for common event, or expert opinion for rare cases. uh, so say for example, if you have an application and you want to deploy on cloud, now now you are kind of considering someone who already have deployed their application. Second is, since your application is not a normal application, it requires heavy security, or it requires uh, like some specific kind of requirement. Then you can't rely on any user who already have used some cloud service provider. You have to rely on some expert who, or some user, or some expert user who already have deployed similar kind of application. So we can see them as an expert.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
Uh, Other than that, we also need to consider our own intuition in terms of uncertainty. So we can say that, okay, uh, what maximum can happen? What are the risks associated with with executing on this particular cloud service provider? So we have to combine these things, or we have to consider these things while making a decision on an atomic trust. Second one is merging trust. So you are a company, and you want to make a decision about deployment on cloud service provider. You don't talk to just one person. You talk to, like, you make a survey. You talk to kind of 50 people, and then you kind of merge your trust. So say for example, if E1 is an entity, has an opinion O1, and another entity E2 has an opinion O2. Now you can kind of merge the trust. So your opinion now relies not only on just atomic trust. Your opinion relies on multiple trust, uh, multiple entities trust. So if employee E1, or if entity E1 has an opinion O1 about some functionality of some company or organization, and some another entity E2 has similar opinion, have opinion O2 on similar kind of application, then you can easily kind of merge those, and you get an opinion. Again, it relies that, or it makes sense to merge opinion about the same thing. So for example, if you want to buy a bread, then you don't want to know that, okay, how is the coke of that particular company. You can maximum go to see that, okay, how is their pastry or how is their cake provided. But you don't want to go that, okay, how good is how good is their chocolate, or how good is their some drink or coffee prepared by them. So in terms of merging, if you see this direct functional trust is, so Paul Paul is a good baker. Steve think, because uh, Steve already have bought a lot of bread from Paul. Steve already know personally Paul. So Steve can directly say that, okay, Paul is a good baker. While we can combine direct and indirect functional trust is that uh, Alice uh, Alice has a direct functional trust in terms of this good bread company. Uh, in terms of cake or pastries she already bought, so she know that good bread company have a very good pastry. She kind of talked to Bob, and Bob already have consumed the bread. So she has a kind of referral dependency that, okay, uh, good bread company has good bread, like in terms of referral. Now she can combine everything, and finally she can trust that, okay, I'll good bread company has good bread. Now using the previous functions, she can kind of combine with some uncertainty and with some uh, a trust state to make an opinion that this good bread company has good bread or not. While just referral is uh, Alice is referred by Dan, or Alice trusts Dan. Now Alice trusts Dan in terms of because she has an interaction with Dan. She gave her book to Dan, uh, and Dan returned her book. She lent some money to Dan, and Dan returned some money to Alice. Now now these two are not very, although these two are not very dependent, but that is very good, or that can be linked together to make a referral trust between Alice and Dan. So she can say that I can trust Dan. Uh, now chaining trust can be, can also be kind of multiplicative. If the advice is, you can make a like assumption or opinion about the agent, whether the agent is good or not. In terms of chaining trust, this is the referring chaining. If the advice is true, then it counts as evidence, otherwise it counts as nothing. Is this always the case? This is not always the case. So sometimes what happens that if someone already told you that uh, that some agent is not good, or say for example, if we go to the previous example, say for example, Bob has very bad experience about Goodbread company. So Bob told Alice that Goodbread company has very bad bread. The breads are not good. But Alice already bought the pastry, and the pastry are very good. So now she know that pastry are very good, but she got referred by Bob saying that the breads are not good. Now she can kind of now it depends on her that how she want to combine uh, the negation of the good and good for something else. Now it again depends on how much she trust Bob in terms of referral trust. So referral trust is our trust that the advice is true. Now it depends on how much we are trusting our referee to make a proper decision. And in this time we are kind of using the multiplication. So we multiply our reliance on that particular person, and what he is saying to make a proper trust decision. This is it for trust. So now trusted computing. So before discussing about trusted computing, there are some basic concepts which need to be discussed, which I'm going to refer all the time. uh, First one is, what do we mean by secure? So when we say something is secure, it is defined in terms of three parameters. First one is confidentiality. Confidentiality is if there is anything which is secret. Uh, so say for example, if you have a document on your Dropbox, you doesn't want anyone to read your document or to access your document. So that is your confidential. That is yours, and you are the only one who can access. So encryption is one of the way to kind of make it confidential, but sometimes it may not work, because say for example, if someone has your decryption key, then they can decrypt your document. So that is that we are going to discuss that very soon. So confidentiality says that the document is confidential and it is kind of inaccessible to someone else. It is like, say for example, if I'm sending that is so confidential is uh, if you have some money in your bank account and you don't want anyone else to know that amount, that exact amount, so that particular amount is kind of confidential. Or if you have a certificate, that particular certificate is yours and yours only, you doesn't want to show to anyone else, for example. So you can say that particular document is confidential. Or consider a more realistic example. Say for example, if you have a VPN key or VPN password, so that particular key and password is yours and yours only, you don't want it to be made public to anyone else. Second is integrity. So integrity is uh, see, if a person A is sending a document to B, or if a person, yeah, if a person A, say for example, if I'm sending a document or a file to someone else, then that particular person will also receive the same file, what was expected. Not there is no change happen in the middle. If I'm depositing 100 10,000 rupees in bank, and when I, like, later on when I'm checking my bank detail, I can see there is 10,000 rupees available. It will not change by any means. uh, the good thing or bad thing here is trusted computing focuses on the first two. Like, it will provide the confidentiality and integrity at a cost of availability. So to restrict the availability, again, restricting the availability, it is not just removing the availability. So it has restricted availability while providing the confidentiality and integrity. So other important feature or basic term is freshness or nonce. So we often want to be sure that the data is fresh. So sometimes what happens, we are uh, we are like, I transferred some amount to my bank, and instantly I will see that okay, um, my money got deposited, and uh, it is available whenever I check, whenever I check online my bank detail. uh, we don't want that it is old data, because old data is has some issue. uh, this is very important when we are kind of performing some operation in the cloud. So if you are accessing your virtual machine, uh, and you have a secured, like, key based access. So when you're trying to access your virtual machine, then there is some way so that it will check that okay, this is you only, because if there is any freshness allocated, then it knows that okay, uh, you are the one who are accessing. Giving some other example, uh, if there is any like man in middle who want to access the cloud, uh, although it got your key, but uh, uh, it doesn't got your key, it kind of, you have a kind of OTP based access. So you are kind of accessing your virtual machine. You got an OTP, and that OTP is now public, not public, it got leaked somehow. And you already accessed, you closed, and now your access is over. Now that particular OTP is known to some third party, and that particular third party want to use the previous or old OTP to access your virtual machine. Now if that is if that is if this freshness is not allowed, then using the old OTP, cloud virtual machine can give them access. But since there is a freshness added to that particular OTP, uh, cloud will check whether is this the recent OTP or is this the old OTP. Since that particular OTP is old, the access to the third party, which are malicious, is kind of restricted. So that's how we need to consider the freshness. Again, nonce is the major way to kind of provide freshness. So what is nonce? It's nothing but freshly generated random number, which need to be unpredictable. We can't predict what is the new nonce getting created. So nonce generator knows any message containing their nonce was created after the nonce. So say for example, if you are accessing your bank account for like performing some operation, you get a OTP. Later on, you want to do some more operation. You kind of logged out, so you already know that, or the nonce generator, like bank, they know that this is the new nonce. So there are some ways there which know that, okay, this random number is newly generated random number rather than the previously generated random number. It allows locally verifiable confirmation that remote activity is current. Timestamp aren't verifiable. What happens with timestamp? Usually, initially, people thought that timestamp is very good because we can provide timestamp and it is very verifiable. But first thing is timestamp anyone can predict. Second thing is in the current scenario where people can access the services all across the world, a timestamp at different places are different. So it is not always valid in it is not valid in all the cases. So we need a kind of random number. Now, how we are generating random number, how we are accessing this random number, that we are going to discuss uh, in in few moments. Uh, the next one is cryptographic key. I think everyone know about. There are two type of cryptography. One is symmetric key. Symmetric key is used for both encryption as well as decryption. There is just one key. There is the other is asymmetric key, where we have two type of keys. One is used for encryption, other is used for decryption. Uh, so if someone has only encryption key, it can't decrypt. So they need to have decryption key. The IBM Cloud claims they are different. Other cloud vendors provide operational assurance, means we won't access your data, but IBM provides technical assurance, means we can't access your data. Good white paper explaining confidential computing. I agree. IBM Cloud also provide a lot of different features in terms of uh, how, like in terms of resources. So I used IBM Cloud for one of my work in in the past.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
It's very fast because there is just one key. It is very good for bulk operations. So if we are performing, or if we are kind of encrypting a big chunk of data, then it's good to use symmetric key. Advantage is the key distribution. How we are distributing the key is not defined well, and it may create a lot of issue. Uh, Second one is asymmetric key. So again, here we have a public key and a private key. Public key, there is no security risk, while private key must be kept secret. Private key is used for sign decryption, signing. Public key used for encryption verification. Great for proof of identity. If we want to check the identity proof, then this is very good. If someone has the decryption key, they can verify themselves. If they don't have decryption key, they can't verify themselves. Although it is slow to use and not very good for bulk operation. If we want to kind of sign or encrypt very bulk data or very frequent, it takes time and is not considered to be good. RSA is the most common public key algorithm in use now. Next one is hash. So hash is again it's a one-way function from arbitrary data to fixed length. It's easy, like critical. There are some property of hash. First one is it's very easy to compute or calculate. It's infeasible to construct data from hash. Reconstruct. So if you already know hash, you can't create a data. What is the data? Infeasible to find collision, different data, same hash. Very, very rare. There are different hash algorithm in terms of SHA1, SHA256, SHA512. SHA is shared hash algorithm. So for example, I provided a hash. Our plain text or our value is AAA, and when we perform hash, we get this big chunk of alphanumeric number. So this is the hash for AAA. We will discuss more about hash when we discuss. Actually, we will see how we compute, how we can use this hash with the trusted platform module. So next topic is, what is trusted computing? Yes, we have elliptic like ECC. We have ECC. We have so when we discuss about TPM in detail, we can see, or you can see all the like all sort of algorithms which is available. Most of the secured algorithm is also, if there is any new algorithm coming, they like which I'm going to discuss next is a trusted computing group. They are kind of adding those algorithms, and you can write or you can implement your own code in terms of the security algorithm, which can be implemented in the trusted computing. So next one is, what is trusted computing? So in terms of trusted computing, according to trusted computing group, which is like a global consortium to kind of rely or to kind of specify the policies uh, about trust. So this is a component is trusted if it is predictable. So if you know what is going to happen, then you can say that, okay, this is trusted. So if you are adding 2 plus 2, and you know the result, the computer is going to give you 4, then you can trust the computer, saying that, okay, this computer is performing correctly, or I can trust the execution provided by the computer. Trusted is not same as good or secured. Again, you can't say that that this is good all the time. What happens that sometimes it will, if your machine is corrupted, so they have a kind of lookup table that kind of just check, okay, 2 plus 2 is equal to 4. So when you are typing 2 plus 2, you get 4, but it may not be adding. It has some background kind of lookup which the computer or which the intruder is just checking and telling you that, okay, this is 4, and you are kind of now trusting. So it's not always good, but it gives you a foundation to build on.
And then you have community cloud. Here, multiple organizations form a consortium to build a cloud infrastructure, which is then available to be used by only members of that consortium. So here, it's a very simple notion. Many organizations will form a consortium to build a cloud infrastructure platform, and only the members of that consortium will use those services. Let's talk about cloud service categories. Now, there are 3 deployment models. I think this is something we are well familiar with. We have the SaaS, PaaS, and IaaS. Let's talk about each one of them. SaaS stands for software as a service. Here, users can use an application provided by cloud service provider and pay for its use. Now, my organization we are using the Google Suite, G Suite platform. So we use Google Mail for business activities. So we are using that serves. At the same time, we are also using Office 365 for various services, right? So we are using that for our, opening our Word, online Word applications and so many things, right? So that is SaaS platform.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
And then we have the PaaS. PaaS stands for platform as service. Users can get a managed platform where they can deploy and run their applications without the developer worrying about the server management. Example, Heroku. You get another example could be Amazon RDS. Finally, the IaaS platform. Here, users can purchase basic computing resources and use them for their own needs, like AWS. Here in IaaS platform, you would properly deploy a virtual machine with the operating system and then utilize it for your specific requirements. Let's say if you want to have more fine-grained control. So for instance, if you deploy Azure Web Application, which is a PaaS service, there you can define only specific configuration settings. But if you want to have more fine-grained control, probably what you will do is you will define, you will set up a Windows server machine, virtual machine. On top of that, you will install IIS server, web server, and define control some settings there, which will, by doing that, it will give you more control than the Azure Web App, PaaS setting. Shared considerations. There are several cross-cutting or shared considerations that are addressed in the cloud reference architecture. These are interoperability, portability, reversibility, availability, security, privacy, resiliency, performance, governance, maintenance, versioning, SLA, auditability, regulations. Now, it's a very simple thing, okay? I will just put it in one single line right now. The whole idea is that this is something, all these pointers, whether it's things like regulations, privacy, the chance to audit something. See, the point is, the moment you move towards the cloud, okay, we are on a multi-tenant model, more or less, right? That's the more appropriate consideration. So probably, for instance, let's say my organization sets up a subscription, uses a subscription account on Azure and sets up their services in the Azure Ireland data center. Now, the point is that maybe I'll be setting up my Azure database, PostgreSQL database, my web application, everything on that data center, which makes sense. Now the catch is, once we are shifting some gears there, right? What are the things? Every organization has certain governance policies. It could be from InfoSec standpoint. Now, I serve as a CISO in one of the organizations. I can tell you that you define policies such as your data security policy, your disaster recovery policy, your cybersecurity policy, like what are the do's and don'ts, how for an organization, so if you're using emails, what's the right way to use emails, all those kind of things. Now, the moment you shift your applications towards the cloud, it's a real shift, right? A lot of things can change there. Now you are no longer in control. Whatever model you go for, whether it's IaaS, whether it's PaaS or SaaS, whatever it is, you are no longer in control of your own data. Your data is residing, and it's residing at the discretion of the cloud service providers infrastructure. So for instance, you may have a policy that says that you want to preserve all the logs for 3 months. You're keeping at a bare minimum 3 months for audit perspective. So if you want to trace back any transaction, any suspicious transaction, so there you may preserve that for 90 odd days. Now you deploy your application quickly onto the cloud. Now these semantics can change there. Now probably the web server on the Azure platform, they're just keeping the logs for probably for 7 days. At a max, they may keep for 30 days, but not beyond that, right? So even if you talk to them, it would not generate much traction because that's the maximum you can get because you're on a multi-tenant model, right? So certain nomenclatures can change. The other thing could be, for instance, a year back, I got a chance to review the security posture of Cooper Surgical, which is a healthcare company which is based in the United States. Now, obviously, they were first moving to the Azure platform last year. And interestingly, they were onboarding, their global sales team was actually onboarding their applications, certain applications in Japan and certain applications in Denmark and certain applications obviously in Texas, in the United States. So interestingly, the database, which was Azure Synapse Data Warehouse, which could load a lot of data, they were uploading the Denmark data there as well. Now, what was surprising is that they were left unaware that obviously, first of all, the HIPAA regulation, would come into play. GDPR regulation will come into play because if there is certain PII data of certain individual sitting in Denmark, right? How can you load it to a database that is residing in a data center in the United States? And the same would go for Japanese data. So if you want to, deploy, or if you're storing, there is no way somebody will stop you from storing Danish data on a database that resides in United States data center in Azure. As an organization, that is your responsibility. It is not the responsibility of the cloud service provider. So there are certain shared considerations. So in this case, there were certain violations of the HIPAA compliance, and maybe there were certain violations of GDPR compliance as well. Because as per the privacy regulations, the data of if there is certain PII data of a European individual, it should be within the boundaries of Europe. It should not go beyond that. So, these are certain, and especially because the services can be deployed so quickly at the end of the day, who are working behind the scenes too. So, for instance, who would be that person who is going to load the Danish data or the Denmark data in an Azure database that actually resides in, that was actually hosted in US East Coast. So probably it would be a DBA. That person probably will not be aware of the data privacy regulations, and this is an area of concern, right? Boundaries, and while there are certain responsibilities of the cloud service provider, certain responsibilities will also fall under the purview of the cloud customer as well. So there are certain shared considerations. When you talk about SLA, service level agreement, what's the norm around worldwide? Because you can deploy so you can get started so quickly on the cloud. What's been observed is 7 times out of 10 there is a de facto norm, and what's been observed is that mostly cloud architects would end up going quickly deploying. If an organization wants to grow on the cloud, they will plan quickly and go, and very soon they will be able to set up their resources on the cloud. Now, while that's a good thing, what's lacking is that every cloud service provider provides a generic SLA, service level agreement, on their portal. And many times, the cloud architects who deploy such services for their companies, they end up not reading the service level agreement. And later on, the same organization which deploys their services on the cloud, now they are facing certain challenges. For example, their policy was to make sure that the logs for forensic investigations, the logs are preserved for 3 months. Whereas on the cloud, it is just preserved. I'm just giving as a use case. Maybe it's preserved for, depending on the provider's maximum and minimum, logging requirements. Maybe it is preserved for just a month. So in that case, probably they will be found lacking, right? So it is important to read the SLA. Now, there are certain questions, I believe, from the audience. Let's take a look at all of them. So let's touch base quickly upon all of these pointers. I think we talked a lot about this thing. So what is interoperability? It's the ability of 2 or more cloud services to work with each other and exchange information. Portability is the ability to move data and operations from one cloud service to another with minimal disruption. Reversibility is the extent to which cloud-based applications are designed so that they can be moved to other cloud providers or environments. Now, remember, there are a couple of things like vendor lock-in. Now, if you go on to RDS or if you use DynamoDB, there will be a vendor lock-in kind of thing. It will be hard for you to, if you feel that AWS is more pricier or it's more costly, and let's say you want to move to a cheaper alternative like probably like Oracle Cloud, or for a matter Alibaba Cloud, which will be a lot cheaper. So that will be a bit hard, right? Because vendor lock-in will come into play. So you got to be very clear when you deploy certain things. You also got to keep that aspect into mind, where if things don't go as per the plan, or if you feel that the services that a particular vendor is offering a lot pricier, and if you're not getting that, it's not meeting your expectations, you should have the ability to fall back on another vendor, right? So that is an important aspect. So, the whole idea that we're talking about, all these shared considerations, many of these are governance related, right? Also, they are business related aspects as well. The whole idea is that the moment you deploy a service in cloud, does your cloud administrator or your cloud architect, do they think about all these aspects before deploying something? 8 times out of 10, or probably be more aggressive here, I will say it's, I'll be more bold in my statement. I'll say it's 9 times out of 10. They will not think about this. So that there's a 1% range of architects or professionals who will, prior to deployment of any service, because it's so fast to deploy, it's all self-service. Before you deploy anything, you will not be thinking about short-term plans, but also the long-term consequences. If tomorrow, if you're not getting the right returns, you should have that pathway to switch to another provider, not just get locked in just with one. Availability is a very important thing. In cybersecurity, we talk about the CI triad: confidentiality, integrity, and availability. Availability is the probably one of the most important aspects. It determines how much uptime can be provided by a cloud service. I give you an example. If you go to a site like Down Detector, you got to be well aware of the fact that a provider like IBM is will have a lot of outages. So it's better off not to go with them. You're better off to go with any other vendor. Maybe like if cost is a concern, you can go to Azure, or maybe for that matter, you can switch on to Oracle Cloud, where you will get a better service. You can at least get a better service than these things. Now, there is another aspect also. When we talk about I'm not just talking about all these components, but I'm also talking about something in addition to this. Now, you see, this entire cloud world is governed by two things, right? And especially in the last 2 years of the pandemic, we have seen more of this happening. Now, what exactly we're talking about? We are talking about the cloud service CSPs, the number of data centers that they have, right? So in the last couple of years, what has happened is Oracle has been very aggressive. They have rolled out their cloud certifications free of cost. Even right now, their cloud architect and all those certifications are free of cost. They were last year and a half back in May 2020. They also made this free of cost. That's just to gain traction and more visibility because they are lagging behind in this space. And in last 2 years, they have launched a lot of data centers. In 2019, interesting development happened, right? Oracle and Microsoft Azure, they're pretty much competitors in their own right. They signed an agreement and now they're partners. Now, which means in a region where so Oracle is based out of Redmond. So assume that Oracle doesn't have a data center in one location, right? They have one in Ashburn. Let's say in Seattle, Azure has a data center. So now Oracle customers can actually they can leverage the Azure because of this partnership. They can also utilize the Azure data center internally for faster access and all for better response times. So this engagement has also happened. Now, that's probably one of the only exceptions. You can read about this. You can go to Oracle was an MS Azure 2019 partnership. As simple as that. They expand interoperability, right? So Oracle Cloud Infrastructure and this. So that's the kind of partnership. So I'll just share the link with you. You guys can probably get a chance. You can go through it. Oracle is probably the best database around the world, and I've worked a lot with Oracle. I do agree with that. Right? So in terms of performance, in terms of resiliency, it's probably one of the best, but it also has pricing. So AWS outage just recently took down Netflix. That's right. That just happened. So these things can impact a lot of customers like Netflix, such on-demand service, pretty much real time they operate. And if it's equally important to assess whether you should be on the hybrid cloud, whether you should run what kind of workloads should be you set up on the cloud. That's something you as an organization want to take a look into that. Third-party service providers, outages will happen. They may be resilient, but the point is that these things may be beyond your control, right? So if there is a region outage in Azure, and if let's say there's a customer who is completely dependent on them, their business is at the mercy of the cloud service provider. At the very best, they may have set up a regional DR service by which most likely that coverage will be provided. So AWS market share is multiple times higher than other CSPs, and the impact of outage is also higher. Now, data privacy is a very, very ambiguous topic, right? Because I deal with data privacy inside out, and all around the world, you are seeing the federal governments around the world are tightening the rules regarding data privacy. Very, very strong. You have PIPEDA in Canada, you have CCP in California. There are multiple other regulations like HIPAA, that provides from a healthcare perspective in the United States. There are certain NIST regulations. You also have data privacy laws, very stringent laws in Singapore market, very, very stringent laws, very hard laws in China. But what's the interesting anecdote to this part? So while...
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. mission critical workloads, C. sensitive data, D. all of the above? Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
All this setup is there. GDPR, CCPA, PIPEDA, other regulations around the world. The interesting anecdote to this part is there are some anti-privacy laws also around the world. And I'll give you a good example of that. Okay. Now, there is something called as Cloud Act. Now, this Cloud Act doesn't really deal with cloud. Okay. It's a different act altogether. It basically supersedes the Stored Communication Acts of 1986. So it's an update to that act, right? So the clarifying lawful overseas use of data act or a cloud act. And this act created a lot of furore in United States somewhere in 2016, 17, around that, maybe around 2017, 2018 period, right? That was, now the problem was, this was a case, there was a federal case against or there was a lawsuit filed between United States government and Microsoft. The US government wanted access to one of certain emails that were originating from Ireland, right, in the Azure data center in Ireland, right? So there were certain concerns around that. However, at that point in time, there weren't any regulations that could compel Microsoft to provide something. So as a result of that fiasco, or that of that fiasco between Microsoft and US, the Donald Trump's regime, they actually ended up, the government around that time in US, they basically introduced Cloud Act, which simply says this part, which compels US-based, the only US-based technology companies via warrant or subpoena to provide requested data stored on servers, regardless of whether the data are stored in US or in foreign soil. Now, this is a complete anecdote to GDPR, right? So if now tomorrow there is a situation where any other US company, let's say Amazon or any other firm, and when they want certain data of an individual based in Europe, okay, this part is an anti-privacy law in a way. So while you have certain pointers, so you may be found wanting it, because this is just one act, okay, by the way, okay, and this is, to be honest, this is very well drafted act, right? The moment you look towards, the moment you go towards China, right, if you, without any bias towards any country, this is all, every country have their own rights in these things. China has such anti-privacy laws. So while at one point they really want to control that part, if you're working with a client, Chinese cloud service provider, and especially if you're hosting a website with them, you've got to be very careful with that, right? Sometimes you can end up getting a bad taste. So it's very important to be aware of any such anti-privacy laws around the world, right? So while there will be some privacy laws that will force you, there are equally without, there is a lack of awareness amongst people regarding this. In the Middle East market, a decade back, BlackBerry, which is very well known for its encryption technology, they are very well known even now, while they were primarily 10 decade back the leaders in the cell phone technology. One of the things that they were facing a lot of backlash, especially in India and very much in the Middle East market, was that the government in all these countries, they're actually mostly in the Middle East, they wanted to monitor their own citizens. Now, because BlackBerry was encrypting that entire data, they really wanted this encryption layer to be taken away or decrypted. BlackBerry did not agree with that, and they did not bow down to their demands, and as a result, they were out of these countries. But that's how things are. And such similar concerns right now are present with Facebook, with WhatsApp. Many people are actually gone onto the Signal application, I think, which is ready budget regarding all these concerns. Security, cloud security involves concepts such as confidentiality, integrity, and availability. So take, for example, data at rest. You're using object storage, you get data at rest, everything is encrypted. Data in transit, probably you're using TLS or secure protocols, HTTPS. So those kind of things. And then privacy refers to protection of data and activities from unauthorized access. Resiliency is the ability of cloud services to recover from failures and errors. Resiliency is very important, right? If there is a failure, they should be able to recover from such things. Performance is the volume of demand for resources that can be handled. And governance, which is very, very important. Governance ensures effective oversight of cloud usage. Maintenance in cloud refers to activities such as installing patches, upgrading systems, etc., which cloud leads to some downtime. Now, sometimes what happens is if you use a particular service, they may specify a downtime period for it, which is done by the cloud provider itself. So you also got to be very careful, got to take into account. Like for example, Azure Synapse database or data warehouse, every 2 weeks there is a specific downtime window, especially from Tuesday, for 2 or 3 hours, there is some downtime window. So one needs to take those things also into account. Versioning is done to keep older versions of data available in the cloud to determine the stream of changes that lead the data in current set. Service levels determine the value of metrics that a cloud service needs to provide, such as availability, performance, etc. And then SLA, which is very crucial. It's an agreement or bond for performance negotiated between cloud service provider, the client. One of the metrics in the SLA is your availability component. Another one is your MTBF, mean time between failures. Because of IBM's lack of, they were not able to fulfill their SLA commitments. So, like 99.95% availability, the mean time between failures, the mean time to recover, they were quite high. So as a result, they really lost customers. Now, mind you that Oracle was actually behind IBM. Oracle really started focusing on the cloud environment way after 2016-17, which was so they were already on a delayed start. But what I feel is that they are at least ahead of IBM in this market. IBM was, they did start a decade back. So IBM always generally lags behind in all of things. Auditability, an audit verifies cloud service providers fulfilling their obligations determined in the SLA. Now, this is very important. Typically, the audits that are being performed, especially the internal audits, external audits may be well drafted, may be well done. Many times your compliance teams, they go by specific norms like ISO 27001. While there is a specific ISO standard of cloud security, they may not understand containers, microservices architecture, and they may not be very well familiar with the cloud setup, as well. So sometimes they may struggle, right? So when you talk about auditability, is there any standard around the world from which we can use as a default or a de facto template for auditing? So there is one. So what's that? Cloud Security Alliance, right? If you go into this, so it's a non-for-profit organization. It's a consortium of cloud vendors. This was started a decade back, 2010. They have something called as a star audit, right? They also have something called as a cloud control matrix, right? So if you follow these, you should be in a good space, frankly speaking. So if you go to CSA, star audit, that's where this is what you know. So if an organization wants to get into this, you can get a star audit done from any of the star vendors. That tells you how good your posture is. The other thing could be adoption of the cloud control matrix. That's a very simple thing. These are the certain domains within the cloud control matrix. Now, along all these lines, how good is the security posture across these specific subdomains of the cloud security is to tell you how good your standard is or how good your overall cloud security baseline is. This is an important matrix. I think this is something that should be, it's pretty much very widely used. So, and this, many organizations are using it, many organizations are not aware of it, but I think they adopted this as the ability to serve. This is one of the best practices, especially if you are focus point of cloud auditing. You could choose this as a kind of a checklist, anything under these subdomains of cloud security. What are the points you are ticking and what are the boxes you're ticking or what you aren't? That will tell you what your overall cloud security posture looks like. So this is a very important aspect of cloud security. So this can be adopted by organizations. And then we aren't, regulations is something we are dealing with inside out. If cloud providers are serving customers that are under certain regulations, then their services to meet these regulations, such as any specific government regulations in certain countries that will apply. Like for example, it could be HIPAA, could be anything else, any other regulations around the world. Now, for instance, if you're operating in a country like Australia, Australia has actually adopted the PCCI DSS standard as a default. So which means that every organization operating in the e-commerce domain or any organization operating that sort of business, they will be kicked in by the PCCI DSS rules, especially even if they end up going in the cloud, because that's the country has adopted that standard altogether. And at the moment, a lot of things are happening with the CMMC, which is based on NIST 800-171. Now, what's the beauty of it is that many countries around the world are actually adopting many variations of the NIST standards. So they are adopting, for example, the UAE government, United Arab Emirates government is adopting it. Israel is adopting a part of it. Germany is adopting, and there are some reports around Saudi Arabia are also adopting. While some of the Middle East countries, with due respect, probably they are lagging behind, with probably the exception of certain countries who are still ahead in that adoption of cloud market. But that's a norm around the world, right? This is how things are moving. We need to get started on the emerging technologies in the cloud landscape. Now, there are several new technologies emerging in the cloud, such as machine learning, blockchain, IoT, containers, and quantum computing. So let's touch base on all of these. Machine learning is a technique that allows machines to gain new abilities by learning from the already existing data sets. Machine learning is heavily used in recommendation engines and applications such as Netflix, Amazon, Flipkart, etc. Now, I'll give you a good example of machine learning here. Okay, if you go to portal.azure.com, right, and as a cloud-based or a cloud native, same tool, right? Same tool which is basically used for detecting any security events and responding to those events. So Azure is probably one of the few vendors, right? One of the few cloud service providers that is providing a native in-house native SIM tool, okay, detecting security events and responding to those events. So that is to those events. So Azure has something called as Azure Sentinel. Now, Azure Sentinel is a cloud-based SIM tool, and in Azure Sentinel, you can define alerts, okay, based on certain security inputs, certain events, certain log-related events. However, in Azure Sentinel, you can also define rules based on Microsoft's machine learning algorithms. So it can do the things automatically, algorithms. So it runs behind the scenes and it can do the job for you, right? So you can define rules based on machine learning and AI. In fact, you are not defining any criteria there. You simply say rules can be defined using this. The only input that is needed for the machine learning algorithms to predict any security events or is that they need data, and data you can get by getting all your infrastructure logs in a centralized repository in Azure. You can get that to the Azure data lake and it can do the job for you. So it can read all the logs and check out if any such information. It can check traces for a DOS attack, denial service attack, all those kind of things. So that's an example of your machine learning solutions in Azure. Okay. Then blockchain. So blockchain is a data store for distributed decentralized ledger, which cannot be tampered with and provides high level of integrity. One of the most famous uses of blockchain is cryptocurrencies such as Bitcoin, and blockchain solutions can be built on AWS and Azure, and similar to that, IoT also. So similar to blockchain, IoT is a technique for connecting non-traditional devices in a network data collection, analysis, monitoring, and control of these devices. IoT is used by smart devices such as Amazon Echo, Google Home, smart fridges, etc. So all these emerging technologies like cryptocurrency, IoT, you can build solutions on them or on the cloud. Then comes your containers, right? Now, containers is a light way. So we are talking about the microservice architecture. We're talking about the Docker environments. We're talking about the containers that are used to manage those Docker setup environments, right? So containers like Kubernetes. So container is a light way to package up entire application to make it portable across different hardware platforms. Containers are very popular in applications such as Netflix. In Azure, you can set that up using AKS, which is nothing but the Azure Kubernetes service. So if you want to set this up, that's how you can set this up. You can check out the service and you can set this up. And finally, quantum computing. Quantum computing is an emerging technology that allows substituting traditional bits with quantum bits for faster processing. Currently, quantum computing is being used for research purposes only. Now, I will give you an example, not from the cloud service provider for quantum computing, but If you want to take a look into this, one good example would be Checkpoint. Checkpoint is a well-known cybersecurity company, and if you look into their solution, it's actually pretty good, right? So Checkpoint's quantum computing is a platform worth checking, right? So it's definitely worth checking on this part. You should definitely check this out. This is widely also used in Checkpoint's Cloud Guard, which is a virtual firewall in the cloud. So definitely you should check this out. That serves as a good example there. So we are talking about all these emerging technologies. Now you see, there are two areas specifically that need some attention, and this is from a cloud governance point of view. I went to the Cloud Security Alliance website and showed you something called as Cloud Control Matrix or the STAR audit, right? CCM, which stands for Cloud Control Matrix, and the STAR audit. This is nothing but the Cloud Security Alliance methodology. Now, the point is, when you are using solutions like you're building IoT solutions on cloud, blockchain solutions on cloud, tomorrow you may be building 5G solutions like a company like Huawei, they've had some setbacks, but they are taken a big lead with 5G and other related technologies, and they can leverage the same thing on the cloud. So now the point is, how do I make sure that I have a good security posture on the cloud? Because see, cloud is not just about IaaS platform and a PaaS platform. It can also be the SaaS platform. So what do I have to make sure that I have adequate security on my cloud? For instance, if I observe that my CPU utilization reaches CPU in my memory utilization reaches, let's say if I'm getting alerts, it reaches 95% utilization. Now, after that, your systems will not be able to perform. So you have two options. You can either scale up, which is vertical scaling, the thing that covered yesterday, or you can scale out, which is horizontal scaling. So let's assume you do horizontal scaling. So if you have a web server which is reaching its full capacity, you can set up auto scaling properties that, based on the alert, that 95% trigger alert, it can start spinning out new web servers of a similar configuration. Now the catch is that the existing web server has been defined with some access policies. So the key question is, you are rolling out new, as a part of your auto scaling request, you are rolling out new web servers to meet the user demand. But do we have adequate policies set up on those new servers that are just getting spinned out? The answer would be no. So your initial server, which has reached its threshold, 95% or 100% of its utilization. So the moment it reaches 95% above, you trigger your auto scaling sets, policy starts triggering, and you launch another web server somewhere in the same region or in another region to meet the demand. Now, does it have the same security posture as your existing web server, which reached its full capacity? The most likely answer would be no. So what about the security for such things? What about the security for your images, for your secrets, all those kind of things, right? So those kind of things are important, right? So what is the security posture from a compliance perspective? So for example, if you are a client running in Singapore, right? If you're running on cloud, if most of the organizations have to comply with mass, regulatory framework, which is a framework in Singapore. So how do I make sure that my cloud posture is compliant with that? There are many tools available, such as Horangi is one of them, which is a Singapore-based company. It will make sure that if you deploy that tool, it's a cloud-based tool. It provides you visibility with regards to how your cloud objects are stored. It gives you an assessment. It does a security assessment and provides you with a report that tells you the overall score of the resources in the cloud and what you need to do to maintain compliance with the regulatory standards or frameworks in that part of the world. So what we're talking about is CSPM, Cloud Security Posture Management. So sometimes you may have some misconfigurations, some bad settings. So you need something to figure those bad settings out and provide you with that kind of visibility. At one end you have cloud security posture management, at other end you have SaaS security posture management. So these are new areas, right? These are the areas that generally tend to be ignored. And it doesn't end here. It's not just about the cloud security posture management. Assume that I'm building up some sort of block cryptocurrency solution using cloud. So how can I audit? What do I do to audit my setup? So I can go for a cloud audit. At the same time, I can go for a cryptocurrency audit, right? Now in cryptocurrency, you may have heard across standards like ISO 27001. So if you go on the site, Crypto Consortium, you will find that they have a standard for cryptocurrency. It's a security standard similar to ISO. It addresses a different area, which is the cryptocurrency security standard. So you have a security standard available for cryptocurrency also. Similarly, there are standards available for IoT platform, for 5G also. So that's the whole idea. So you not only can you do a cloud audit based on the star audit, but you can also do something like this. So that's the reason why it becomes important to look at all aspects. And you can get involved as a blockchain auditor. You can, if you become familiar with cryptocurrency standard audit, which is one of the only few certifications from cryptocurrency's perspective. So this is what it will help you. Cloud computing security concepts. Now there are 6 security concepts relevant to cloud computing. These are cryptography, access control, data and media sanitization, network security, virtualization security, and common threads. Let's cover them one by one. Now, cryptography. In cloud computing, cryptography plays a major role in data security. Some of the important aspects to consider are encryption, key management, data in motion, and data at rest. When we talk about database encryption, every organization's data, their business data resides in databases. So if you can break that up, you can get something, either breaking that up and just seeing, and if you have built something up with that, I think that's really good. We're talking about not just about cryptography, we're talking about the entire landscape. Where it is helpful, what are the use cases? Think about cryptography or any area in security from a perspective of what are the benefits or use cases it is providing? Are there any relevant risks of using that technology and any downsides? And does it support from a governance perspective? Is it subjective to audit? So for instance, if you are using first your S3 buckets or your object storage, that uses encryption. Amazon S3 will use encryption. Your Microsoft Azure blob storage or Azure Data Lake, that's the new term for it. Azure Data Lake generation 2 now. It was a earlier generation 1. So that uses encryption. When we say these are examples of data at rest encryption, because here you dump all the data in one place. Object storage is nothing but long-term storage, right? So it is not used for faster data retrieval. Maybe you can store your historical data or archival data there, right? If you want anything to be used for instance, if you want something to be processed for OLTP, right? Then you need to attach block storage. So block storage to any of your IS servers or something, and they will provide you with this kind of a feature. Even if you're using PaaS service, internally any of the PaaS databases, internally they are connected to block storage, right? Now, the point here is these are the use cases. It can secure your information, right? Especially for data at rest. And we'll talk about data in motion also. So it can secure your data using 250 AES or any other encryption methods. So if you use AES, advanced encryption standard, it could be 256 bits or more. That could be the length of the key. The data at motion basically talks about any data. So for instance, let's say you are using BitLocker encryption, in one of your web servers, right? And you're not using the Azure web application, but let's say you have set up a VM and then just installed the IIS web server there. It's the classical on-prem kind of thing that you usually do on the IIS platform, right? Because you want more fine-grained control, you want to be able to tune the settings according to your requirements, so you have gone for that. Now that's the scenario that we're talking about. Now the drive where you're hosting your Windows server, right, on which your IIS server is hosted, the drive is encrypted by BitLocker. So that's an example of block storage. These are either S3 buckets, something like a Windows server, virtual machine that is connected to a data disk, which is a data disk and operating system disk, which is nothing but protected by BitLocker encryption. They are examples of data. Now you make some queries to the web server. You made a specific query. The web server is sending you some data. Now there is some latency between you and the web server. So whatever data it is sending you, that is data in transit or data in motion. So data that is traversing from source to destination or from destination to the source. So it's the data that is traveling. It's not static. And this data needs to be protected. So you can use SSL, you can use HTTPS, and basically you need to use a secure passage to provide that layer of encryption, application level encryption for the data that is traversing over the internet. That is data in motion. Now, cryptography is a science. So cryptography consists of encryption and decryption. Encryption is the process of converting human readable data into a format that does not make sense to the end user. So it basically converts human readable data into ciphertext, which is a format that is not understood by humans. And decryption is the process of decrypting the data which is not understood by humans to a format which is understood by humans, or to back to its original form, right? So the cryptography involves encryption and decryption. Now, how is key management related to that? So now let's say you have set up a resource group in Azure. Resource group in Azure is nothing but a collection of all the resources that you have. It's a logical kind of entity. So it's a placeholder under which you have placed all your resources, right? So for instance, you may have set up a database server, a web server, you may have set up a container, and lots of different kind of things you may have set up, right? Now, this resource group is the placeholder under which you have, and all of these, whether your database server or a web server, they are all accessible by, you encrypted them. So they're accessible by some keys. Now the problem is, where do you store the keys? And if you store the keys with yourself, there is a potential chance that you may lose the keys. So key management is centralized location where you can keep all the keys of your resources under one centralized location. And the cloud service providers provides you that. So it's the management and storage of encryption keys, right? So that's what it does. So we have talked about encryption, key management, data in motion, data at rest, and data at rest. So we understand that it's one of the benefits is that you can encrypt the data, and by doing that, no third party will be able to decrypt your message, if they're trying to sniff your packets or something. So it provides an extra layer of protection. Now, before we discuss the second advantage, let's talk about one of the disadvantages in this architecture. So let's say I'm doing encryption now, because let's say I've got 10 resources and I have set up the encryption keys for all of them, and all the encryption keys are different. Now, if I maintain all these keys in an Excel file, I can lose the file, right? And then I lose access to my own data. So I need to make sure that there is a safe location where I can keep it. So that's where you have Azure Key Vault, you have Alibaba KMS, Key Management Service, where you can store your keys. It's a centralized location where you can securely store your keys and access, and you can use them when needed to access a particular resource. One of the disadvantages is that now not only your application, but also your application, your cloud resources, your data, and the encryption keys are also under the control of the cloud service provider. That's the catch. Now, while as a good practice, the cloud service provider, you are paying them, they have nothing to do with your data, right? But isn't that a risk factor? There is a perennial risk, some degree of risk is involved, because if there is disgruntled employee at cloud service providers end, they may come just in an ad hoc manner, just try to take your keys and decrypt your own data and just damage your reputation. So while that guy may end up getting fired,
just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee. and it is taught by IIT Roorkee professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
Your reputation is also taken for a toss because here you are at the mercy of the cloud service provider because you are keeping all the keys in one place. So definitely the cloud service provider will have access to the keys. Now, as a good practice, they will not do this kind of things. That's for sure. But whenever a leak happens, whenever any companies, there is a data leak or there's a cybersecurity incident that happens in any company, it's not the company's intent to leak that or to get bad reputation. Somebody does it, right? Either an external guy or an internal guy. SolarWinds, which is such a well-known organization, very well known for its monitoring software, very well known for its cybersecurity also. Sometime around this time last year or at the start of this year, they faced a massive cybersecurity breach.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Or their systems, one of their systems was exploited, one of the vulnerabilities was exploited. It may be very advanced, but the point is they were targeted, right? So while that was not someone's fault, it was somebody's fault because nobody paid. There were some areas that were found wanting, and that as a result, external hackers were able to exploit some vulnerability. So there is a potential risk, especially with key management, because you are storing all the risks here. Sorry, you're not the risk, sorry. You're storing all the keys here. So from a risk perspective, there is some degree of risk. Now you have no choice to accept that. But the point is, if you do not want your keys to be under control of somebody, you can use external providers. So for instance, Google has partnered with external providers for key management and storage. So this problem is taken away. Somebody else is doing that job for you. Now, one of the vendors, well-known vendors in this industry is Fortanix. It is a hardware security module. So how does it work? How does it integrate? So if you check out Fortanix partnership with Google or AWS, you will be external key management, right? So you can check this out. So Google platform collaborates with this, right? What all things can you do? You can generate and store keys externally outside the cloud. So you can generate the keys also outside the cloud. Now that's a different thing. Customer control over encryption in cloud with customer owned keys. Now you don't have to manage the keys either, but you have control over generation of the keys and keeping them outside the cloud. So it's you have a controlled key access, central audit, and policy management. So these are the things that you can do with hardware security modules and external ones. And why did Google partner with somebody like this? Google can generate the keys for you, but what was the need for it? So you can say they newly announced Google External Key Management Service because there is a potential risk within the cloud. The cloud provider has too much control over your applications and your data. So you want to have some level of control, isn't it? That's how you manage control over that, right? So this is one of the demerits because the cloud has too much control. They can decrypt your own data, right? So in this case, you should go for external key management service like Fortanix, and Google partnered rightly with them. The next benefit is that there is something called as crypto shedding. Let's say you have decided to move from, let's say you find AWS from a price point, you find it very costly, right? And now you want to move to somebody who is very cost effective. So let's say you decided to move from AWS to Alibaba Cloud, right? All cloud managed services have high SLS2, that's true. So let's say you decided to move from AWS to Alibaba because from a pricing point of view, it'll be easier. Now, there's no such problem here, but your organization worries that you are storing your data on this guy's infrastructure, right? So even if you delete the data with some forensics tools, they may be able to, and if you move away from them, they may be able to recover your data. The cloud service provider can still recover the data using some forensic tools. So that's a concern, probably for customers, such customers who move away, right? These guys can cause some damage. And to be honest, vendors like AWS, Azure, big organizations for sure, but malpractices can happen in any organization of any sort. You can't just rely on the fact that they are huge and everything is ethical there. You can't just go by that. They would have certain policies, but at the end of the day, it's a private organization, and you cannot just have a de facto trust in another provider, right? So while they will not do this kind of a thing for sure, but you can't just rest assured, because something which is beyond your control can be misused, right? And you will not even come to know of that. Like for example, Microsoft, since 2017, they have a policy. They can perform pen testing on their infrastructure. If they have leased their infrastructure to you as a customer, you're paying for it, then you are the owner till the time you are with them, right? You are the one, because you're paying service for it. But what they have said is they can pen test even your data as well. They don't need your permission. In fact, they will just go ahead. They have a very generic comment which is mentioned on the website. They can go ahead and pen test their infrastructure without your permission, even if you're hosting your own data there. So they don't need prior approval for this. So what do we do in such cases? Especially if you are migrating from one cloud provider to another, you can use something called as crypto shredding, right? Now, crypto shredding is interesting. You encrypt your data and you delete your encryption keys. Okay, encrypt your data. You're not deleting your data, but you're deleting your encryption keys. And to delete your encryption keys, they also would need to decrypt your data as well. That's crypto shredding for you. Now, at least here you can rest assured that they will not get access to your data because you have lost the keys. You've deliberately, you've done it deliberately, right? So intentionally you deleted your encryption keys because you decided to move to another vendor, and you just want to make sure that this cloud provider cannot get access to your data. So it's as simple as that. So encryption is nothing but the process for encoding information to make it impossible to understand the encoded text. So basically conversion of original information to cipher text. This text is encoded using a key, which is then used to convert it back to original information, which is called decryption. Key management refers to managing cryptographic keys within a system that uses cryptography. So basically, key management refers to generation of keys, exchanging of keys, storing keys, using and replacing keys as needed at the user level. Now, Brian did mention this prior to the break. He raised a valid point where he said, if you're using crypto sharing and if you still delete the keys, all these things like key generation can happen. The cloud provider may even keep backups of your keys, right? So so while you may have a good sense of security, that it may give you a good impression of security, right? That the cloud service provider doesn't have any way to decrypt your data. That could turn out to be a false narrative, right? So you have options such as going towards external key provider for key generation management and all those things. So that way you're well covered, and it's outside, the decryption process remains beyond the realms of the cloud provider. And the second hand, if you still, when you adopt key management, it comes as a part of the package of what you pay for, right? And if you go with the external provider, you got to pay some price for it, right? So many customers don't do that. So if you go with the second option where you utilize the cloud service provider's platform for key management, there, one of the ways to look at if something wrong happens is to get covered from a non-disclosure agreement. So while it definitely may cause some damage, but at least you can get, there are penalty provisions for the cloud provider in that case. Data at motion and rest. In cloud, data that is either at rest, that is stored in a device, or in motion, means that data is transmitted over the network, and both of these need to be protected and secured. Data at rest is encrypted by default. However, data being transmitted from a client to the cloud infrastructure needs to be sent over an encrypted connection using HTTPS SSL. So this is how you can set up a good security posture on cloud using the SASE framework. So this is how you will, you can access these things. So we talked about all this part. Let's go on to security. Next, security control related to data access. Let's talk about this. Now, what is access control? Access control is a major source of security flaws in cloud computing. Access control refers to granting and revoking a user authorization over some data or service. in cloud computing, access control can be managed in several ways. However, in real world practice, organizations tend to manage access control locally due to its importance to organization information security. This is done so that the organization has full control over granting and revoking access to cloud computing services and data. Absolutely correct. Let's talk about data and media sanitization. This is a very important area. We touched base upon this earlier. Data and media sanitization refers to dealing with encrypted data when being erased, changed, or overwritten. When dealing with secure and encrypted data, there are several concerns we need to be aware of. For example, we may have to delete or overwrite a small piece of data that is encrypted using a key. If the key is only used for that data, then we should remove the data and then remove the key as well. For security purposes, all cryptographically secure data should be deleted or overwritten in such a way that it cannot be recovered successfully. And that brings to the point which Brian mentioned, that you may overwrite the data multiple times, but are you absolutely sure that the provider may have a backup of the data in some other location? In some other, you will not have any idea. So frankly speaking, the moment we decide to host our application on a cloud, we are pretty much at the mercy of the cloud service provider. Network security. Network security allows us to impose restrictions on incoming and outgoing traffic in a virtual or real environment. Many cloud services provide several tools which we can use to better protect our virtual networks in the cloud. For example, we can use network security groups in Azure for applying specific security rules on a group of resources. Firewall should be properly used to prevent unauthorized access to our networks. Set security rules to only grant networking access to resources that need them. So the whole idea here is, from a network security perspective, follow the concept of least privilege. Give only that level of access that is desired, that is needed to perform, for somebody to perform their job role. Now I'll give one example of network security. Now this is debatable. Okay, so be it any cloud provider. Okay, I'll just restrict myself to Azure for a moment. Right, doesn't matter who the provider is. It could be AWS. Now you have a subnet, right, in Azure. So what are the default networking rules defined? And this also is pretty much with every other platform. So as a default rule, any incoming traffic to your cloud resources is blocked. That's by default. But outgoing traffic is allowed by default. Now, this makes sense because you want to define certain ports and certain things to be, you define something, some rules, and then you explicitly enable those ports, so you want connectivity from the internet to your internal network or from specific services or ports. But there's a default trust factor for outgoing traffic, which doesn't make sense. So for example, if you are using, okay, if anybody was using cloud virtual machine, right, to send company data to an outside entity, by default, this rule means that they will not be blocked. They are allowed. That's a no-brainer. It doesn't make sense. Right? See, internal, we understand that there is external perception of external threat. But how you get an on-premise firewall where everything is nothing is allowed? You have to explicitly configure rules. But here, in cloud setup, any outgoing traffic from a trusted cloud resource is always allowed. Why is that? And that's a de facto rule. Now, this also should be not allowed in the first place. And then this rule should be overridden on specific port for a particular cloud resource to send outgoing traffic to the internet, right? So this rule is by default allowed. That is, if somebody quickly deploys their services, then this is presenting a risk factor. Virtualization security. Virtualization comes with its own set of security concerns. As virtualization deals with hypervisors and host operating systems as well, we need to be cognizant of several flaws in their security. A virtual machine attached to a hypervisor is affected when the host hypervisor is also compromised. Even when you are using containers, you have to be cognizant of these security concerns. Common virtualization security threats include DOS attacks, host traffic interception, VM jumping, they are all examples of this. Now, virtualization comes with its own set of security challenges. Now, while you may not have visibility to the hypervisor, you still need to be cognizant of the fact that if somebody can manipulate at the hypervisor level, any guest operating systems that are running on top of it, they are all compromised. So hypervisor attack, one layer where it has the potential to compromise all the guest operating systems that are running on top of that. If there is a hypervisor attack, this is where your cloud service provider will be under serious repercussions on the cloud service provider's security posture. Let's talk about some of the common threats. Cloud Security Alliance has defined the 9 of the most common security threats in cloud computing. These are data breach, data loss, insecure interfaces, account and service hijacking, denial of service attack and distributed denial of service attacks, malicious insiders, abuse of cloud-based services, shared technology vulnerabilities, and insufficient due diligence. Data breaches can cost a lot of this thing. That's the reason why having a good DLP solution is going to be very effective. Have a good data loss prevention solution, like a force point kind of a thing, will always help you. So let's talk about all of them one by one. So in simple terms, data breach refers to a situation where the data is accessed by someone who is not supposed to have access to it. Your organization should have a data breach policy, response policy, how you respond to data breaches. Is that breach caused by you or by the provider? That will also be interesting, right? So probably it may be caused by the provider. It may be because they are eventually the backend data they are storing for you. It is also possible that this is done by some insider, somebody from the cloud consumer side, customer side. Data loss is also a threat. Here, users may end up losing their personal and valuable data on cloud computing platforms because of various reasons, and if no backup is present, then the data is normally lost. Now, if you delete, one has to be very careful when you delete cloud resources. One should be familiar with, prior to deleting, if somebody is new to the cloud, prior to deleting resources, they should do a thorough check with their counterparts, with somebody who has experience, right? Because when you delete something, and if let's say you don't have the backup of that, your data is gone. So you got to be careful of that part. In secure interfaces, we may expose several APIs to allow integration with customers on on-premise systems, and therefore we need to have proper authentication and authorization mechanism in place. API security is paramount. We need to make sure that integration is secure and APIs are not leaked. So we can deploy whatever security controls are required for API protection, that should be deployed. And also, because API connections are also used in automated platforms. For example, if you're using certain monitoring tools, your APIs, it may be getting accessed by a certain API. If you have set up something like RabbitMQ, like a messaging service, it will be using the API connection. So you got to make sure, you got to be aware these API connections are being utilized, right? And you got to make sure that there are appropriate security controls where all these connections are being used. Account hijacking. So here attackers use methods such as phishing, fraud, and exploitation to gain access to user credentials, and therefore the accounts can be compromised. One has to be careful if they're using their corporate systems, laptops for accessing cloud resources. Externally also, fall into a phishing trap or on a phishing trap, your systems can be compromised and somebody else can also get access to your resources. Then DOS attacks and distributed denial of service attacks. These attacks prevent legitimate users of a cloud service from gaining access to their data and applications because of a system slowdown caused by a large volume of requests coming to these services. Now, DOS attacks we are well familiar with. Then we have malicious insiders, so somebody who is within the organization and has some malicious intent. A malicious insider is a current or a former employee who has or had authorized access to an organization's network, system, or data and intentionally misuses that access to negatively affect its security. Malicious insiders can also cause these issues. Abuse of cloud-based services. A malicious user might end up using cloud services to do some damage to another organization's network, such as distributed access attack, brute force attack to guess someone's credentials. Now it's interesting. You are leveraging, like you are sitting in one location, right? Now think if you are the hacker. Let's say you are accessing the Ireland data center and you are sitting somewhere in a place like Turkey. You're accessing the cloud data center, which is there from the portal. You connect to a virtual machine, which is also in, which is also there in Azure's Island data center. And from there, you try to compromise a system, which is somewhere there in Netherlands. A company's that you're trying to pen test someone or trying to, compromise someone's system. So that's abuse of cloud-based services to target somebody else. Now the traces, what are the traces of what IP address traces with, if any, on the victim side? They will see the cloud service provider traces, not your traces. They will not be able to. It will be hard for them to reach out to you. While it's not certainly not impossible, but it will be a bit hard for them to reach out to you. Share technology vulnerabilities. Since cloud providers use virtualization, if any host system becomes compromised, then multiple virtual systems become compromised as well. Best example, if there is a hypervisor attack, all the guest operating systems running on top of it are all compromised. Insufficient due diligence. If an organization uses cloud computing services and they do not take care of security on their end using techniques such as encryption, security monitoring, etc., then an attacker could exploit these loopholes. Most of the times, it is out of all the 9 problems, it is insufficient due diligence. For example, bad configuration. For example, not focusing on the prior to deployment or prior to coming on the cloud, the NDA, non-disclosure agreement with the cloud provider, the SLA with the cloud provider, right? All those also, just because you come on the cloud provider, while some customers still think about deploying a web application firewall in front of a web server, there are some customers who just come on the cloud feeling that, okay, this is not our setup. Microsoft is managing security for us. We pay them on a monthly basis, let's say $2,000, but they are managing it for us, so we don't have to worry about deploying antivirus or anti-malware solution. And the next moment, a month later, you see that your system is compromised, and then you end up blaming the vendor, cloud service provider. It was your prerogative. You should have done due diligence on what are the cloud providers' responsibilities and what are your responsibilities. So many times it is 8 times out of 10, it is insufficient due diligence, which is the single largest threat amongst all the threats. Now, secure cloud computing design principles. Now, these are the 5 key principles relevant to secure cloud computing. These are cloud security data lifecycle, disaster recovery and business continuity, cost benefit analysis, functional security requirements, and cloud categories, security considerations. Let's touch base upon all of them one by one. Now, what is the cloud security data lifecycle? It's very easy, actually. You have 6 stages. You have the create stage, store stage, use stage, share, archive, and destroy. And I'll quickly touch upon it. Now, let's say you are a company that is involved in some sort of forecasting. Let's say you are your organization is building revenue management software for hotel industry, right? And you are deploying your services on the cloud. Now, given this, so for instance, we are well aware that 3 weeks from now, right, during the time of Christmas, you can expect a large occupancy in hotels. So most of the hotels will be, filled up, and that pattern will continue for another 1 week till the New Year's Eve, right? So probably somewhere from a day prior to the Christmas till 2nd or 3rd of January, many people will actually go on leave, right? That's the time when hotels are occupied. It's a well-known fact. So what will happen is the pricing on those days will be very high as compared to. So if you look at the hotel's rooms price on 20th of December, and if you compare that to 25th December or on 1st of January, you will know that there's a huge difference. On 20th December, the price will be a lot lower than 25th December. So this company is building revenue management forecasting. It gives predictions to hotels, so that they can up their pricing accordingly based on previous year's data, right? So the first thing what they need is data. So probably this company, which is a new startup, it would have crawled or got some data from Expedia, may have done some web crawling and would have got some data, so that data is now raw data that you get, right? Now this raw data is not of much use because it is not doing any business intelligence. Now you create that or you get it from someplace, right? and then you store it, you dump it somewhere, let's say in your object storage. Create and store. Now what you do is you apply ETL, extract, transform, load. You get the raw data, you store it, then you transform that data. So convert the raw data into processed data, and that is generally done through data extraction, applying some business logic. You transform the data. Once you have transformed the data, the raw data is now converted into processed data. Now this processed data can be used in business reports. Now you can use it for forecasting and something. So now you can use business intelligence tools like Tableau and so others to give some numbers or present some reports. So now this is used for you, right? And now because it is usable, you can share the data with your customers. So what's the time of use phase? The use phase comes after transforming the raw data into processed data. So it's probably used in reports. Then you share the data with the other users, right? You share your reports with the users. Now, once the transformation has been done, once the data has been consumed, it's been used in business reports. Now this data is not current. It's no longer of much use. So now you can archive this data. You archive the data, you may still require that data at a later stage for historical retention requirements, for historical reporting. And once you have crossed the stage of requiring this data for business requirements, you can destroy the data. That covers all the 6 phases: data creation, data storage, data being used, data being shared, data being archived, and data being destroyed. That's the 6 phases. That is exactly what your cloud secure data lifecycle is all about. So first stage, create stage, get the raw data on it, create the raw data or get it on the cloud platform. Then store it. In this stage, data is at rest and stored on a cloud computing platform. Now you can decide if you want to store this data on an object storage or you want to store this data on a block volume. That's all up to you. Mostly it will be stored on a block volume. It will not be dumped on the cloud. This thing, because retrieving the data from object storage, and so retrieving and addressing that, right, that takes a bit of time. So there are latency issues. Object storage is not designed for fast performance, so it's not designed for real time, for OLTP setup. So that's the reason why you would be using block volume. So once you have used it, in this stage, data that was stored earlier is being used by a user inside a cloud computing service, yes, and then share. So here many times data is shared among different people with different levels of authorization. So as I said, as an example, I gave this where BI reports are being generated and they're shared with business users. And then you archive the data. This data becomes stale. It's no longer relevant for current business needs. It is still relevant for historical requirement, but it is no longer. So what you do is now you push this data from your block storage to object storage like S3 buckets or Azure Data Lake. And finally, once it has crossed that requirements, you can then go ahead and destroy the data. Right? So let's move on to disaster recovery and business continuity planning. In cloud computing, the 2 major design concerns with respect to data are DR and business continuity, disaster recovery and business continuity. Now, before I go further, we need to distinguish between DR and business continuity. Now, I will say that DR is a subset of business continuity. BCP, business continuity, is larger behemoth, right? It's the giant. Now, what exactly is DR and business continuity? Business continuity talks about any interruption in business services. So there is some interruption. That interruption does not necessarily mean it's an outage. Disaster recovery means it's an outage. That's the simple thing, right? Now, because outage itself is an interruption, but it could be for a longer time. And there could be that because of some internet latency issues for a minute or so, your web server was not accessible. So that's an interruption, but it's not a disaster. So we need to be clear with the definition between DR and business continuity. So disaster recovery, it's the plan of action that needs to be implemented when disaster strikes, such as loss of data, data integrity violation, etc. And business continuity, it's the objective of disaster recovery systems is to ensure business continuity and prevent organizations from suffering substantial damage in the form of losses to revenue, reputation, market share, etc. In short, business continuity is interruption in services. Disaster recovery seems clearly means outage. For business continuity, there are two major success factors. These are understanding, so what are your responsibilities and what are cloud service providers' responsibilities. Clearly state and prove what the cloud service level agreements components are covered.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And the depth of the coverage. Now, for DR requirements, you have to be very, very clear. You have to be absolutely clear with what you are going for. The cloud providers can, their marketing guys can fool you, So you got to be absolutely be sure what you're going. Simple thing. Are you deploying your applications in the same region or in a different region? Are you going for local backups or are you going for geo redundant backups? Are you doing point in time recovery? What's the lag between your production and standby systems? Like if you have a production product PostgreSQL database and if you have a standby database, let's say you have the production PostgreSQL database running in your Ireland data center and the standby is running in the Netherlands data center. What is the lag between them? Are you keeping your standby services up and running all the time? Or are you restoring from backups? What is your planning? So all those things. Have you tested your backups? Is the cloud service provider now, because it's all in the form of a single click. What about the reliability of backups? Whatever backups that you have taken, those backups are with the help of a single click on your browser, you are doing the backups, right? So all those are considerations that need to be talked about when you sign your NDA and when you sign your SLA. So you see, we are going back to square one, which is before coming on the cloud, make a note of all these things. Talk and discuss with your cloud service provider all these things. Backups can fail. All these things can happen. So if this was an on-prem system, what would we be doing in general? We'll be taking the backups on a weekly basis or depending on a fortnightly basis. We'll be testing our backups. That's what you would have a COP system, which is your continuity on business systems, where you will simply restore your backups, you will test your backups. While you may test your backups in the cloud, you're not going to set up every now and then, you're not going to set up, if your backups are working, what if they become corrupted? That's how do you validate that? In Oracle, you have a utility called as RMAN, Recovery Manager. There you can test the backups, you can validate the backups, you can do all these things. Security concepts, cost benefit analysis. CBA plays a major role in deciding security concepts and the solutions. Cost benefit analysis allows us to compare different platforms on the basis of expenditure needed for a service with the value provided by a service. Now you see why we are talking about CBA, because unlike software development, when you talk about security, here you require investments. There is no direct monetary benefit as a result of implementing security controls, right? So whatever you deploy, it has to be seen from the context of cost benefit analysis and other techniques. There is no direct monetary benefit of deploying security controls. Its cost has often been called the key driver for whether an organization will adopt cloud computing some capacity. Different cloud computing solutions provide different services at different prices, and they need to be thoroughly examined to choose the best option. Functional security requirements. Functional security requirements in the cloud, these are portability, interoperability, vendor lock-in. Yeah, many times, if you work with Amazon Redshift or DynamoDB, that there can be a vendor lock-in feature. Portability, easily and securely moving data from one service to another service. That is portability. Interoperability, multiple services being able to access and manipulate data securely. And vendor lock-in, moving encrypted data from one cloud service provider to another cloud service provider securely. This can be a hazard, and with databases, especially with databases which are like, for example, if you're working with RDS for PostgreSQL, right? That will still work because in PostgreSQL you can take logical backups. So if you have a larger data set, you might still be able to take a schema level backup and, or make a table level backup, you will be able to do a schema level backup easily and move on to another platform. But if it is DynamoDB or if some vendor specific thing, then it will be hard for you to do that. Design principles, cloud security considerations. Depending on the service model, we can have different security considerations such as software as a service, platform as a service, and infrastructure as a service. Okay. Software as service, here the data is being encrypted when it is transmitted over the network. Is the application preventing against common attacks such as SQL injection, cross-site scripting attacks? XSS stands for cross-site scripting attacks. Are proper measures in place in case of application security being compromised? So all those are the questions that we need to answer. Platform as a service. Interestingly, this is very interesting. Are we using the latest version of platform services? Are the softwares being used in deployment up to date with latest security patches? Is the deployment process using the latest security standards? We come to infrastructure as a service. Here we have to ask questions related to, are all the networks properly configured? Are all proper backups and replication strategies in place? Do host machines have the latest operating system and security patches installed on them? All of these are questions. Evaluating cloud service providers, and then now there are three major ways of evaluating cloud service providers. You've got to look at if they are certified with any specific standards, security standards. ISO 27017 is related to cloud security, PCCI standards, and there are some government security standards, as well. As an organization, you want to see if with how many security certifications this vendor has. That gives you a good posture of their security apparatus. ISO 27017, it provides standard guidance for implementing security concepts in the cloud. Many cloud computing providers offer services that comply with these standards. So if we see this, it will tell you how this vendor has this level of security posture. So it's only a certification attestation by a third party. So that just tells you that at least they have some decent level of controls. But still, don't just go by the nomenclature, right? Just don't stick by that. You'll have to also consider other specifics as well. PCCI DSS, it stands for Payment Card Industry Data Security Standard. By the way, in countries like Australia, they completely mandated the use of PCCI DSS as a standard. So whether you go on cloud or not, the whole idea is that you will still be bound by the rules of PCCI DSS. So if any company is compliant with that, good enough. And then there are different government agencies, right? That are subject to different security standards which need to be adhered by cloud computing providers. You can talk about the NIST, cybersecurity, any of the best practices. You could use the common criteria certification for hardware and software products. Standards, you can use the Federal Information Processing Standards. Obviously, these are US-based standards to certify cryptographic security in government services, all those kind of things, right? What is our understanding? What all things can we do? We can set up a infrastructure as a service platform. We can use the platform as a service solution, and then we can go for software as a service. Right? So these are some of the things that we are very familiar with in this. Right? Now, when we talk about infrastructure as a service, we can deploy virtual machines, and on top of that, you can probably go and deploy any application or specific tools. Right? When it comes to platform as a service, I mean, this is nothing but inherent cloud services that we're using. So for example, let's take Amazon RDS or Amazon Redshift, which is a data warehouse. And SaaS, we are well familiar with tools like Office 365. We are familiar with G Suite, Salesforce. These are some of the tools that we are well familiar with, right? Now, this is where we end up going. Then our understanding is, then we talk about the containers or the microservice architecture, right? That's the another piece of it, microservice architecture, okay? We talk here about things like what Kubernetes, Docker containers, right? And then obviously, I'm going to be attaching this to obviously with the configuration management tools like Ansible, Puppet, and Jenkins. So bottom line is the entire DevOps, your Git services and so on, right? So this is the entire modus operandi when it goes towards the microservices architecture. Another thing is this the only piece of it? Can we go, is there a different dimension to the cloud beyond this? I mean, this is in general what constitutes the entire cloud. But is this all? Has cloud got nothing further to offer? I mean, these are the questions that we need to get around and see if we can get responsive on that. Now, what are the existing differentiators? Okay. Now, for instance, if you want to do threat hunting, okay, one of the amongst all the vendors, the only native tool, this feature is not available in Oracle Cloud, not in Alibaba Cloud, not with Google, not with Amazon. It's only available with Azure. Now, when I say cloud native threat hunting solution, which means the vendor specific itself. So now the vendor like Microsoft offers Sentinel, Azure Sentinel. Now this is roughly a product that's almost 2 years old. And this is a SIM tool. It's a security integrated event management tool. Okay. So basically it can aggregate all your logs. You can centralize all your logs in one place. And this tool can read all your logs and convert that information into some sort of security analytics. So it gives you a dashboard. It looks out all the logs, finds out based on the rules that you define, and it can have its own defined rules because Microsoft leverages its own machine learning and AI algorithms to find something suspicious, and they can report such things. So that's the role of the Azure Center. And this is somewhat different from the other thing because the other vendors don't have an in-house software, right? That's the whole point. Now, if I talk about, and that's where you will start looking towards third-party solutions. That's where you will start looking towards third-party solutions. So this is the initial differentiator. The other part is, now when it comes to SaaS tools, are we just focused on Office 365, G Suite, Salesforce? Is that it? Is there nothing else that could be offered? So there are multiple solutions available, and we'll touch base upon each one of them. And that's the whole idea. Now, I'll talk about something called as CSPM, okay, which is nothing but Cloud Security Posture Management. And then we have something called as SSPM, which talks about SaaS Security Posture Management. Now, if you look at the list of controls, it's exhaustive. Whatever we're talking about here, it just doesn't end here. That's not the world, right? There's a lot beyond it. So for instance, if you look at this cloud control matrix, and now for instance, let's take an example. Now, let's say you have some financial firm like Bloomberg, right? So if tomorrow Bloomberg comes with a SaaS tool, or Franklin Templeton comes with a SaaS tool for wealth management, which is one of the important verticals for financial services. So if that happens, that tool will be successful because there's a growing demand for all these kind of things. And it provides seamless connectivity, because if I can have my wealth management reports through my app, that's a lot better than just logging in physically and all those kind of things. But what about the security of this wealth management app? What about it's a SaaS tool, so how secure it would be? Those things bring a different dimension. Now, imagine if you are a SaaS provider and your customers, if you are Franklin Templeton, if you are executive, one of the employees of Franklin Templeton, your clients will, come back to you saying that, hey, what about the security of this, right? You are taking in our data. What about the security? Is there some way we can get some kind of reports that ensures that your SaaS tool is good enough from a security landscape? So the moment you talk about SaaS security, your customers will be convinced about, or if you're SOC 2 certified, it adds a lot of credibility to your organization. And it gives your customers, they can get a sense of security, because if you're SOC 2 audited and you're certified, that demonstrates your layer, that how good or how well.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
Your security posture is being managed, right? So SOC 2, that's a very relevant point. And this is what most of the SaaS providers end up doing. I'll give you one good example. There is a Singapore-based company called as Horangi, okay? I often deal with them. Horangi is basically a CSPM provider, Cloud Security Posture Management. First, let's see what is Cloud Security Posture Management, right? CSPM. You can see here, Cloud Security Posture Management is Cloud Security Posture Management automates cloud security management across the different dimensions of your cloud. So for infrastructure as a service, instant computing of infrastructure provision and manage over internet and your SaaS service, right? What it does is it provides the necessary security control over all these things, especially. So if you have certain misconfigurations, it can check that out and it can help you to, it can detect that. Something that anything else will not be able to do, right? So your CSPM solutions can automatically and continuously check for misconfiguration that can lead to data breaches and data leaks. This automated detection allows organizations to make necessary changes on a continuous, ongoing basis. Now, misconfigurations can happen anytime there because everything is human controlled. So misconfigurations can happen anytime. This can happen through your APIs. It can happen through some human errors. You leave one door for the attacker to enter and they will definitely enter and they will damage your infrastructure. So you got to look at your posture management and mostly to do with security misconfigurations. That's where your cloud security tools like Horangi, they help not only to improve your cloud security posture management, but they also help you to meet regulatory compliance. Now, especially if you're in Singapore market, they have something called as mass compliance, right? It's a regulatory compliance within Singapore market. That tool itself, if you are completely deployed on cloud, and especially if you are a bank, then that compliance is already met there, right? With the help of tools like Horangi, you can achieve you can achieve compliance as well as you will not have any security misconfigurations. So that's the whole idea. And the next part is that now, just for your knowledge, Horangi as a company, okay, itself, they offer a product, right? And they themselves are SOC 2 certified and they got it recently. Now they're offering a product called as Warden, right? And they are themselves SOC 2 compliant. So they recently got the SOC 2 certification themselves. So you can see one of the first companies in Asia to achieve SOC 2 Type 2 compliance and certification. Because they are offering a tool for your compliance. They can look into things like access control, change management, risk mitigation, system operations, all these kind of things. So a lot of these things will be helpful, So cloud security posture management, it helps you to improve it gives you visibility. Checkpoint offers, CloudGuard, Horangi also offers certain tools, and there are many other vendors in the market who give out these kind of tools. Okay. Then your SaaS security posture management. Now your SaaS security also needs to improve. That's another piece. Then, now for instance, Azure offers a web application firewall. Now, does it have all the features? Azure also offers a network firewall. Is it something that is comparable to Palo Alto, those kind of things? I think these are the questions that you need to think about and answer. You got to see if the native cloud vendor is giving all those features. Now, moving to the cloud itself comes with some risk, and this is what organizations take. But these are some of the things that we have to be very clear about. What are the responsibilities between the cloud service provider? Are they willing to sign NDA? Are they willing to get a customized SLA and get down to your requirements? Are they going to fulfill that, or are they going to back down from that? Now, legal risk and compliance, let's talk about it. Now, in this, we'll be talking about legal requirements and unique risks that are prevalent within the cloud environment. Now, when trying to understand the legal requirements in a cloud setup, we need to understand a few important points. These are conflicting international legislation, evaluation of legal risk specific to cloud computing, legal framework and guidelines, eDiscovery, and forensic requirements. Now, conflicting international legislation. For instance, if you are GDPR going to be GDPR compliant, and if this law is a conflicting law with another law in another country, then it presents you with some sort of problems, right? You will have to deal with both the federal agencies in both these countries or locations. So whereas GDPR says that any data stored in Europe, any PII data or any such sensitive data that is should be stored in European soil itself. It should not be stored outside European countries. So technically, even now, with the exit of United Kingdom, even Britain is also out of it. You know, if you're going to be storing some data in London data center, technically from a GDPR standpoint, they're out of it. So these are some of the things that we'll have to be very careful about. Now, for US, this is a law and it works in the best of their interest. But for Denmark, probably if the Danish data is going in American data centers and PI data, it could be a violation of GDPR. Whereas as per the Cloud Act, it is absolutely fine. So there can be conflicting international disputes or international laws that can present you with conflicts. And because every country have their own legal jurisdiction, there is no global or defined framework that addresses common international concerns. It's not the case. It is only with encryption. Beyond encryption, nothing else is similar. Evaluation of legal risk specific to cloud computing. So there can be potential legal risks specific to cloud computing. There can be. There could be certain legal frameworks and guidelines and eDiscovery and forensic requirements. So these are some of the important aspects we need to be absolutely clear about and address things accordingly in the cloud world. The simplicity of computing and storage provided by the cloud has led to a complexity of legal issues. And the number one problem around the world is data privacy. Data privacy has really picked up pace from data protection issues from 2015 onwards till now, and they're pretty much new legislation almost coming out on a regular basis. Many countries are adopting certain frameworks, and thereby new regulations are coming out, and that presents you with complexity. Now, you cannot store China's data outside Chinese data centers. However, China expects Chinese firms to provide them with data that may be stored in, let's say, in Malaysia or in Singapore. So there are potential international legislations which can be a potential source of conflict. Now, below is a list of the possible sources of international legislation conflicts that we must keep in mind when we're dealing with legal technicalities in cloud. So, for instance, copyright law, intellectual property, breaches of data protection, violation of patents, privacy-related components, and legislative requirements. So there could be a breach of any of these things. And there could be these 6 areas, there could be a potential violation, especially when you're dealing with international boundaries in any of these 6 areas. That's the whole point. Okay. Cloud computing can be subject to several legal risks. There are a huge number of laws and legislative items which may impact cloud environments, such as legislative law, state laws, copyright law, piracy law. So there can be some anti-piracy laws as well. Now, cloud computing can be subject to several legal risks. When coming up with a legal strategy, these specific laws should be thought of about very carefully. Many of the laws may be location specific, so we need to take that into consideration as well. Also, possible mitigation using certifications and regulatory compliance should be considered carefully. To any extent, you can, whatever mitigation techniques you can do, you should just try to, you cannot completely eliminate risks, especially if you're in cloud, or even generally you cannot completely eliminate risk. But in the world of cloud, there are more areas to cover. Hence, there are more risks that are prevalent. So you should try to minimize your risk to the maximum extent possible. Let's talk about legal frameworks and guidelines. Now, there are several legal frameworks and guidelines which may help in dealing with legal issues itself surrounding cloud computing. Depending on the geographical and judicial location of the users and cloud service infrastructure, different legal guidelines may apply. For instance, if your operations are located in EU, then EU Data Protective Directive may apply. In short, EU Directive 95/46/EC is intended to protect the data privacy rights of European citizens. These guidelines focus on the quality of data, legitimacy of data processing, special data processing categories, the data subjects, data access rights, etc. So there are, in short, they're addressing all data privacy related concerns. Also, to better deal with the legal and privacy related processes, there are few legal frameworks which you can take a look at. For example, the Asia Pacific Economic Cooperation Privacy Framework. Now, the goal of this particular framework is to promote consistency of approach to information privacy protection. This framework is based upon 9 principles. So the principle that we're talking about is the Asia Pacific Economic Cooperation Privacy Framework. And what it talks about is 9 common principles. The first one is integrity of personal information, choice. Let's say you're trying to get access to somebody's information. You're requesting that person to give consent. That person has the right to allow you or not allow you. So it's a matter of the subject's rights. Now, once the consent is provided to you to store that person's information, what are the security safeguards that you as a data controller are having to make sure that the recipient's information is adequately protected? Accountability. So you are accountable for making sure that you as a data controller, because you are holding the data of some individual private data or their personal data. So you are accountable to make sure that security is paramount and the data is adequately protected and accurate information is available when requested. Access and correction. So let's say tomorrow the persons whose data you have stored comes back and will ask you, will want to see what information about him or her has been kept in your systems. You will have to furnish that information. And if there is anything information which is wrong, he may request for correction and you are obliged to carry that correction out. So for instance, if a person has changed their middle name or they've changed their last name, so if they want any correction there, you are bound to do that if you are a data controller. Now, these guidelines and frameworks are there. They help in dealing with legal matters. These are highly subjective to the geographical location and judicial boundaries that apply to a particular data center. You need to do your due diligence in understanding what legal guidelines and frameworks are important for you to understand. So far we actually touched base upon privacy related aspects. The next part is about eDiscovery. eDiscovery refers to any process in which electronic data is sought, located, secured, and searched with the intent of using it as evidence in a civil or a criminal legal case. eDiscovery involves the following main steps. Identification. Data that is potentially relevant to a case is identified along with its location, custodian, size, volumes, etc. Preservation. The identified data is placed under a legal hold, starting the formalized forensic process. Collection. Data is collected from the original custodian, typically by physically removing the original digital storage media. This conversation, these 3 steps, if you purely look from digital forensics within cloud, it throws 2 interesting questions. When you know the original evidence is identified, now typically what will happen is, if this was an on-premise setup, you will physically see that machine and that will no longer be under someone's control. As a part of the agreement, the log is to be kept for 30 days. Now it's the 29th day, or let's say it's the 30th day itself. And that's the time when this preservation is required. Will the data be preserved beyond 30 days, which is agreed because it is required for forensics? That is a potential, catch here. It's a catch-22 situation because as per your agreement with the cloud service provider, after 30 days, they will not preserve it. They will just rotate the logs. So which means that you will have no longer logs. 30 days preservation time period is over. That would be one thing. And the other thing is, defined in your contract where it says that preservation of audit logs will be required for digital forensics. So there could be conflicting situation within the contract itself. So at one side it says beyond 30 days it will not be kept. On the other side it says for forensics it may be required. Now, how you deal with this thing? Now, it's a potential bottleneck because there is no overriding scenario here. One side says, the cloud service provider says, yes, I will preserve the logs, but that's the thing. After 30 days, I'm not required to do so. On the other hand, it says that the logs for any digital forensics investigation that a customer wants, such evidence needs to be preserved by the cloud service provider. Now, in this case, now if such a conflict occurs, if I look out from a legal standpoint, probably the second point, which is that if the customer requests for digital forensics, in that case, probably indirectly, because that part is being said, it's 30 days doesn't matter, but you still need it. If they requested it, you may need to preserve it for longer than 30 days. So if that's the case, the second part of that probably gives a clear answer here. Processing forensic bits are stored in a form that allows them to be searched or analyzed for information that is relevant to the case using suitable forensic tools and platforms. Review. Forensic bit copies are searched or analyzed for information that is relevant to the case. Analysis. The information is further analyzed and assessed as to its relevance, suitability, weight, meaning, implications, etc. Production. Relevant information from the analysis plus the original storage media, etc. is formally presented to the court as evidence. So these are the steps. You first process the information, review it, and you don't directly work on the original evidence. You actually seal it across. You make copies of that.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And you analyze the copies on which you have copied the data. You copied the evidence data, right? So then an analysis, and then you produce relevant information from the analysis plus the original storage media. Now, take into account two factors. One is that we are well aware that you can use the hash codes, the hashes. So if X data has a particular hash value, another copy of that will also have the same hash value. At least you can correlate that, because the same hashes, more or less, they produce the same data. If two hashes are the same, it means data on this machine and the data on the other machine is the same. That's the basic assumption. So if you go by that principle, even if you present copies, this could be presented as a valid argument in court. Forensic requirements. For proper cloud security, we must understand and accommodate cloud forensic operations. It has several considerations, such as cloud forensic is a subset of digital forensics based on the unique approach to investigating cloud environments. Cloud service providers have servers around the world to host customer data. When a cyber incident happens, legal jurisdiction and the laws that govern the region present many challenges. A court order issued in a jurisdiction where a data center resides will likely not be applicable to the jurisdiction for a different host in another country. So this is also a potential problem. In modern cloud service provider environments, the customer can choose the region in which data will reside, and this should be chosen carefully. I mean, that's something prerogative of the cloud customer, and they should do their due diligence to make sure where they're hosting this data. In PaaS and SaaS service models, customers must depend on the cloud service providers for access to the logs, as they do not have control over the hardware. That's true in PaaS and SaaS. That's definitely true. In the IaaS platform also, there's a defined, 30 days, 7 days, like depending on the cloud service provider, right? So there is a default policy after which the service provider itself will start purging the logs. Understanding privacy issues. Privacy issues in cloud usually stem from misunderstanding or incorrect implementation of one of the following ideas, difference between the contractual and regulated private data, country-specific legislation related to private data, jurisdictional differences in data privacy and standard privacy requirements, difference between contractual and regulated private data. Contracted and regulated private data might seem the same, but they are different and they need to be treated differently. Contractual private data is data for which all the parties are contractually bound to only work with provided data in a legally restricted manner, which means the only operation specified in the contract, which is agreed upon by all parties, can be performed on the data by the parties involved. On the other hand, regulated private data is defined as data that requires implementation of specific privacy and security safeguards as mandated by the federal, state, or the local law, or your own organizational policy or any vendor-related agreement. This means that this data can be worked on, stored, retrieved, and worked up under very specific conditions by authorized country-specific legislation related to private data. Now, one has to be very careful regarding this. Now, for example, in Canada, you have to be aware of the data privacy, requirements. This is Canadian. Similarly, if you are in Europe, it is GDPR. If it is the United Arab Emirates in the Middle East, they have their own data privacy law. They have their own privacy this thing. So many countries around the world have their own this thing. In fact, Switzerland being directly under, they have their own data privacy laws apart from GDPR, right? So they have their own specific data protection laws, So for instance, we are well aware that in Switzerland, it's the hub for financial activities, right? It's a financial hub. And whether you go to Geneva or Zurich, you talk about a famous bank like UBS, right? UBS, probably one of the top banks around the world. It's so hard to get customer data there, right? I mean, accounting data, so many countries have requested. And, we have seen for over a century, it was a secretive system, right? So if, let's say, China wants to find out which individuals from China are holding a Swiss bank account or how much money they are holding in Swiss bank, that's something it will be hard to obtain, because Switzerland have their own privacy and it operates in very secrecy, right? So it's hard. So apart from GDPR, there's so much regulations around there. Now that some sort of agreements are coming between some countries and they're coming up with that, but still it's pretty hard. This kind of data is pretty hard to obtain. So the whole idea here is that every country could have their own data privacy or data protection laws. One has to be careful regarding with these laws and be aware. There has to be some sort of awareness regarding that. That's the whole idea. Different countries may have different rules and regulations that govern storage and treatment of private data. In cloud computing, data centers which store data and workloads are usually spread across multiple counties and even continents. Because of this, dealing with private data and the laws applied to them based on the geographical locations can be very tricky. Now, I'll give you a good recent example, something which happened last year. India still does not have any data privacy law, in practice, right? There is a draft bill, it has to be tabled, but there is no such legal provisions around it at this point in time. Last year, that's the case. Last year in 2020, there was a serious concern regarding the social app TikTok, where the concern was that it was storing TikTok application. It was storing the data of customers in India and around the world on Chinese servers. That became the contentious point for the Indian government to expel TikTok out of India. So TikTok and some other Chinese companies, under which there were concerns that they were storing the data of Indian citizens on Chinese servers. So as a result, even though the data protection bill is not yet out, they were out of business last year. So they are pretty much out of India. Yeah, that's right. Personal data protection bill, it's still not completely out. It's not defined, right? So pretty much it. So while it's not completely out, and still this happened, right? And there are concerns around with other Chinese companies, specifically Hikvision, which is one of the world leaders when it comes to the CCTVs, right? So there is a serious concern regarding how Hikvision, may be storing. So here, in many parts around the world, for example, there are CCTVs that are deployed on the roads specifically because if people are overspeeding, your Hikvision CCTV cameras can make those notes or can capture those details like automobile numbers, the vehicle numbers, and then these people can will be liable to pay some penalties if they're over speeding or something like that, right? And even when these are deployed around some cities here in this part of the world, there is a serious concern that Hikvision is actually sending this data in Chinese servers. Same thing happened with Huawei, right? I mean, why Donald Trump was so aggressive around the fact that Huawei 5G's infrastructure was capturing, it had a lot of security concerns and it will capture some of the user details and will be sending this data to Chinese servers. Potentially, that was the reason why it was kicked out of US and it never came, it was never allowed. And it's pretty much out of business, at least in pretty much in Canada, at least in front of 5 Western countries. Like it's out in Canada, it was never established in US, never established in Australia, New Zealand, and UK also. Britain also kicked them out, and there's now a chance that countries like Germany would also follow suit, right, where they may not be adopting their 5G infrastructure. So you see that these are the concerns around the world. Okay, let's move on. So each geographical location may have their own legal rules and regulations for data privacy and protection, which needs to be followed by the cloud service providers. For example, EU maintains that the GDPR applies to the personal information of all EU residents where they might be located. And these nomenclatures are also changing. Now, for instance, with Britain, they have exited the European Union. And there are certain data centers, Azure maintains it in London, Southampton, they all maintain certain data centers in UK. Now, what will happen with the Britain's exit? So if some of the, whatever customers data was there in this thing, let's assume that the UK data center was used as a backup data center for the data that is hosted in Netherlands. So now with UK exiting the EU, what will happen to those customers whose data is there in UK data centers? Now it's officially out of EU, so would that also be treated as a breach? What will happen to that kind of things? What provisions are there in place? So jurisdiction, another thing to keep in mind when dealing with legal rules and regulations that apply to data centers and data stored in them is the jurisdictional rules. Jurisdiction is the practical authority granted to a legal body to administer justice as defined by the kind of case and the location of the issue, which is to say the location of the data center may also determine which legal bodies have authority to dictate rules related to the management of private data. Now let's talk about something interesting in regards to this international laws. Okay, let's talk about a country called Austria, which is near to Germany and near to Poland, nearby Czech Republic. They have some very interesting laws actually. Now what they say is crime is committed by any Austrian individual, okay, in Austria or in any part of the world beyond Austria, they will be held accountable for that guilt, for that breach of law. So let's say if an Austrian citizen is in Singapore, right? And this citizen is earning good money, and let's say they violated this resident violated some law, right? Some data privacy, legislation in Singapore. And then for his holidays, he goes to Australia. And before he comes back, he realizes that, some people inform him that, hey, did you do something like this? And now this person is stressed and he doesn't want to come back to Singapore. He is happy back in Austria. He probably look out for some other job. He's just happy there. A data, any such breach which involves some sort of digital computer crime, that's being committed by an Austrian resident in Singapore. And even if Singapore and Austria do not have any extradition treaty, any crime committed in Singaporean soil by an Austrian, that person will still be held liable, guilty within Austria itself. Now, that's really fascinating because no such country around the world, at least as far as my limited knowledge goes, has such provisions. Austria is definitely one exception. So beyond its boundary, it does recognize the norms or the laws of the other countries. And if their own citizens commit a crime in another country, irrespective of how grave the matter could be, a crime is a crime. That's the notion they go about. It helps to resolve international conflicts because that's the way to go about it. Standard privacy requirements. Depending on the geographical location, there may be several guidelines, regulations, and practices which you may need to follow. Here are three of these. You can take a look at that. ISO 27018. You can look at GAP. You can look at GDPR. ISO 27018. This document establishes commonly accepted control objectives, controls, and guidelines for implementing measures to protect PII data for the public cloud computing environment. The objective of this document is to assist the cloud service customer and the public cloud PII processor in entering into a contractual agreement. The guidelines in this document can also be relevant to organizations acting as PII controllers. So this can help you. GAP, Generally Accepted Privacy Principles, is a framework intended to assist chartered accountants and certified public accountants in creating an effective privacy program for managing and preventing privacy risks. The framework was developed through a joint consultation between Canadian Institute of Chartered Accountants and American Institute of Certified Public Accountants through the AICPA CICA Privacy Task Force. So it's a, GAP is a common principles between US and Canada. It's applicable within North America. The GAP framework was previously known as the AICPA slash CICA privacy framework. It is founded on a single privacy principle that the PII information must be collected, used, retained, and disclosed in compliance with the commitments in the entity's privacy notice and with the criteria set out in generally accepted privacy principles issued by these two bodies. Then you have GDPR, which is came into effect in 2018. It's a regulation in EU law on data protection and privacy in European Union and European Economic Area. It also addresses the transfer of personal data outside EU and EE, European Economic Areas. The GDPR's prime and the sole aim is to give individuals control over their personal data and to simplify the regulatory environment for international business by unifying the regulation within the EU. The GDPR 2016 framework has 11 chapters concerning general provisions, principles, right of the data subject, duties of data controllers or processors, transfer of personal data to third countries, supervisory authorities, cooperation among member states, remedies, liabilities or penalties for breach of rights, and other miscellaneous final provisions. Now you see the term data controllers and processors. Data controller is a person who is storing your data, who is requesting for access to your data, request for consent, and they are storing the data. Data processors are the people who access your data on behalf of data controllers. Okay, so that's the difference between the definition of a data processor and a controller. And GDPR came into, it was being defined around 2016, finally came into effect in 2018. Understanding audit process methods and required adaptations for a cloud environment. So let's talk about this part. Auditing in cloud computing is very important. There are several aspects to it that we need to understand. The internal and external audit controls, the impact of audit requirements, restrictions of audit scope statements, gap analysis, your policies, internal information security control system, identify assurance challenges of virtualization cloud, audit planning, identification and involvement of relevant stakeholders, impact of distributed ID model, type of audit reports, internal information, your ISMS, and specialized compliance requirements for highly regulated industries. Now, a simple point to consider here is if you are going for a important assessment, you could always go for a star cloud audit. Okay, it's one of the most comprehensive and one of the best audits that you can get around. So star audit is This is what I was talking about. You can go for this is a star program, right? You can go for a star level 1 audit and all those kind of things, right? So a company that is star certified like BSN, they can do a star audit for you, and they will do it on the basis of your cloud control matrix, right? So it's the one of the most comprehensive it's CCM, cloud control matrix, and they will check around all these security domains, which is quite comprehensive in its own right. So it'll be all around this. Internal and external audit controls. Now, audit can be of two types. You can go for internal audit, you can go for external audit. Internal audit is obviously performed by your own people. Audits performed by a designated company employee to make sure all operations are following standard practices and logs are being maintained. For example, you can get somebody from your dedicated info cybersecurity team to do an audit. If it is a CISO, can get some of his staff members to conduct an audit for you, right? To conduct an audit for your applications, which is hosted in the cloud. And then comes the external audit performed by an external entity elected by stakeholders, by company stakeholders, to check and verify operations and standards are being met. So that is the external audit. Now, what is the impact of audit requirements? The nature of cloud computing has made auditors reimagine how they audit. Auditors now have to worry about several questions such as, what universal population do we sample from? What are the sampling methods for this? How to tell if the virtualized server that you're auditing is the same as it was before? So identify assurance challenges of virtualization. So there are three main challenges in service assurance in the virtualized cloud environments. One is ensuring that the data acquired from a network and its processing happens in real time. So that's number one. Number two is building service models that are always synchronized with the state of the network. And number three, converting network or oblique service data into meaningful analytics to serve the business objectives. So these are the three main challenges in service assurance. The thing is that the only factor that is within your control is the fact that you can create certain metrics by the help of which you can count. So for example, if you have a production server and you have a standby server, you can take into account things like the latency factor, all those kind of things. But always remember that you don't have complete physical access. So to get real visibility into things like how much of this is happening real time, you will not have all the metrics available at your disposal, especially when you're setting up these kind of services in the cloud. If the same was in your on-prem data center, it was easier to calculate or get those metrics, but the same is not holding true for the cloud world. So let's take a look at kind of the types of audit reports. Now, there are three main types of audit reports that are important for cloud computing audits. You have SSAE, which is pretty much now. It's been replaced by SOC reports, and you have ISAE. Let's talk about what are all of these. Now, SSAE stands for Statement on Standards for Attestation Engagements. It is an auditing standard for service organizations produced by American Institute of Certified Public Accountants Auditing Standards Board. This standard is used to produce system and organization control reports. Earlier this used to be the norm, but this has long been replaced by SOC reports. So in SOC, you have SOC 1 reports, SOC 2 reports, SOC 3 reports, those kind of things, right? SOC 1 reports are basically for financial standards. SOC 2 is more about controls related to your IT setup. There are 5 parameters for SOC 2, it will look into things like the trust factor and all those kind of things specifically. SOC stands for Service Organization Control. It is, these reports help companies to establish trust and confidence in their service delivery process and controls. Again, these reports are administered by an independent third party that must be a certified public accountant. And by the way, SOC is the benchmark. This certification is attested by AICPA, American Institute of Certified Public Accountants. ISAE stands for International Standards on Assurance Engagements. Now, International Standards on Assurance Engagements is an international assurance standard that describes SOC reports which give assurance to the organization's customers and service users that the service organization has adequate internal controls. SOC stands for Service Organization, here it is, control, okay? Now let's understand, let's just go a little deeper into this discussion about SOC and, let's just talk about ISAE, right? Now, before I explain the difference, just take a minute or so to read the definition for, or just read the narrative or the description provided for ISAE. So International Standards on Assurance Engagements, ISAE, it's an international standards that prescribes SOC reports which give assurance to the organization's customers and service users that the service organization has adequate internal controls. So first of all, ISAE internally utilizes SOC reports, and it's an international assurance standards that prescribes SOC reports which gives some sort of attestation to any given organization's customers that this company has got adequate internal controls. So ISAE internally utilizes SOC reports. That's what they say, and they say that it's a nomenclature that's being used. Now, what exactly is SOC reports? Let's just understand certain differences between type 1 and type 2, right? Now, you have something called as SOC. First, let's talk about SOC type 2, type 2 report, right? Now, what is it exactly based upon? 5 factors, right? Okay. So 5 trust criteria for SOC 2. So you see here, you have different variations of SOC. You have SOC 1, SOC 2, SOC 3. And within each one of them, you have different, SOC 1 type 1, SOC 1 type 2, SOC 2 type 1, SOC 2 type 2, right? Now, instead of getting into the intricacies of entire SOC, because what we are going to just understand is the differentiating factor between SOC versus ISAE. Now, I'll talk about SOC 1 and SOC 2. Let's start with SOC 2, what exactly it is all about. Now, SOC 2, if any organization goes for SOC 2, it is basically an audit process that relies on 5 categories. So there are 5 factors for trust service criteria. So it is looked from the aspect of security, availability, data availability, application availability, confidentiality factor, integrity factor, and privacy factor. So 5 critical areas, 5 trust areas: security, availability, confidentiality, processing integrity, and privacy. So you got to have the right controls in all these 5 areas to make sure that you are SOC 2 compliant. Right? Now, what is SOC 1 report? Right? What exactly is SOC 1? SOC 1 is a report on controls at an organization which are relevant to user entities' internal control over financial reporting. So it's in simple, SOC 1 basically refers to controls related to financial reporting. SOC 2 report focuses on controls, internal controls related to 5 criteria factors, 5 trust criteria factors. Those factors are security, availability, confidentiality, integrity, and privacy. So it's based on, so it looks out for internal controls in these 5 areas, right? And this is SOC 2. You have SOC 1, which is focused on internal controls related to financial reporting. Okay. So now when we come back to this, what is international standards for assurance engagements? International standards on assurance engagements is a standard which prescribes SOC reports. It could be SOC 1, it could be SOC 2, any of these, which give assurance to a particular organization's customers and service users that the service organization has adequate internal controls. SOC 1 relates to internal controls related to financial reporting for a given organization. SOC 2 is more on the IT related controls for 5 critical factors, which include security, availability, confidentiality, integrity, and privacy on these 5 related areas. Now, restrictions of audit scope statements. There are several restrictions of auditing in cloud computing, such as You need to rely on experts. An auditor has to rely on experts like engineers and lawyers for estimation and valuation of fixed assets, estimation of contingent liabilities. Now you see why it's a potential challenge, because the server is hosted on the cloud. So if a server is procured in-house, you would probably add up its cost at that moment. So if it is a new machine that has been procured, during given year, or if the value of that particular server has been depreciated over a period of time, you will take into account all those factors, right? Now, the fact is that there's a slight difference, because think if you are going to have a data breach, now your server is very critical, right?
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
But what about the server that is holding the data? So its price, maybe it could carry a heavy price tag because of the critical nature of the data that is getting stored on that. But it is also possible that the server itself, which is hosted.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Which has been hosted in the cloud is not having new generation hardware architectures. It's a virtualized server with running on cheap hardware, right? So those are some of the things you will have to reach out to experts for cost estimation and all those kind of things. Efficiency of management. An auditor does not comment on the efficiency of management working in client organizations. No comments on future performance of an organization can be made through audited financial statements. So keeping the management away from the purview of the auditor, it's always kept out of scope, right? Checking of all transactions. Now, it is not possible for an auditor to check all business transactions, especially in their organizations, where the number of transactions is very high. An auditor has to rely on sampling techniques and test checking. You will not have the bandwidth to check out all the business transactions. Probably you can take a sample, or you can sample a given period of the transactions, and you can sample on that basis and come up to some conclusions or some findings. Additional financial burden. An organization has to bear additional financial burden on account of any fees and other such expenses for conducting an audit. So the auditor also will come and charge your organization some dues. So your organization will have to consider these aspects as well. It is not easy to detect some frauds. It is not easy for an auditor to detect deep laid frauds like forgery, misstatements and non-recording of transactions. So if any of these things have happened, it just makes the job of the auditor even more difficult. Gap analysis. Now, what exactly is gap analysis? It's a method of assessing the differences in performance between a business's information systems or software applications to determine whether business requirements are being met, and if not, what steps should be taken to ensure that they are met successfully. Gap refers to the space between current state and the target state. So where you currently are and where you want to be. So it just talks about the gap between your present state and the futuristic target state. Our gap analysis may also be referred to as needs analysis, needs assessment, or need gap analysis. There are several tools and frameworks such as the McKinsey 75 framework, which can be used for gap analysis. Audit planning. So let's talk about this. An audit plan is the specific guideline to be followed when conducting an audit. It helps the auditor obtain sufficient evidence for the circumstances, helps keep audit cost at a reasonable level, and helps avoid misunderstandings with the client. The auditor plans to perform the audit in an efficient and a timely manner. So audit plan contains the guidelines to be followed during the process of the audit. Now, it will help the auditor to obtain a good deal of information or good deal evidence for the circumstances, and that will also keep the audit cost also at a reasonable level, and it will always avoid any misunderstanding. So audit plan is a very important aspect. Now, what does audit plan include? It includes the following procedures: knowledge of the client's business, which includes financial, legal framework, government norms, investments, accounting policies, business risk and financial risk, development of audit strategies or overall plan, preparation of audit program. Now, we've been talking about things like, as a part of the audit planning, you should take into account, all these factors. Let's say you are doing an audit of a banking application, and let's say you are doing the audit for mortgage. So what all things you would need? You would need certain reports. Here you would need, financial reports. You would need some certain metrics, some internal transaction reports, and all those kind of things, so that it helps you to understand the current setup and ask questions accordingly as a part of your questionnaires, or find evidence accordingly. So these are the things that will serve as an input. So audit planning is all about that. And the more insights you can get during the planning process, it will really help to cover seamlessly things, when you actually start the audit cycle altogether. Internal Information Security Management System, let's talk about that. An ISMS, which is an Information Security Management System, is a set of policies and procedures for systematically managing and organization sensitive data. Now, the goal of an ISMS is to minimize risk and ensure business continuity by proactively limiting the impact of a security breach. Now, what sort of policies? Let's just talk about it. Let me show you an example here. Okay, let's just see from a governance standpoint, and something that you will be. Let's take Salisbury University as an example. Okay, let's take their security policy management. Okay, so we go here, right? It will probably download the data security policy. Now, I'm not interested in that. I just want to take a look at if I can get a chance to look at some of their policies. That's the whole idea. Okay, so we can see there are a lot of policies here around. So there is something called a security policy management. You can see that they have a lot of IT related policies like account management policies, the cloud service security policy, configuration management policy, and so on. I'm more interested in this particular policy, security policy management. Okay. Now, what is this is all about? Now, you can see this organization, this university has got all the following policies referred to as the overall IT security policy. So they have got an account management policy, they have an asset management policy, they have a data security policy, they have a cyber security incident response policy, they have a configuration management policy, they have a wireless access policy, they have a remote access policy, they have a security assessment policy, they have a media protection policy, they have an endpoint protection policy, they have email security policy. So that should answer any such question. So your security policy management document, it just provides context to all the other related policies. And this entire set of policies makes up your overall information security management system. That's the whole idea. Now, the goal of an ISMS is to minimize risk and ensure business continuity by proactively limiting the impact of a security breach. So if tomorrow, if your organization encounters a security breach, the whole idea is that the things that will be checked around would be some audit log entries. You have, who did what at a given time, all those kind of things. And ISMS typically addresses employee behavior and processes as well as the data and technology. It can be targeted towards a particular type of data, such as customer data, or it can be implemented in a comprehensive way that becomes part of the company's culture. Internal information security control system. Information security controls are measures taken to reduce information risks such as information system breaches, data theft, and unauthorized changes to digital information or system. These security controls are intended to help protect the availability, confidentiality, and integrity of data and network, and are typically implemented after a information security risk assessment. This is quite comprehensive, and it's comprehensive enough to the point where a lot of security related checks. If due diligence is done, you will be getting a tick across many security domains that are covered by the CCM, cloud control matrix. And this is how, and your goal is to figure out the security controls under all these areas, audit and assurance, application and interface security, business continuity management and operations resilience, in logging and monitoring, security incident management, eDiscovery and cloud forensics, all these kind of things. Okay. Internal information security controls systems are systems which can be used to automate the application of these controls. These systems speed up the application and management of security and data collection policies in internal systems. An audit policy defines account limits for a set of users of one or more resources. It compromises rules that define the limits of a policy and workflow to process violations after they occur. These policies may be grouped into several levels or groups such as organization, functional, cloud computing. These groups can have different auditing requirements and different auditors as well. Now, an account audit policy defines account limits for a certain set of users of who are allowed to access one or more resources, and it comprises of rules that define the limits of a policy and workflows to process violations after they occur. These policies can be grouped into several levels like organizational, functional, and cloud computing. Identification and involvement of relevant stakeholders. In the auditing process, relevant stakeholders should be involved. These stakeholders must be first identified based on the resources being audited. After the identification of these stakeholders, they should keep in loop of any relevant updates on information found during the auditing process. Active involvement of stakeholders is expected to make the auditing process more successful. Now, specialized compliance requirements for highly regulated industries. Let's talk about this. Based on the kind of data being stored, there are times where we have to follow several regulations in storage and data retrieval. These regulations may be geographical, like in North America, could be in payment card industry, or sensitive data as well. As a part of the specialized compliance requirements, these regulations are maybe more geographical in nature, right? I mean, the jurisdiction of that will be geographical in nature. So whether you're doing it from a perspective of critical infrastructure protection or industry-based, like payment card industry standard, and many such things. Now, auditors need to especially be cognizant of the regulations that apply on the data as well as the infrastructure in which the data is stored. Auditors also need to do proper verification of the compliance of these highly regulated, especially based on the industry that the data is concerned. Now, if you are a healthcare provider, one has to be, as an auditor, I'll have to be very extremely careful to make sure that wrong information is not passed through in such cases, right? So auditors should be aware of the regulations that apply on the data as well as the infrastructure where the data is being stored. So for example, privacy related, so any privacy related challenges can be well addressed, by doing due diligence here in such cases. Impact of distributed information technology model. Let's talk about that. Now, since cloud computing is spread across a wide range of geographical locations, it further complicates the auditing process. Based on the geographical locations, different laws may apply to the data and the infrastructure. The legal jurisdiction may vary based on the location as well as the data being stored on the infrastructure. Auditors will have to understand the legal and jurisdictional aspects of the infrastructure and data being stored on and proceed accordingly. So auditors will have to take into account any such legal or jurisdictional related aspects accordingly. Understanding implications of cloud to enterprise risk management. Now, there are several factors we need to consider when we talk about enterprise risk management and cloud computing. We need to assess the service providers' risk management programs. We need to understand the difference between data owner and data custodian. Regulatory transparency requirements. Then you have the risk treatment, Then you have different risk frameworks, you have the metrics for risk management, and you have then finally assessment of risk environment. All these factors will come into play. Assess providers' risk management programs. Many cloud computing service providers provide risk management programs. These programs may need to be evaluated by the auditors as well as the stakeholders. These programs should be evaluated on the following parameters such as controls, the internal security controls, any methods, and any such policies. It should be made aware that these programs can provide desired value to the organization and support their expectations. So let's cover the difference between data owner and data custodian. Now, data security is a complicated problem, and many people across the organization play different roles in the data security process. The data owners are the business leaders with overall responsibility of data centers. They set policies and guidelines for their data sheets. Then you have data custodians. So they are the people who actually store and process the information. They are often referred to as IT staff. Risk treatment. Now there are 4 options to treat or deal with the risk. So the point is very simple. Whether you go for risk avoidance, sharing of risk, modification, retention. So these are the 4 options, but you cannot completely eliminate risks. You can mitigate them. You can lower those numbers, but you cannot completely eliminate, risk scenarios. That's not possible. So let's talk about what are the 4 options to deal or treat with the risk. So avoidance, changing organizations' business practice to remove the possibility that the risk is affecting your business. Sharing, shifting the impact of the risk to another organization, like such as insurance policy. Modification, reducing the likelihood or impact of the risk. Retention, we can accept the risk without taking any further action. Regulatory transparency requirements. Dealing with audit regulations can be tricky, and it is very important to understand that several regulations demand high level of transparency about data with the customers. There are several legal acts which make transparency between parties compulsory, such as Sarbanes-Oxley Act of 2002. Several guidelines require strict deadlines for sending notifications in case of data breach. For example, GDPR states that in case of the personal data breach, the controller, which controller? Data controller, somebody who is requesting your personal information and you have approved that you have given your consent for the third party to store that. Now, if the data controller's environment is breached, then as per the GDPR rules, the controller shall, without undue delay, not later than 72 hours after having become aware of it, notify the personal data breach to the supervisory authority. So they should notify this to the supervisory authority. So this is also a regulatory requirement. In some cases, there would be a need to report certain things. I'll give you an example, right? Recently in India, they introduced a new requirement that all the social media companies, and pretty much on the cloud, they don't, they have either their own cloud-based data centers or they are storing it on AWS or other platforms. The whole idea here is that companies like, Twitter and other firms, they were mandated in India roughly around in the month of March, April, earlier this year, that they need to have a compliance officer, which is a chief compliance officer based in India. And every 2 weeks, that person, the chief compliance officer of these social media companies, they have to share a report, a compliance report with the government. So that's a regulatory requirement, right? And it's a mandatory regulatory requirement. That's just a new development which happened this year. And such developments could be happening, or such provisions may be there in other parts of the world, that you have to follow some compliance with the regulatory bodies. This may have become the norm here. In GDPR also, there is a certain criteria that after 72 hours of the controller being aware of any data breach, they have to report it to the supervisory authority. And there are such several regulatory restrictions around the world. You don't have a choice. You have to just comply with that, right? So that's the whole idea. Now that can bring an additional layer of challenges, these regulatory requirements. That's the whole thing. Now there are different risk frameworks. Risk management frameworks provide proven time-tested techniques for performing enterprise risk management. Organizations can create their own risk management frameworks if they do not find any framework fit for their use cases. One of the most widely used risk management framework is NIST Special Publication 837. So this could be used, any of the NIST standards, special publications that are out. They are all self-adopted, right? There is no, it's not a certification which you have to acquire, right? They're all self-adopted. You can adopt it and you can tweak it according to your organization's requirements. So NIST 837. The other famous example would be take an example of fair risk assessment. That's also pretty good. So if you want to check this out, you should check this out. In fact, as of now, there is there are some recent developments happening on this. So anybody, or if you want to take this out, there is some partnership that is happening between RiskLens and NextGen Talent. So there are some discounts happening. So if somebody wants to take fair training, get acquainted with the fair risk assessment, you can go for it, if it suits you. Anyways, like similar to NIST 837, fair is also a pretty standard or a well-known risk management framework. Okay. Now what the risk management process do? They have 6 steps in NIST Special Publication 837. NIST is nothing but a series of special publications. They have certain things for risk management, they have for disaster recovery, they have for cloud computing. They cover a variety of areas. So what are the 6 core steps? Categorize information systems, select security controls. So first you categorize your information systems. When I say categorization, what I mean is you should have a proper structure in place. You should have an inventory. You should define which are your critical assets, non-critical, what location these assets are, who is the business owner, all those kind of things. Right? So once you have laid out that categorization, you need to select security controls. Now it's prudent to say that any of the assets that are of critical, considered critical. When I say critical, we're not talking from a risk point of view, but what we're talking about is from business critical. The assets that are considered more business critical, they will have the requirements for more enhanced security controls are applicable to them. So any organization will have better security controls for the critical business assets as compared to the security controls for less critical assets or not so important assets, right? So the amount of security controls, the higher the criticality of the asset, the more fine-grained the security layer would be. That's how it is. So you define security, you categorize information systems, select the security controls. Then you implement those security controls. So for example, if you have a server which is very demanding, let's say it carries a server has data and that data is worth, let's say, $500 million. Now, if there's something that happens onto that server, this is the amount of monetary loss that a company could suffer as a result of a breach or as a result of unavailability of that server. So you would need to have very strong security controls. What kind of security controls? You want to make sure that there's a very strong layer of encryption there and any other security controls beyond that. A very strong authentication process is established there, all those kind of things. This server got to be protected by your next generation firewall and any other pillars, security layers in between that can maintain the security posture of the server. So categorize information systems, select security controls, implement security controls, access the security controls. So if you want to be deploying a firewall, so any request that comes to this particular server has to first go through the checkpoint firewall. And if it is a valid request from the firewall, it will be then routed to the next security layer or directly to the appropriate organization server. So this is what we're talking about. Then you need to authorize information systems. You need to have a strong layer of authorization. So make sure that proper user credentials are being used, proper access mechanisms are a good layer of security and authorization and authentication established. And then you need to monitor security controls. You need to make sure that whatever security controls that you have defined, they're being monitored. So for instance, if you have deployed an intrusion detection system, you need to make sure that what kind of alerts that may be throwing up. Are those false positives? Are those alerts false negatives? Are they true positives, true negatives? This is the entire 6-step process. Metrics for risk management. There are several metrics for risk management, such as asset value, exposure factor, single loss expectancy. Now, asset value obviously is the monetary value of an asset. Exposure factor is the expected percentage of damage to an asset. So here in this case, if we talk about, let's say there was fire in the building, or let's say, so what is the amount of loss that happened to a specific asset like a server, or if multiple assets like to the entire data center, what is the amount of loss? So what percent of damage that happened to the asset? Single loss expectancy is expected dollar loss if a risk occurs one time. So exposure factor is different than single loss expectancy. In exposure factor, we calculate the percentage of damage to an asset. It's not expressed in monetary terms, it's expressed as if the asset's condition is 100% right now, how much percentage of the damage was that happened to that asset. So whether 10%, 20%, 30%. And single loss expectancy means that the monetary amount of loss if a risk occurs one time. If that threat, you had a threat perception, but threat really occurs, right? So you're facing a real-time threat now, and that actually happens. So what's the amount of monetary loss? So that's the single loss expectancy. Assessment of the risk environment. So when assessing risk in a cloud environment, there are three kinds of risk we need to consider: service risk, vendor risk, infrastructure risk. Now the point is that you as a customer will not have that much benchmark to check out the locations, because where you're hosting up. So let's say if the cloud vendor is leasing some infrastructure for some monthly charges to you as a customer, you can't go to that data center, but at least you can get a fair estimate as to, let's say if you open up a data center, if you're hosting your services in island data center, you got to be aware about at least some of the semantics in that particular location from a risk assessment point of view. You got to be aware of some of the challenges there. I think if we are aware about these kind of things, we can decide on where to host our applications. We can choose in a better way. So service risk, vendor risk, infrastructure risk, and to add to that also the physical risk factor. While you are no longer in control of the data center here, choosing a data center where you're going to be hosting your services, at least you can benchmark that. At least you can get some idea regarding the conditions there. All you need to do is a bit of searching, right, on internet. So these are some of the risks that are prevalent in when you think about service risk. Could be vendor risk. We talked about, even if you're storing your data itself, you're storing the encryption keys also, entire repository is under risk, right? So service risk involves a cloud service such as a server or database going down. This needs to be tackled using redundancy across geographical locations. Now, the whole idea is that, let's say you have a standby setup in another cloud region from a cloud vendor. Now, the point is, we are talking about the global supply chain. Okay. Now, if a CDN vendor on which these cloud providers like Amazon and many others, and Fastly is not just one of them, there could be many other such vendors, on which these large organizations, including the CSPs, are dependent for their supply chain. If something breaks in the middle, does this ground really hold true? I mean, are you really getting redundancy in the first place? Is that really a correct assessment? So for instance, if you have set up a database server in one region and you have set up a standby database server in another region, and if an outage like what happened with Fastly happens, is it guaranteed that the assumption under which you are as a customer, that, hey, if something happens to my production server in one region, I have a backup or I have a standby server in another region, could a outage like a global outage like Fastly can change that narrative? Is it a false impression for a customer? I mean, that's the thing, because people are building up cloud services, and if there is a breakdown in the global supply chain, so while you are aware as to how to get onto the cloud, you're well aware of how to set up services, people, most of you are, well versed in the cloud. I see that there are certain people who are on the cloud architect role or who have a good background generally. They've come from good infrastructure or some other background. Vendor risk is where there are several risks that involve cloud vendors, such as use of insecure hardware or software. There could be a small misconfiguration issue, and that can compromise. The whole idea is that there could be some vendor risks that have the potential to cause some real damage. Then there is infrastructure. So you've got to cloud infrastructure needs to be protected from various things such as fire, water, etc. To make sure that the infrastructure is protected against these threats. Make sure to follow guidelines related to laying out and managing cloud infrastructure, such as ASHRAE guidelines. ASHRAE is a series of data center guidelines. Understand outsourcing and cloud contract designs. When thinking about outsourcing and contract designs, there are a few terms that we must ensure that are present in the contract that have been created. These are business requirements, vendor management, contract management, and supply chain management. Business requirements. When thinking about outsourcing contract design, we must ensure that following things are present in the contract. Important clauses should be present in the contract, right? So when you're looking at your service level agreements, you have to be very explicit regarding what you need, not just a generic SLA that the cloud vendor is providing. SLA, as we know, is an agreement which specifies particular requirements of the service being provided and also what the user is expected to do. You also have something called as a statement of work and a master service agreement. A master service agreement, also known as framework agreement, is a contract reached between two parties in which the parties agree to most of the terms that will govern future transactions or future agreements. SOW is a document within a contract that describes the work requirements for a specific project along with its performance and design expectations. SOW is basically more widely used with, so for example, if you are a company like Accenture and tomorrow you want to do business with Bank of America, or let's say with Deutsche Bank. So Accenture will try and get their people on the project of, let's say, with Goldman Sachs, or for that matter, with Citibank and many such companies. So that is the statement work. So what each resource is supposed to do, those, how many resources, and that planning is all covered in SOW. So generally, this is a classical document that is getting used in outsourcing agreements. Vendor management. When dealing with the vendors, we should have clearly stated rules and restrictions that the vendor must agree to. Agreement should clearly specify data ownership. Customers should retain uninhibited data ownership. Vendors' right to use the information is limited to activities performed on behalf of the customer. Vendors should be limited in their data sharing practices with third parties. Also, I want to add here, if you as a customer want to perform DOS attacks, do pen testing, on your cloud applications, Microsoft doesn't want you to perform DOS attacks, DOS pen testing, Azure. They will not allow it, right? It allows you to pen test if you want to perform against their own applications. DOS attacks is out of it. You cannot run DOS attacks. You can see here, the following acts are prohibited as a part of the pen test: analyzing or testing assets of other Microsoft customers, which is signed; running DOS denial of service attacks that generate, or any test that generates a large amount of traffic. What is the definition for a test that generates a large amount of traffic? Microsoft can test it, you can't test it. See, it makes sense to not to conduct DOS attack. Okay? But the point is, what about the second line? This is not making sense, right? This sounds like being hypocritical, right, on part of Microsoft. Contract management. When dealing with cloud contracts, we must take care of several things, such as the contract should clearly define any terms used in the contract. Performance metrics like uptime, availability should be defined in SLM contract. It should clearly state what happens if the vendor fails to live up to its own obligations. It should include compliance and obligations in contract terms. Customers should retain the right to audit the vendor's performance. Customers are not getting the choice to audit the vendor's performance, right? Indemnification or reimbursement clauses should be carefully negotiated. Contract should specify their end and renewal processes to avoid confusion. Contract should specify litigation terms. Where would the litigation take place if contracts are broken? Supply chain management. As vendors provide the supply chain for our cloud services, we must deal with vendors in a way that protects the confidentiality, integrity, and availability of our data and ID workloads. We need to make sure that the vendor security policies are at least as stringent as our own. Now, see, there are a lot of conflicting scenarios, like, and that is a added complexity. So, that's the reason why even after a decade of cloud, technically it started in 2006 with Amazon. That was not really the time. It really started in 2010, 11, mostly in 11 onwards till now. So even in this 10-year or decade-old year journey with cloud, what seems, there are a lot of gray areas, especially the right to audit from a customer side. You want to audit the cloud vendor because they are hosting your own data. Then I showed you this hypocrisy of Microsoft, where to me it sounds like hypocrisy. So, pardon my words, but it is a hypocritical scenario where Microsoft can test their own environments against, they don't require your approval from 2017. So which means prior to 2017, they requested permission. So what changed on that date? And you can't DOS test, or you can't generate some test that generates a huge amount of traffic. And we need to make sure that the vendor security policies are at least as stringent as our own. Make use of vendor management lifecycle. It includes the following steps: vendor selection. Make sure you include our security requirements in the request RFP documents and assess the vendor's risk management program before selecting a vendor. Onboarding. When onboarding a vendor, make sure that the contract details are verified and the data transfer to the vendor systems and services is secure, and that incident procedures are established. Monitoring and offboarding. For monitoring, make sure you conduct regular site visits and audits. You also need to review independent audit reports and make sure that even minor security incidents are being handled. Offboarding. In the offboarding process, make sure the vendor is destroying the confidential information so that it cannot be misused.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now let's take a look at data dispersion. Data dispersion is used to store multiple copies of data at multiple locations. In cloud, there are two ways of doing it. First is called bit splitting. Second is called erasure codes. Both of them are quite popularly used in storage systems. They both have their own pros and cons, and they both have their own special way of working. Essentially, what we try to do with these is that we create some sort of redundancy. So once the data is stored in multiple locations, if one location goes down, other locations can be used to rebuild the data, or other locations can be used to provide some backup. In any case, let's take a look at them one by one. So first comes bit splitting. Bit splitting is like adding encryption to RAID. RAID stands for redundant array of independent disks. Here we store data in an array of disks, and it allows us to store data in a more secure way. Similarly, bit splitting works much more like that, but with encryption added to it. The data is first encrypted, then separated into pieces, and the pieces are distributed across several storage areas. This is so that even if one of the storage locations gets compromised, the person who has the compromised storage location cannot access the complete data. He can only access a chunk of data, which may not be something useful for them. Bit splitting carries the following disadvantages, however. Processing is CPU intensive. So once you have uploaded the data, if the data is of huge volume, splitting it and performing bit splitting on it, which includes processing intensive tasks such as encryption and chunking the data and then spreading it across multiple locations. All of this is a CPU intensive task, so it cannot be done for a lot of devices, for a large volume of data, for a lot of users. Availability concerns are all part that the data needs to be decrypted before you use the information that is contained inside the data. So you need to be able to understand that all parts of the data are available, so that when you decrypt the data, it is completely decrypted and the entire information is presented in front of you. Storage requirements and costs are higher than other systems because it takes time, it takes effort, and you need to store multiple shreds of the data in multiple storage locations. You need to have multiple storage devices all attached to each other, maybe, or maybe in separate geographic location. That's completely up to you, but that's one way of doing it. Now, here's how bit splitting works. These are the steps. First things first, we encrypt the data. This is done to make sure that the data that is sensitive is becoming data that is incomprehensible. So encryption basically uses a key and converts plain text to ciphertext. Plain text is the data we have, ciphertext is the data that we want. That's something that people can't comprehend and it becomes something that people cannot understand. Then we split the encrypted data into chunks. Chunks are basically small pieces of same size of the data, so that we don't have to worry about how we go about splitting the data and how we distribute it. Then the data is distributed to different locations based on the chunks. If we have 8 chunks and 4 locations, two chunks are displayed on all locations. Preferably one chunk on one location is a good strategy. Then comes encryption data at new location. Once the data is put on the new location, it needs to be encrypted there as well. That is the responsibility of the local systems, or you could encrypt it on your own. That depends totally up to you. This is done for enhancing security so that even if one person gets access to the encrypted data, it has another layer of encryption added on top of it, so that once the person breaks that encryption, even if the person breaks that encryption, it's not going to work for other pieces of data. Now, to recover the original data, the reverse of the above mentioned steps need to be taken into consideration. For example, the data chunk that was stored in a new location that was encrypted needs to be decrypted first. All of the chunks need to be decrypted. All of the chunks need to be collected in the correct order. They need to be put back together, and then the final decryption needs to happen before we can access the data. On the other hand, we have erasure coding. Erasure coding is like using parity bits for RAID stripping. In RAID, parity bits help you recover missing data if one stripped drive gets lost. So essentially, parity bits work like this. Suppose I have 4 bits I'm storing. All of them can either contain 1 or 0. Parity allows us to determine whether or not parity allows us to determine whether or not how many number of ones are there, how many number of set bits are there. If there are even number of bits, then the parity is 0, and if there are odd number of bits, then the parity is 1. There are options to reverse this so that even number of bits get a parity of 1 and odd number of bits get parity of 0. That completely depends up to you, but you have to understand the differences between them. Once that's done, even if one of the bits gets lost or corrupted, we can just take a look at the number of bits that are set, and then we can add the data. So for instance, out of the 4 bits, I have 2 ones and 2 zeros. So there are even number of bits that are set, parity is going to be 0. Once one of the data is lost, I check again how many number of bits are there. If, for instance, I have 4 bits and out of those 4 bits, 1 bit is lost, so I still have 2 ones. That means I have even number of data and only one piece of data can be added there. That means the missing chunk was 0, so you replace it with 0. That's essentially how RAID works. That's something that is taught to us using in storage systems. But the basic method in erasure coding of data protection is which data is broken into fragments and then expanded and encoded with configurable number of redundant pieces and data and stored across different locations. So that's essentially how it works, very similar to how RAID and parity stripping works. Erasure coding helps you recover missing data in the cloud if the place where the data was stored becomes unavailable or the data gets lost while you disperse your data. In cloud, erasure coding is only used for cold data storage. Cold data is, as far as you are aware, is the archival storage systems. So storage systems that have low latency for high latency for lower costs. And this is because it gets very compute intensive than simple replication across geographical regions. One way to protect your data from being lost when one data center goes down or one server goes down is by copying the same bit of data across multiple regions, so that if one of the data centers completely go down, the data can be recovered from other places. Erasure code like RAID creates parity bits along with chunk data to make it easy to recover the data. A common erasure code configuration is 4+2 erasure code, which means that the data is split into 4 chunks and 2 parity chunks are created out of that 4 chunked data for data recovery. This configuration can tolerate up to 2 node failures. Both of them can either be parity bits or both of them can be data bits, but both of them cannot be parity and data bits. Now, more than if there's more than 2 node failure, then there's no way of recovering the data. Now, this is what the process looks like. Firstly, we create the chunk. Data is chunked into 4 parts. Then we encode the data. Encoding the data is a mathematical process in which we keep the 4 chunked pieces that we have as it is, but we create parity bits out of it as well.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
Parity bits let us take a look at how many ones and zeros are there so that we can understand how the ones and zeros work. Then we write to the disks. Writing to the disks basically allow us to have 6 chunks and we have them be written to 6 different disks so that the failure of one disk does not affect the other one. Now, in case of failure or corruption of data in these disks, we can use mathematical operations to rebuild the missing data. This only works if the number of lost chunks is less than or equal to 2. If it's more than that, then the data is unrecoverable and essentially our entire data is corrupted. This is why it's stored on multiple locations so that even when worst of worst comes, only 2 of the places where data was stored can go down. Other places might not go down. There's a good chance that that's not going to happen. This is because if the lost chunks had one data chunk and one parity chunk, data can be recovered. If both the parity chunks are lost, then also they can be rebuilt using the existing data. We can just pass it through the encoding process and rebuild the parity chunks. But if both parity chunks and a data chunk is lost, then there is no way of knowing how to recover the data, and we have essentially lost the data that we needed to recover. So that's basically how data dispersion works in a nutshell. Design and implementing cloud data storage architectures. In this, we'll try and understand the individual components of cloud data storage architectures, and we'll try to understand what are the security components that we need to take into consideration when we're using these architectural components. Let's take a look at them one by one. So in cloud data, there are several ways of storing data to cater to different use cases. Using these, you can build your own architectures to satisfy your own use cases. Now, there are also several threats that you need to be aware of, which is what we'll be covering right now. So firstly, let's take a look at storage types. There are 6 main storage types available in the cloud: raw storage, ephemeral storage, volume storage, object storage, CDNs or content delivery networks, and long-term storage. Let us try and understand them one by one. The first one is raw storage. It is permanently allocated disk storage that stores data and exists independently, that is without this running server instances. Basically, you can store some data and then forget about it. You don't need to run a server and attach the disk to that server, so on and so forth. So it works completely fine. It is used to persistently store data such as logs, files, etc. So if you have some data that you need to be stored for a long period of time, raw storage is the best option for you there. Now comes ephemeral storage. Often used to swap files and other temporary storage needs, this storage type is used with infrastructure as a service instances. Basically, it is used with the raw servers, whether they're virtualized servers or real-world servers. And when the instance is terminated, that is either we shut it down or we delete the instance, our instance of the ephemeral storage gets removed with that as well. So it's only for temporary storage purposes. It's really fast, it's really cheap, and it's for temporary storage. Now they are also used as caches and temporary storage locations, which will store data as long as the server is running. So for instance, server logs and all of this kind of stuff, you can run inside, you can have them be stored inside an ephemeral storage. Now, most often a virtual hard drive is something that is attached to a virtual machine or a host. That's what a volume storage allows us to do. Basically, a volume storage is if you have some disk storage that stores data and exists independently, that is without this running server instances. Basically, you can store some data and then forget about it. You don't need to run a server and attach the disk to that server, so on and so forth. So it works completely fine. It is used to persistently store data such as logs, files, etc. So if you have some data that you need to be stored for a long period of time, raw storage is the best option for you there. Now comes ephemeral storage. Often used to swap files and other temporary storage needs, this storage type is used with infrastructure as a service instances. Basically, it is used with the raw servers, whether they're virtualized servers or real-world servers. And when the instance is terminated, that is either we shut it down or we delete the instance, the our instance of the ephemeral storage gets removed with that as well. So it's only for temporary storage purposes. It's really fast, it's really cheap, and it's for temporary storage. Now they are also used as caches and temporary storage locations, which will store data as long as the server is running. So for instance, server logs and all of this kind of stuff, you can run inside, you can have them be stored inside an ephemeral storage. Now, most often a virtual hard drive is something that is attached to a virtual machine or a host. That's what a volume storage allows us to do. Basically, a volume storage is if you have some drive and that drive needs to be partitioned into separate volumes. For instance, when you are working on a Windows system or Linux system or Mac system, you have a disk drive that is much bigger for your need. So you logically partition the drive, that is create three separate spaces for those drives. In Windows, it's usually the C drive, the D drive, the E drive, and so on and so forth. Depends on how you have partitioned the system. So this is one of those partitions could be considered a volume, and a volume storage is often referred to as a virtual hard drive, which is attached to virtual machines and host systems. It is used to persistently store data and can be attached and detached from already running server instances. Think of it as a virtual USB drive or a virtual SSD drive. Basically, you create some data, you attach a virtual storage or a volume storage to that, then you copy the data to that volume, and then you detach the volume, and now it's stored in there. Now if the server gets deleted also, the data is remaining in the volume storage and you can use it later on. Then there's object storage. File shares accessed via the web interface or real world APIs. Real world examples include Rackspace and Amazon S3. If you have ever tried to store some really unstructured data like audio, video, images, any of this kind of stuff on the internet, then on the cloud essentially, then object storage is the storage that you have used. It is not something that creates a file system for you, and how things are managed underneath is not really a concern. You just want a bucket there to be able to throw some data inside it and then forget about it. And this allows you to do that. It is used for storing massive amounts of unstructured data using such as storing photos, songs, or files, etc. Unstructured data is basically data that has no structure to it. There's no pattern. That's nothing. That's just a stream of bits rolling around, and that's what unstructured data is. And that's how you use. That's what you use an object storage for. Then there's CDNs, also called content delivery networks. They are used to store static assets which are replicated over several locations in geographically distant locations. This is done so that your static assets can be accessed by a global audience. To give an example, let's say you deploy a website. It uses certain images, style sheets, fonts, so on and so forth. These are static assets mainly because these do not get updated regularly. They are not dynamic. Different users are not going to get different versions of these files. So what happens is, if you have a server that is serving this file over the internet, and that server is in the United States, and then you are somewhere on a distant location, let's say India, then accessing that website is going to take you a longer period of time because the data needs to travel longer distances than it would take someone, let's say, in the United States. So that's a big problem. In order to overcome this, what happens is these servers are configured in such a way that they access these static resources from the nearest servers available. And these nearest servers are also called edge locations, which are referred to as content delivery servers or content delivery networks. Many of the servers are located and spread across geographically. So one may be in the US, one may be in Africa, one may be in Europe, one may be in Asia, one may be in China, one may be in India. Depending on where you are accessing it from, the nearest server is then asked to fetch the resources so that it's delivered to you at a much greater speed. They are used to store and cache static assets such as images, CSS files, etc. in geographically distinct locations for faster access. Finally, there's the long-term storage. It is also called archival storage. It is used for storing data that is not accessed very frequently, and latency in access is tolerable for low storage cost. Think of it this way. You have some data and you don't use it very often. But since you have stored it inside cloud, you get the opportunity of accessing it really quickly, but that costs you a lot more than it should, mainly because you don't use it that much. You can have the option of moving it to an archival storage system in which this will be stored, and the time that it takes for you to access the file could be a little longer. Let's say that if it takes 1 second for it being served over the internet in the normal storage locations, then in archival it will take 2, 3, or sometimes even 4 seconds. However, that's tolerable because you only use it like once or twice a year, once or twice a month. It's not that frequently accessed, and you get a much lower cost option for storing it inside archival storage. They are used to store data at lower cost and higher lower access speed or latencies, as this data is used less frequently. Think of data such as data logs or something like that, which you use once a month to audit the security prospect of your entire network. In cases like this, these can be moved to an archival storage each year so that the previous year's logs are moved into the archival storage and the current year logs are kept so that they can be viewed at a fast speed. Then the current year, when next year comes, the current year logs are then sent to the archival storage and the new logs are recorded, so on and so forth. Now let's take a look at some threats to storage types. Storage types are an important concept in cloud computing, but there are certain threats that we need to be aware of when we're discussing these storage types. Let's take a look at them one by one. In the ISO IEC 27040 is an international standards published by the International Organization for Standardization and the International Electrotechnical Commission (IEC). The standard describes few threats to storage. These are unauthorized access, unauthorized usage, regulatory non-compliance, DOS and DDoS attacks, modification and corruption and destruction of data, data breaches and leakages, theft or accidental loss, malware attacks, and improper sanitization. These Let us discuss these threats into a little more detail and understand how you can prevent it. The first one is unauthorized access. As the name suggests, users gaining access or are able to view and manipulate the data that they should not have access to is called unauthorized access. To prevent this, you need to set strict authorization policies and only allow access to resources that are absolutely needed by them. For instance, if a user requests for building an application, let's say that you are an organization and the developers want access to certain resources, you only provide access to those resources that they absolutely need. So a server, a database instance, and a virtual server in which they can connect each other. That's about it. That's all you need for the usage of your app developers. Similarly, other users may have other needs. You need to firstly assess the needs and determine what are the minimal accesses that you can grant them that could work. And once the access is complete, they have done what they need to do, then access revocation policies should also be in place. Then comes unauthorized usage. Users are able to modify, update, or even delete data that they should not have access to. So for instance, if I have created some piece of information and I should be the only person who can access it and modify it, but another user comes in and can do so, then that's an unauthorized usage storage threat. That's a concern that we need to be thinking about. Now, to prevent this, granular permissions should be used and only the required permissions should be granted to the users. Many storage systems allow you to set granular permissions, such as if a user is allowed to just view the data, if they are allowed to manipulate the data and view the data, if they are allowed to manipulate the data, view the data, and also delete the data, and if they are allowed to, basically they become the administrator and they are allowed to share this data with other people and can revoke my own access to this as well. So you need to understand the context in which this entire application is running and how the storage systems should be utilized there. For instance, if you have some file and you have shared it to someone, you only need to share them with the permissions that they need. If I only want to view the file, then you only need to share it with me with the viewing permission. And there are options for you to specify the time period for which I can view this. So for instance, for the next 7 days, I can view the file. I can't change it, I can't delete it, but I can view it for the next 7 days. Now comes regulatory non-compliance. Several applications deal with data that is regulation bound, such as data regarding credit cards and payment systems. This data needs to be stored in compliance with the set standards. Otherwise, there is a risk of data breach and leak, and you can be levied with a heavy fine if it turns out in an audit that you are not complying to the regulations. It should be made sure that all the regulations are being properly followed through, and test and or mock audit should be done, so that when the audits are performed, we can get access to the information that we need in order to determine whether the regulations are being followed. Then comes DOS and DDoS. Many people know these as being denial of service and distributed denial of service attacks. These are basically network attacks in which multiple requests are sent to a particular server in order to take it down. A high volume of traffic is sent to a particular resource or particular server so that it becomes either really slow or it hangs up and dies. In any case, the legitimate users are now not able to access the resource. There are ways to prevent this, such as analyzing the incoming data for patterns such as large amounts of requests coming from the same device or the same network. You can also set policies to deal with the same. Many times, many big companies, what they have done is that they have set systems in place that will determine whether or not a particular IP address or a particular network is potentially performing some DOS or DDoS attack. If that happens, then each request from that domain needs to firstly pass a CAPTCHA test, which specifies whether or not the person whether or not a human is sending the request or machines are sending the request. Do note that this is not just enough for that, mainly because you can't just expect all of this to work just by software. There are several other softwares available for you to install and use for preventing DDoS attacks as well, but strong security policies are the major beneficiaries here. Then comes modification, corruption, and destruction of data. Data in the cloud is protected against unauthorized modification, corruption, and destruction of data. This is usually remedied using data dispersion and replication. So think about it this way: if you have some data and an unauthorized access has taken place, or maybe the data center where the data was stored suddenly crashes, goes down, some natural calamity happened, fire erupted, water came down, something happened, and the servers are destroyed. So the data that you had stored in a remote location where you have no access to it needs to be secured in such a way that it can survive these attacks or survive these calamities. One of the easiest way and one of the most preferred way is using data dispersion and replication. As we have discussed, replication basically means that you store multiple. What you do is you chunk the data into smaller pieces and then you spread those pieces across multiple locations so that they can be rebuilt again. Replication, on the other hand, is just copying the same file across multiple locations so that if one location goes down, the request for gaining access to the file can be transmitted to another server or another place, another geographical location. Data breaches and leakages are quite common nowadays. Data breach and leakage lead to data being accessed by unauthorized users who can then copy and transmit and view the data. To give you an example, when some data gets leaked on the internet, then a simple Google search will reveal the data to be available and to be used. To prevent this, we need to make sure that the sensitive data remains encrypted and HTTPS is used when data is being transmitted over the internet. This prevents data leakages mainly because once the connection is secured and HTTPS systems are being followed, then the data is encrypted over the network. So even if some person is able to essentially listen to what we are sending back and forth, they are not able to decrypt the data, and it's completely up to us to take a look at that. Then comes theft or accidental loss. If a user gains unauthorized access to the data and they can delete the data after creating a private copy of it, and the user may also end up accidentally deleting their own data. It is quite common to users for deleting their own information accidentally. There are several ways of preventing this. First one is make sure that the user is only able to gain access to read-only copies of the data so that they don't accidentally delete it unless they choose to change the mode. Know that this is not enough. Sometimes users are able to change the mode and forget which mode they are on, and if they're in admin mode, then they can delete the data easily. Also make sure that the data access is revoked by the owner or the administrator once the person is done with dealing with data. There are other things that you can do as well, such as multi-factor authentication, to make sure that the user doesn't accidentally click on two buttons and gets the job done that they didn't mean to do. They need to enter some CAPTCHA. There are many things that you can do in order to make it difficult for them to delete it accidentally. Then comes malware attack. Malware stands for malicious software, which can end up corrupting data all the resources that are stored on a particular device or on a network. So malwares are quite common, especially in cloud computing. So in order to get rid of them or to overcome this hurdle, the best way is to install antivirus and anti-malware software on your systems and make sure that they are regularly being updated, and then they regularly run their system checks when they are running, so that once the system is being run and malwares do end up attacking, they can be easily caught and can be removed. Also, it is to be made sure that the resources are not exposed to unknown devices or unknown networks, so that other people can access and install other software. Finally, there's improper sanitization. After data is deleted or delivered, it should be made sure that it cannot be recovered from any of the resources that the data was stored on. So for instance, once you download a archived copy of it and you delete the data, then it should not be possible for people to look at the cloud computing resources and recover bits and pieces of the data. To do this, you need to use proper policies to destroy data and destroy virtual disks on which the data is stored once the data is removed completely from them. Also make sure that both logical and physical deletion takes place. Logical deletion means that it's deleted from the file tables of the file system that is stored inside the disks, but physical deletion means that the actual bytes get wiped from the disk and it becomes completely clean, so that even if somebody wanted to, they can't recover the data from the disk on which we have performed the deletion. How we can design and apply data security technologies and strategies. In cloud computing, there are several ways of applying data security strategies, so let's take a look at them one by one. The first one is encryption and key management. Encryption is the process of using some process called algorithm to convert some data from its original form, known as the plain text form, to an alternative form known as the ciphertext form. Encryption of data is done using a special random data called the key. The key is a very important concept in encryption. Encryption essentially is a branch of cryptography. It is a cryptographical process. Basically means it hides the original meaning of data. So the contents of the ciphertext cannot be understood by anyone. It appears to be extremely random, and you can't draw any information out of this. Now, the ciphertext is converted back to plain text by using a process called decryption. Decryption is the reverse process of encryption, and and it is to be understood that for decrypting the data, the user needs to have the same key that an algorithm had used to encrypt it. There are several algorithms in which you can use a private key to encrypt the data, and then public key which could be multiple keys that the person can have. So in this regard, you don't need to share the same key with the person, but in other regards, you do need to share the first key, the same key to the person, so that the process could be reversed. That really depends on you. There are several kinds of keys available for you to use, such as symmetric keys, asymmetric keys, several algorithms for you to use. There's a whole range of things that you can do. The main thing to understand here is this, that keys are important to use, but they are difficult to manage. There are key management softwares that allow this to happen for you. For instance, if you have some key and you want to manage that key, then using a key management software is a great option for you if you have multiple keys and you have multiple data files that you have encrypted. They will also take care of knowing which data was encrypted using which key, and if the data that a key belonged to is deleted, could that key be deleted as well or not? All of this is a complicated process, and there are softwares that will do it for you. Essentially, the process works like this. Plain text is passed through an algorithm and a key supplied to the algorithm. These two features are important. Then this new key that was passed in allows it to encrypt the data and convert plain text to ciphertext. Then that ciphertext, when the user wants to read the data into it, the ciphertext is again passed through the algorithm to decrypt it using the key. Now that key, along with the algorithm and ciphertext, will convert it back to the plain text. Ciphertext is some text that has no meaning. You are not going to be able to understand what it actually contains. So even if a person was able to gain access to an encrypted data, let's say that you have some data stored inside a drive, somebody steals that drive, gains access to it over the internet, whatever it could be.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above? Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
They are not going to be able to extract the information from it because it needs to be decrypted, and it's only decryptable using a certain key, which that person does not have. Then comes hashing. Hashing is the process of converting some data of arbitrary size into a shorter fixed length value called its hash. Different hashing algorithms give you different size of hashes. Usually 64-bit strings are useful, for which there are 64 alphanumeric characters strung together one after the other. Hashing gives us the same data always as a result of the same value. So for instance, if I have some data and I hash it 4 times, I'm going to get the same hash or the same string of finite size. Now it could also be called the signature of the data. Now this is something that many people, when they first understand, find it a bit difficult to understand, mainly because it's not apparent where something like this would be used. So surely you can understand that you can get some data, pass it through an algorithm called the hashing algorithm, and it will give you a signature, if you would call it that, or a hash, if you would call it that, which is a fixed length string. And if you were to hash the data again and again and again, the same hash or the same key, same fingerprint will be given to you again and again. Now, where this is useful is something called integrity management. When you have some data and you want to verify if the data has reached you correctly, then you can use hashing algorithms. Many of the online providers of softwares do this. So, for instance, if you're downloading some really big piece of software, let's say an operating system, a disk image of an operating system, what they do is that they give you a small fixed length string, also called the checksum string. That string contains is the hash of the data that they have calculated. Now, once you download the operating system's image, you can then again pass it through the hash, calculate its hash, and then check whether its hash, the hash of the file you have downloaded, matches the hash of the file that you just copied. So then, if the hash is matched, then that means that the data has not been modified and you have downloaded the uncorrupted version of the data. If, for instance, even a single bit of information, if a 0 is turned to 1 or 1 is turned to 0, even that change is going to affect the entire hash, and it's going to give you a completely different result. So because of this, you need to understand that the hashes are really important and they are used to check data integrity. Now, another important thing to note is that hashes cannot be used to convert the back to the original data. So just as encryption, when you decrypt the data, you get the original data back. In hashing, there's no such concept. You can't unhash the data, just as you can't convert some large piece of information into a smaller piece and then convert it back to the larger piece. That's just not going to work. So that's how hashing works. Then comes masking. Masking is a very prominent technique. It's used by many online service providers. It is also called data obfuscation. As the name suggests, we essentially just hide some pieces of data that we want to be confidential. It is the process of hiding original data by modifying its content. If you have ever downloaded some official government documentation, then unless you are authorized to have that information, you will be able to download the document, but the data inside it will be masked using X symbols or O symbols or dashes or whatever. This is done to protect the data that can be considered commercially sensitive or even personally identifiable. So for instance, if it's a personal information or it's some commercial data such as the GST number, or could be anything that you do not want people outside your organization having access to. People who should not have access to this piece of information in some records are shown are as the masked data. Suppose you have some database and there are multiple people who can view the database information, since some of the database information is not something that is sensitive while other pieces are sensitive. So for instance, in the case here, the ID, name and email is a sensitive field. Now you can prevent access to the entire row itself. However, it is considered a better option to just hide the data that you don't want people to be able to recognize. So in cases like this, what you do is that you get the data and then you mask it. As you can see, after masking it, we, instead of getting john@example.com, we get the first and the last letter, and if the @ symbol is intact. Other than that, everything is hidden behind an X. The name and the ID field are not that sensitive, so you can just show them and it's fine. Although if you wanted to, you could mask those as well. If you want some data to be protected while others not to be protected, then masking is a good choice for you. Then comes tokenization. Now, tokenization is one of the easiest things to implement, and it is very easy to use as well. It is the process of substituting sensitive data elements with a non-sensitive equivalent, which has no exploitable meaning or value called a token. Essentially, what happens is that this tokenized data can be mapped back to its original form or the original data stored inside a token vault, which contains the tokens and the original values they correspond to. To give an example, let's say that I have an original value in which I have the ID and name column mapping to 1 and John respectively. I create some tokens. Tokens are just randomly generated things. So now the data is 1, and when we see 1 as the ID, it should be mapped to 7. Similarly, when the name becomes John, we want to map it to Brian. Now, whenever a person gains access to this data, they will only gain access to the tokenized version, and internally we'll be using the original version. The reason why this is useful is because once you are using data replacement techniques like this, even if the person gains access or hacks the information, they're going to get access to information that is completely nonsense. There's no record in our system of someone named Brian with the ID of 7. However, they are going to get it, not realizing that it's fake information, and they won't be able to make any use of it. On the other hand, we will be able to map it back to the original data, and that original data can then be used by our internal systems. So it's a good way of securing the system, so that even if there is a data breach, no one is able to access the actual data that they need to, unless the token data vault is also leaked, in which case you have bigger problems at hand. Then comes data loss prevention, also called DLP. Data loss preventions are a set of technologies that detect potential data breaches. It's not just a single piece of software, it's a group of software. It prevents them by monitoring, detecting, blocking sensitive data while in use, in motion, and at rest. Think of it this way: if you have some data and you are using it, it could be in motion, it could be in rest, or it could be in use while it's being created. These refer to the lifecycle stages of cloud data. And all of these different stages have different security requirements. Now, instead of you having to do it on your own, monitoring the data, detecting and blocking sensitive data, this can be done by data loss prevention systems. Standard data loss prevention systems use technologies like firewall, intrusion detection systems called IDS, antivirus softwares, anti-malware softwares, etc. There are also some advanced data loss prevention systems which use machine learning algorithms, temporal reasoning algorithms, user activity monitoring, etc. These help in understanding how the data is being accessed, if there's some irregularities in the users who are accessing the data, and if so, that the data can be either put into a vault and prevented access unless a person gives some OTP. There are different security policies that can be put into effect after a suspicious activity is discovered. Then comes data de-identification. Data de-identification is also called data anonymization. So if someone is talking about data anonymization, it's the same thing. It is the process that is used to prevent someone's personal identity from being revealed from some data. There are moments when there are times in your life when you submit some data with your consent, with the understanding that the data is not going to be out for other people to use. Your participation in the data collection process and your data that you have provided are going to be completely confidential. In cases like this, we need to provide some mechanism to de-identify the data or anonymize the data. This is usually done when some sensitive data is collected and the identity of the person is irrelevant. For example, when the data is collected from the participants in a medical study. You might end up collecting more information such as the name of the person, the email, if they should be, if they can be essentially contacted, if there's some important stuff that we found about it and we want to call them once again for some another kind of study. Now, in any of these cases, the problem here is that when you publish the study result of the study, you need to publish certain information, and in this publishment you need to verify and figure out that you are not leaking some personal information that you should have held back on. So in cases like this, what you can do is you can use data de-identification techniques. Data is de-identified after passing it through a series of steps, which uses techniques such as tokenization, masking, removal of personal data, etc. Personal data such as name, email, etc. are removed out of this. Now, several institutions and government bodies have their own rules and standards for data de-identification. So it may be that you don't have to do it on your own. Once you store the data inside some system, When you publish the results, the data that you will be given access to is going to be automatically de-identified. But in any case, it's important to understand. As the diagram shows below, a simple data de-identification pipeline in which we tokenize the data and then we mask the data and then we remove the data. So with that, now let's take a look at what else we can do. How you can implement data discovery. So in cloud computing, cloud computing is a set of technologies that can play a big role in data discovery. Data discovery is the process of collection and evaluation of data from various sources. There are several concepts that we need to understand, such as types of data, data discovery techniques, and the issues that might pertain when you're trying to do data discovery. Let's take a look at them one by one. So the first thing that we have to understand is the types of data. Data can be of several types, and discovering these types of data can be different from one another. So the two kinds of data that is available is structured and unstructured. Let us discuss them briefly one by one. Data that is comprised of clearly defined data types and patterns which make it easy to search and comprehend, e.g. data stored in tables, is called structured data. Think of data stored in your databases, your SQL databases, in which you have tables, columns, foreign keys, primary keys, and all of that. That's called structured data. It has a structure to it. You can see the structure repeating in multiple columns. You can search for data quite easily. You can see a pattern. You can comprehend the data easily. Then comes unstructured data, data that has no clearly defined structure and is not easily searchable. Data such as audio, video, images, so on and so forth. At the most basic level, this is binary data. When you take a look at the binary data, there's no structure, there's no pattern that's repeating. The only pattern that you can see is a bunch of ones and zeros are there, but that's not really a pattern, that's just a technology that is being used. Other than that, there's not much that you can do to understand how the things are working and how you can make searching and scrolling effective here. Now let's take a look at the different data discovery techniques that are available. So there are several techniques which you can use to perform data discovery, such as metadata, labels, and content analysis. Data discovery using metadata is really especially useful because many of the companies use this. Now, metadata is data about data, such as data when a file was created, column name was created, when the last time these things were edited, what is the last version of the file, the who created the file, when the file was created, when the file was last modified. There's a bunch of data about a file that could be considered information useful for data discovery process. It can be used to find and extract useful information, such as if the data was essentially modified in the last few weeks, that means that it is a useful piece of information. However, if it hasn't been touched in a month, then that means that it could be moved to an archive storage. Maybe we can store it into a data warehouse where this data will be worked on and will get some insight out of it. Then comes labels. Labels are descriptions of data, such as the description of what an image contains. These descriptions can be used to group and classify data. For instance, if you have certain images that contain a particular piece of information that is useful to you, let's say that you are trying to build a system that can determine whether or not a particular image contains a traffic light, and multiple traffic lights are going to be inside an image. They can be labeled as containing the classified information or containing the traffic light image, and the other one would be considered not containing the traffic light image. You could go even further and further classify them as when they are containing the traffic light image is one of the lights in the traffic lights on, which one is it red, green, or blue, and so on and so forth. So these are all done using labels, and labels provide very useful information so that we can then discover the data based on the labels that are provided. Then comes content analysis. Content analysis allows us to analyze the documents and artifacts of various formats such as text, pictures, audio, video, etc. This analysis allows us to examine patterns and extract features from the content, such as emotions being shown in a review, etc. If you have some online review that is written and you want to analyze the content and figure out how the content is being structured, what are the words that are used, what are the keywords that are used, does the reviewer review the piece of information favorably or unfavorably? Is he or she happy with the product? Is he or she unhappy, satisfied, unsatisfied, sad, happy, angry, so on and so forth. So this is also very useful. Now comes data discovery issues. Now, data discovery is a complicated process, and as with any complicated process, there are several issues associated with the data discovery process. Let us take a look at them one by one. The ones that we'll be taking a look at are poor quality of data, dashboards, and hidden costs. Poor quality of data basically means that the discovery of data among data that is not correctly classified, that is not correctly cleaned, that contains incorrect information, missing information, that could be a source of a lot of problems. And this could lead to a lot of misleading statistics and misleading facts that may or may not be true because the data is so poor. So poor data can be a major cause of issues. Then comes dashboards. Now, a dashboard is an important data visualization tool in data recovery. However, it can be difficult to build based on the complexity of data and the size of the data. If you have data complexity, data shape is very complex, then visualizing it is going to be really difficult considering the edge cases that you might have to consider, in which data is nested deeply within one another. Now you have to go through each of the nested places to find out whether or not some data is available there, and if there is, then you extract that data, go back up the hierarchy, and then go down. This is going to be really difficult, so it could be an issue, especially if the data comes from a source that you do not control. They can even change the data, and the shape of the data is changed, then your application needs to adapt to that as well. Then comes hidden costs. Costs associated with data discovery are difficult to estimate. These costs estimate may turn out to be underestimated, or hidden costs may emerge if the data is not analyzed properly for the estimation process. So understanding what kind of data you have, what is the complexity of the data, and how you are going to go about doing this will allow you to figure out what are the hidden costs. Cost may not only be monetary, it could also be time-based cost. For instance, if you determine that it's going to take you 3 months to create a data discovery pipeline there, but it ends up taking you 6 months or 7 months, that means more and more time is being used and more resources of the company are being used here. So it's important to understand how you're going to do that. With that, we have understood all there is to understand about data discovery in the cloud. It is a process that is very important, and these are the issues and techniques that you can use in order to do data discovery. Now let's take a look at data classification. Data classification, or how you can implement data classification in cloud computing. What are the things that you should know before you implement data classification? Now, data classification is the process of analyzing structured or unstructured data and organizing it into categories based on file types, contents, and other metadata. There are several options in data classification, such as mapping, labeling, and dealing with sensitive data, etc. Now, mapping refers to the process of creating links between features and data in a dataset. Suppose you have some dataset that contains images of famous people. The mapping is going to be the features and the data that is considered contains in the dataset. Or another way of thinking about it is if you have some medical data, then you can create several links between several kinds of data. For instance, one kind of a feature would be if the person is old or new, or you can say old or young. And in cases like this, you can create a link between the old feature and attach it to one particular file and one particular row of data, and then the young people will be given the feature of young. This way, it's easy to categorize and group data together. So for instance, if you have some data that contains just the age of people, but you want to classify them as being old, as being senior citizens, as being young, as being teenagers, as being babies, as being adults as well. So you can generate these features, and then you can just map them to those. Then there's labeling. Labeling is the process of assigning classification labels to determine a class in which a particular row of data belongs to. So taking forward our medical information dataset, let's say that we want to determine a particular person has diabetes or not. If it turns out that a particular person has diabetes, then the data in the row in which it is existing will be labeled as positive. Positive meaning that the person has diabetes. It's a yes or no binary classification. You could also put yes or 1 or 0 as well. A person who does not have diabetes will have 0 in their row. The meaning of 1 and 0, yes or no, and positive and negative are already predetermined because we are checking for a person having diabetes or not. Then comes sensitive information. Whenever trying to deal with data classification with sensitive data, special needs to be taken care of data that is being used for data classification, such as the protected health information, also called PHI, personally identifiable information, PII, and cardholder data. So depending on the kind of data that you're working with, there's special kinds of care you need to take care of when you're dealing with these kinds of data. So these are the considerations that you need to take care of. These are the processes that work with data classification. Now let's see how we can design and implement information rights management systems in cloud computing environment. So information rights management are technologies and processes that protect sensitive information from unauthorized access. For IRM, we have to understand these things, the objectives and the tools. So let's firstly take a look at the information right management's objectives. Now, as with any technology, there are several objectives that are associated with the information rights management system. But the main ones are data rights, provisioning, and access models. There may be other objectives that you can tack on based on how you want to structure your applications and how you want to deal with the entire data access models. But overall, you have to understand that these are the basic tenets or the objective that we need to understand. The first one is data rights. As the name suggests, data rights give people authority over their data. They offer the right to access, change, move, and delete their data. Essentially, this is to determine what person has what right over what data. If I create some data, do I then have the right to manage the data, change the data, basically be the administrator of the data? Or does the organization that I am working for has the administrative right and I only have the right of requesting certain permissions for that data? That is covered under data rights. Now, which one of it is for you is something that you need to determine based on the use case that you have. To give you an example, let's say that you want to essentially create a system that works only for yourself, that you're the only person who will be using it, and the data is only going to be the data that you create. So think of it such as a blogging system. In cases like this, it is a good idea to give the employee who will be working with the data complete access over the data. They can change the data, they can add the data, they can delete the data.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
Whether or not some information is being collected about how the data is changing, what are the changes being made, who are making these changes, when and why, that remains up for consideration, and you can do so yourself. But in any case, data rights essentially means that you determine the people and the authority that they have over the data. So if you're someone who has been using blogging platforms such as WordPress for a company, then and you move it to the cloud, then several of these facts apply to you as well. Then comes data provisioning. It is the process of creating and deleting users from a system. These users have authorization properties associated with them, such as roles, groups, permissions, etc. It may seem really easy to create and delete users, also called provision and deprovision users. However, there's a fair bit of complexity that is associated with it once you take into account the complex networks of attributes that are associated with each user. A user can have different roles such as administrator, viewer, commenter, so on and so forth. And a user can belong to several groups, such as the admin group, the managers group, the management group, and many other kinds of groups. And each person can have several permissions such as being able to access some data, being able to remove some data, being able to spin up some servers and delete some servers, being able to add new infrastructure resources such as servers, load balancers, networks, virtual networks, etc. In all of these, the important thing to understand is that all of these needs to be managed using a permission system. The permission system's primary job is to take care of whether or not you are able to create some data, delete some data, and are the permission applied to you removed once you have been deprovisioned. So if you create a user and you then deprovision that user, do you deprovision their entire identity, or do you deprovision the rights given to them for certain resources? So do you disallow the person from creating new servers, but you keep their identity in your identity management systems? All of these are things that you need to consider when you are designing the security and authorization policies. Which is why it is determined that these systems are very complicated, and they should not be given in hands of every person, because if people don't have the strong understanding of authentication and authorization policies that need to be set for a secure environment, then giving them that kind of access is going to be really problematic for the people who do give them that kind of access. Then comes access models. An access model defines users what a user can do and cannot do on the data based on several factors such as their roles, permissions, and the group that they belong to. So in provisioning, what we do is we create the user and we remove the user, and we take care of all the other aspects associated with them. As mentioned before, this gets particularly complicated because of all the values, all the attributes associated with the user, and depending on each use case, we have to determine a particular solution. Access models, on the other hand, determine which role can access which resources, which role can access which data, what permissions are given to a particular user, what groups are associated with particular permissions, so on. To give an example, if you have a cloud computing infrastructure and you're managing the rights and management of everyone, then if a person builds an application and they are the developers, then they should be given access to servers on which the data, the application is being deployed, and the right access to the servers on which the data is being written, or but treated right access. On the other hand, if a person is an administrator, then they should have full access over all of these. Preferably, only one person is given administrator access over all of the resources. If possible, don't give just one person or anyone that kind of access. Compartmentalizing these accesses can be a better option here as well. Another thing to notice is that there are several groups as well. So depending on what kind of permissions you're giving to a group or a person is going to be understandable. Suppose there's a person who belongs to the developer group and the management group, which is to say that they are a developer and a manager at the same time. And in cases like this, they should have access to users' information, they should have access to employees' information, their salary, and so on. And they should also have access to infrastructure resources so that the applications are being deployed and they can take a look at how they're being deployed. However, if the person then gets demoted from a manager to just an employee, then they should be kicked out of a group that gives them that access. Instead of just removing all the accesses for that entire group, we should kick out that person from that group. Again, this depends on the situation that you are faced with, and so on and so forth. Now let's take a look at the appropriate tools that we would have to use to implement information rights management. As we have discussed thus far, that it's not easy as it might seem to determine the rights that a person has on particular information in cloud computing environments, and how do people craft their own cloud computing information rights management system depends on the tools and that are available for them. So for digital rights management, we make use of several concepts such as keys, certificates, etc. These concepts require several tools several tools that can perform certain tasks such as issuing certificates, revoking certificate, and certificate revocation. Different tools can do these tasks, or maybe you can create just a single tool that can do all of these tasks. It is to understand that these certificates are cryptographic certificates. It's not a piece of paper that you can just randomly create and copy and paste. They have their own cryptographic signatures, and if a particular action is authorized using a particular certificate, then that person's name is associated with it. And these keys also, these cryptographic certificates also come with keys in order to determine whether or not a person has given their consent for these certificates to be used. Specialized tools that use cryptography to issue cryptographic certificates with securely specifying users' identity and tasks that they need to be permitted to need to be created. Issuing these certificates is a cryptographic process. This is not extremely or lightning fast as multiplying to numbers maybe of all the other tasks that we perform in a computer-based system maybe. Here we have to understand that these are specialized tools and that they use cryptographic processes. This could take a lot of time depending on the strength of the cryptography that we're using. And so issuing the certificates is a task that is best left on tools, because tools are much better at issuing things and keeping track of things that are issued thus far. Then comes revoking certificates. Certification revocation is basically the process of revoking the certificate so that it cannot be used further. This is also a cryptographic process. Again, cryptographic processes may seem like a very easy term to use. However, cryptographic process are really important to understand. The important thing to understand here is that since these are cryptographic processes, that means that you do not get access to essentially do anything that you want with these things. They are properly secured, and that's why to maintain the integrity and security of the certificates and the meaning of the certificates, we keep track of these certificates using specialized tools. That's why for issuing certificates and revoking certificates, we use specialized tools. Otherwise, all we would have to do is basically just delete the certificate that is inside our database, and that would be it. But since it's a cryptographic process, there's a lot more involved in it. Cryptography uses a lot of mathematics in order to maintain the integrity of a particular system. So we need to take care of that as well.
Just a quick info, guys. Test your knowledge of cloud security by answering this question. Which data may not be suitable for public clouds? A. Legacy application data. B. Mission critical workloads. C. Sensitive data. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So these are the two kinds of ways. Third one is certificate replication. Suppose a particular certificate needs to be issued to multiple people. In cases like this, or suppose a multiple simple key needs to be given to multiple people, maybe it's a public key and we have private key, we have generated multiple public keys and we need to be distributed to each person. This is also a cryptographic procedure and needs to be handled by a special tool. So these are the kinds of things that we need to take care of when we're dealing with the certification, using certificates, issuing certificates, revoking certificates, and certificate replication as well. These are cryptographic certificates. They are secure. You can't just automatically create the certificate. Once the certificates are created, then the tasks that these certificates are used to authorize, these certificates are then verified by a verification system, and that certificate verification system then lets go of the task if the certificates are verified correctly. If not, then this is logged inside a system which will be notified to the data administrator. So with that, we have understood all that is to be understood about information rights management. Now let's take a look at how we can plan, implement data retention, deletion, and archiving policies. So there needs to be policies that deal with several activities performed on data in cloud, such as retention policies, deletion policies, archiving policies, and legal hold policies. Let us try and understand them one by one. The first one is retention policy. As the name suggests, the retention policies are used in order to determine how a particular system is going to retain the data that is provided to us. So essentially, think about it this way. When you have a cloud data policy for retention of certain data, the thing to understand here is this: how the data is going to be retained, for how long it is going to be retained, is it going to be deleted after a while, and how is this going to affect the data's integrity. If someone gains access to a particular data server, is my data encrypted? Is the data that has been retained deleted immediately when I delete it? Is it a logical deletion? Is it a physical deletion? As you can see, there's a lot of policies that need to be taken care of. But retention specifically takes care of how the data is retained. What are the geographical locations where the data is copied? What is the uptime of these geographical locations? Is it encrypted? What level of encryption is there? And so on and so forth. Then comes deletion policies. These specify how to securely delete the data when a specific resource is assigned to a different user. They should not be able to recover the deleted data. Let's understand this using a scenario. Suppose that you are working on a cloud computing system. You have created some data and you have been creating some data on those cloud computing platforms for a long period of time. Suddenly, the application that you used to do is no longer useful and you decide to take it off the internet. Now, for doing that, first things first, you need to delete the data that your users have submitted, such as their email, passwords, mobile number, and many other kinds of things. Now, in cases like this becomes really difficult because once you understand that you have to delete the data, you first have to realize where exactly have you put the data. Is it just in the database? Are the databases storing the data or logs inside some other files as well? Are there some cache files? Are there some servers on which locally the data is stored, so on and so forth. Using this, what we end up doing is we end up creating the policies that will delete the data. So once we end up taking our application off the offline, then we delete the data that is given to us by user by firstly deleting the databases, deleting the servers, deleting the virtual hard drives, so on and so forth. Now, it is to be done in such a way that the data that was deleted could never be recovered by anyone, whether or not they gain access to the same resource. So the virtual server that you had created to host your application stored some data. You deleted that virtual server, but that data is still being stored in some ephemeral storage. When someone creates a new server and gets assigned that kind of it gets assigned the same resources that you did, then can they still recover the data? Can they still find the data or not? These are the kind of things that we need to worry about in the deletion policies of our data retention policy. Then comes archiving policy. These specify how long the data needs to be dormant before it is archived, how long the archiving process needs to store the data for. So to give you an example, archiving is the process when you store some data that is not very frequently used. The dormant data here basically means that it hasn't been used for a long time. Suppose I create some data and I store it in a file. Then I forget about the file and I don't use it for let's say 6 months. Now that you consider some data not being used for 6 months dormant? If so, then in your policy that will be specified, and every time when 6 months pass and a particular file has not been used, then that will be moved to an archived storage. That will cause it to cost less because it's not in the raw storage format, it's in archived storage. Latency of accessing and using the file is going to be more, but since you have not accessed it for 6 months, it's a good bet that it's not going to be used for another 6 months or for a long period of time. In any case, once you archive the data, then you need to understand that how long does the archive data needs to be there. Certain organizations keep some data for archived forever, while others don't like to keep the data archived for any period of time. So in cases like this, we would recommend that what you do is you specify some archiving deletion policies in which you specify if the data has been in archive for 1 year and no one has touched the data, then it's safe to delete the data with the user's permission. Now that permission could be that they send you an email that the cloud service provider, once you log into their console, tells you that this has been the case and would you like to delete the file or review the file. And in any case, these are how these things can be done. Again, you can craft your own policies, you can negotiate with the cloud provider, you can use a cloud broker to do the negotiation bit for you. The important point here to understand is that these are the ways that you can do these things. Then comes legal hold and policies. So some data is highly sensitive in a legal context, which means that some data is extremely legally sensitive, and misuse of that data, unauthorized access of that data, all of that could lead to really high fines and criminal cases against both the person who stored the data and the place where it was stored, if the place it was stored was not in-house. So within specific regions, within specified encryption policies, there are certain regulations that we must follow when we are storing this highly sensitive data. It could be governmental data, it could be medical data, it could be anything. So these regulations need to be followed. For instance, if you are storing some data that is stored inside a particular facility, let's say that you are working with the US government, they have their own specified encryption strategies and how you can encrypt the data, how you would decrypt the data. There are specific procedures that you can follow in order to encrypt and decrypt the data. There are specified regions in which that data should reside, so on and so forth. So there's a lot that we have to be cognizant about when we're learning about cloud policies for legal data. The legality of the situation could be drastic in the sense that once you are working with cloud data policies, you do not know how the cloud data policies are going to be followed. So you can also set up some audits there as well. Several government organizations also perform random audits so that they can determine whether the regulations are being followed or not. So with that, we come to the end of cloud data policies. Now let's take a look at how you can design and implement auditability, traceability, and accountability of data events. Data events are notifications caused by creation, modification, or deletion of data. There are several factors associated with data events, such as event sources, analysis, non-repudiation, and chain of custody. And we'll take a look at them one by one. First thing to understand is that data events are not a new concept. Data events are basically just some metadata that we store about the modifications or changes made to some data, such as when some new data is added to a particular folder, when the data's contents are changed, when that data is deleted, or when that data has its content is replaced by some other contents. All of that is taken care of And these data events contain information such as the person who changed the data, time it was changed on, when the data was created, when the data was destroyed. If it was destroyed, then this kind of information will be stored. What were the changes that were made, and at what time were the changes made. Using these kinds of metrics, what we can do is we can determine whether or not a particular piece of information was unauthorized, was caused by unauthorized access, was some data accidentally or maliciously deleted by someone, and if so, who was that person, and how can we retrieve the data back? What are the changes that were made by the person so that we can uncorrupt the data and change it back to its original form. All of this is an important tool to understand, and that's why we have cloud data events. Many cloud computing service providers provide these capabilities out of the box, so you don't have to worry about them right out of the gate. However, you do need to understand that these tools are very powerful, and understanding what are the security challenges associated with them can be useful. The first one is event sources. This is a term that is used in software development quite a lot. Event sourcing is a particular kind of software. Event sourcing is the process of keeping track of all the information regarding changes made to some data in a system, and event sources are the softwares that save or log this information. If you are a software engineer, then you definitely would have worked or either heard of a system like this. It's a very popular system called Git. Git is a version control system. For those of you who are unaware, Git is how software developers manage the versions of the software that they are working on. The new changes that are made by people can be pulled down from GitHub. They can submit their own changes, and they can merge new changes to original existing files. Git also keeps track of all the changes that are made to the files, and the labels associated with it are the commits message. So if you have ever written a commit message, you need to understand that these commit messages are the description of the changes that you have made, and the changes that you have made are also kept as records in Git. So if you, for instance, determine that one of the changes that were made and were merged into the master branch are not good and you need to revert back to the original systems, in cases like this, what you can do is you can use you can revert to an original form of the data, or you can revert to the state of the data before it was changed. This is possible in event source systems. So this is why event sourcing is considered such a powerful tool. Similarly, in cloud computing, when data is stored online, the data, when it was created, when it was destroyed, when was it accessed last, by whom it was accessed, who changed its content, what were the contents changed from, what were the contents changed to, and several other information can be kept track of. Again, for example, in Google Docs, you can do this. All you have to do there is essentially you create a spreadsheet and you keep track of the changes that people made and when they made them. This makes it really easy to blame for some disastrous change made by someone based on the event source data that was kept. Now, let's take a look at analysis. Data analysis is also an important aspect of software of data events. These data events need to be properly logged, stored, and analyzed. Once they are analyzed, you can also create dashboards for visualization of the data. What is important for you to understand here is this. The dashboards that are created are not for us, they are for the non-technical people. Usually the data that is stored using event sourcing systems and data events are in text format. They are logged in databases, flat files, object stores, wherever we want to and however we want to store them. And after that, once the data is analyzed, we can determine trends, we can determine people who made the changes, how the changes were made, and we can create interactive dashboards that can take you through the entire timeline of the data that was changed. In cases like this, we recommend that you take a look at data services, and for that, you need to firstly understand the shape of the data that you have logged as the event sources. Then you need to understand how you can create a dashboard. Several services provide these kind of services for you, so you can just basically plug in some data or plug in some service to your cloud service provider, integrate them, and then they will fetch the data from the event sources securely and then create the dashboard for you. Important point to understand here is that even if the dashboards are created, you need to understand that these need to be done in a secure way. So if you are using an external system, then it could be difficult. Many cloud service providers provide their own systems to visualize some kind of data, so you can use those as well. Then comes non-repudiation. Non-repudiation is actually a desirable trait in any secure system. It means that it's a situation where a customer cannot deny authorship of some data and its event. So to give you an example, suppose I have some data and I made some changes to it. Those changes lead to a devastating effect, and now my data is corrupted. the organization that I'm a part of starts blaming cloud computing providers. They can, for instance, tell the cloud computing providers that this is your fault and you need to fix it. Now, in cases like this, what the cloud computing systems could do, can take a look at the event logs and just tell that, okay, this is what the event logs say. We can't change the event logs unless it's been made by your organization. That's the policy that we had set. And it shows that one employee of your organization has changed the data. That means that you are the people who need to take care of this. In cases like this, non-repudiation is actually used to essentially specify the order in which, or specify the authorship, which is determined by the event sources. So who made what changes led to what catastrophic failures, what changes led to what successful failure, successful events, so on and so forth. In any of these cases, first thing to understand is that non-repudiation is usually used in many cryptographically secured systems. So it's not something that is new. However, it is to be understood that even if we create any kind of cloud data event system, non-repudiation is one of the key tenets that we need to make sure that we are following. And then comes chain of custody. Now, chain of custody could be a little difficult of a topic to understand right off the bat. Chain of custody refers to the documentation that establishes a record of the control of transfer and disposition of the control of data. Basic idea is this: once you have some data and some people have some access to that data, when that person's access is revoked or is transferred to another person or another ID, that also needs to be checked. And when something catastrophic happens, then this chain of custody, which is I held the custody for the data and then somebody else did and then somebody else did, this needs to be maintained so that in cases of catastrophic failure, data breaches, data leakages, we can get a proper understanding of the timeline of how the data was used, and we can also determine the culprits who might have committed these issues. This doesn't necessarily mean that that chain of custody is the only saving grace. You also need to maintain all the other kinds of non-repudiation analysis, event sourcing, and so on and so forth. However, chain of custody is an important aspect. Chain of custody is such an important aspect that it's not only used in cloud data events, but also in legal withholds. So if you have ever been involved in a legal case, there are also chain of custody is something that needs to be established. And in cases like this, all of these things need to be taken into consideration. So just to recap, the things that we have taken a look at thus far is the data events. What are data events? We understood what event sources are. We understand how the analysis of event sources takes place. We understand what non-repudiation is, and we understand what chain of custody is. All of these things collect data that is then audited by auditors, and we determine who was the culprit, who were the people because of whom particular data breach or a data leakage happened. So this is how you implement auditing, traceability, and all of that in your cloud computing system. Data events are an important aspect because they allow us to understand how the data was changed and who changed the data and how we can recover the data back.
So coming to the first question on the top cloud computing interview questions and answer set, we have a question that states compare between cloud and on-premise computing. Well, whenever we go on to compare cloud and on-premise computing, you really have to talk about 5 very important points. And the first thing is, of course, it's always going to be initial cost, because so whenever you're talking about a cloud computing environment, your initial cost to set up the hardware is extremely low compared to having an on-premise setup. And then coming to maintenance is mostly hassle-free in a cloud computing environment because you really do not have to have experts standing by working with the hardware, associated software, network and all of that. But in the case of on-premise software, you do require good amount of expertise there. And when you're thinking about scalability and upgradability, right? Cloud computing, the middle name of cloud computing should be scalability and upgradability in my name, because it's automatic, it's excellent, it does a very good job of, if you want to go from, if you want to scale from, let's say, 1 gigabyte storage to 10 terabytes in matter of, half an hour, it is really possible that quick today. And it's not only that, right? So when you're talking about upgradability, you want to use the computing power of one machine versus, 10, 12, 30 at a moment's notice. Yes, it's possible. And then when you think about one of the biggest advantages of cloud computing is the pay as you go policy, because at the end of the day, you'll only be putting down money for the things that that cost you money, basically at the end of the day. So what I mean by that is, if you're using certain computing resources, you'll only be charged for that rather than the
the entire thing, for example. So in that particular case, depending on how much storage you use, how much computing power you use, for what amount of time has your cloud computing environment been running, it's been up, the instance has been created and it's being used, based on all of that, you will have to pay as per you go. Now, coming to the second question, it states, what is a cloud? Well, this is a very generic question, so make sure you do not get carried away by the simplicity of the question. Make sure to keep the answer concise. See, a cloud is nothing but a collection of networks, collection of hardware, services, storage, and an interface that brings it all together to make sure that you can provide all of these, right? Hardware, computing power, and storage as a service to the people out there who have access to an internet connections. So who uses cloud? Well, we have end users who make use of cloud. For example, we ourselves will be using a lot of cloud, right? Think about it. Backing up your photos to the Apple iCloud or Google Photos itself is using a cloud service. And then you have business management users and of course the cloud providers themselves, right? So the service providers themselves are the ones who are providing the service. There are a lot of big names when it comes to cloud computing, and you can either use it for personal usages or business applications too. Coming to question number 3, it can be a follow-up to the previous question, but here we are asking, what is cloud computing? See, when you're talking about cloud computing, you have to understand that it's not only just cloud storage, it's a lot more than that. It's literally having supercomputers at the tip of your fingers and using all of its computing power, all of its resources, all of its storage as well. So, you can do everything with today's cloud computing out there. You can run, government organizations, military networks. You can, handle everything that's present in space as well with the use of cloud computing networks. Yes, NASA does use a lot of cloud computing. It's a very important innovation in the modern world where technology is provided as a service, and based on the user's requirements, technology can be implemented in a way to cater to very specific requirements without having to put down a lot of money or a lot of time too. This is cloud computing in a whole. Now, coming to question number 4, it says, what are the benefits of cloud computing? Well, again, this is another question which is very, which makes it very easy for you to get carried away with the answer. But I definitely recommend, at least taking your time to answer it in a concise way with at least 4 or 5 points to talk about the benefits of cloud computing. I am sure you can probably state 10 or 15 points. It's really good. If you're not explaining the points, do talk about the points and list them. But if you want to explain about each different point, make sure you're keeping the answer concise. For example, you can have automated data backups, automated storage of data. You can have very powerful server capabilities, very good amount of productivity. There's not much upfront cost for the hardware. You can save a lot of money. You can save a lot of time. You can access it remotely from any part of the world, depending on how good your internet connection is and all of that. So you can go on and on and on. So make sure you're sticking to at least 5 very good foundational points such as this, and then build your way from there. Coming to the 5th question, it says, mention the layers of the PaaS or the PaaS architecture. See, whenever we're talking about PaaS, you have to know that it's platform as a service, right? So you get a lot of details in PaaS, SaaS, and of course, the other kinds of architectures that are present in cloud computing as well. But one thing is that whenever you're asked a specific question such as, we want the layers of PaaS architecture, make sure to know that exactly as how I've shown here. See, there's 3 main layers. One is the cloud controller layer. Of course, we have the storage services layer, and we have the application storage layer. Now, when you're talking about the platform as a service architecture here, what we do with the cloud controller is we make sure that, you have virtual machines that get created. You have controllers for those virtual machines. You can deploy the applications. You can connect to services, scale up, scale down based on your requirement and match, the requirements. So all the things that control the actual environment through which you're going to run your machines on, that's cloud controller. And then we have the storage services. Of course, we have to have a place where we can manage data, ingest data, process it and store it, right? For that particular case, you can make use of objects, you can make use of NoSQL, the relational databases, block storage. There's a lot of different kinds of storage services that are provided. And then of course, when you're thinking about the applications that get stored in these, right? So you can have applications which are simple to scale. They can be easy to recover from if there was any sort of failure. Chances of failure in today's world of cloud computing is very lean, but even if there is a chance of failure, you can recover your data very easily in a PaaS architecture through this particular storage services as well. I mean, of course, you can go on to explain more and more in case if the interviewer does expect, but this is a good framework to approach this question and answer it effectively. Coming to question number 6, it says, what are the cloud service models that are out there today? Well, you can be asked a question in a very different way, saying, can you explain the various services that the cloud offers today as well? It's the same question. Now, coming to the answer of this, there are 3 main types of, the cloud service models that we have today. One, we have PaaS, which is platform as a service. We have SaaS, software as a service. And of course, we have IaaS, which is infrastructure as a service. If you are in this video at this point of time, I'm sure you have heard of all of these and you know the differences that exist between them. If you do not, I would definitely suggest you check out the cloud computing video that we have. In fact, we have multiple videos on cloud computing here on the Intellipaat YouTube channel. So make sure to brush up on all of the concepts, because this forms to be a very basic foundational concept that you really have to know in case if you're planning to have a serious career in cloud computing. So coming to question number 7, it states, what are the components of Windows Azure? Well, the Windows Azure platform services offer a lot of things, but there are 3 most important components, under which of course you have a lot of other components, so sub-components too. We have the cloud computing environment, we have SQL Azure, we have the application fabric, which will allow for a fabric cloud to be used, and then you can have a lot of sub-components as well. See, in the cloud you can have a lot of subcategories of how the cloud is used, and what the cloud provides, what makes it native, what makes it special, and all of that too. And of course, when you're talking about SQL, that's an ocean of its own, right? But once you're asked for the components, do put it out in a clear way, such as this. And of course, if you are asked to explain, there might be a follow-up question saying, okay, can you talk about Microsoft Azure Cloud? In that particular case, of course, with the follow-up question, you can go on to answer that too. Coming to question number 8, it says, what are the differences occurred in distributed operations? Well, whenever we're talking about distributed operations, FC and Nova come into the picture, right? So in FC, we have the operations that take place as a master-slave, master-slave architecture. But then when we're talking about Nova, the main difference here lies in how, processes are executed parallelly and how its data gets shared across, the network or the channel whenever it is required to. So whenever you're thinking about distributed operations, make sure you talk about how master-slave operations work, and of course how the data gets stored, how processes can run, either if it's based on events or if it's based on triggers or if it's based on a requirement for scaling, and a lot of that too. Coming to question number 9, it says, which agent is equivalent of Nova Compute? Well, Nova Compute has a very good equivalent, and in fact, I would say that the equivalent of Nova Compute is Azure Agent to one point of time, because it's considered to be on par with Nova Compute. But in my honest opinion, I think Azure Agent has a lot of lot under its belt that makes it that gives it the particular edge to move it one step ahead of Nova Compute. So what do you guys think? Have you used Nova Compute? Have you used the Azure Agent? If you do have, head to the comment section and do let us know. And then coming to the 10th question, it says, mention the reliability and availability of cloud computing. Well, again, this is a very important question. There's a very good chance that you'll be asked this particular question, right? So to attack it really well, do talk about how fault handling is done in the world of cloud computing, right? So when we talk about how 2 virtual machines are used in a single fault domain, if there is one particular hardware that fails, it means that both of your virtual machines can fail. But what a cloud computing platform like Microsoft Azure does in this particular case is it has the capability to automatically distribute instances of a role across a lot of fault domains too. But when we go on to talk about how we can use the upgrade domains to make sure our data is available and of course it's reliable, right? In that particular case, whenever think of the scenario where a new software version gets rolled out, right? Version control is something that's very important, and every time that this gets done, we make sure that any sort of service that is attached to it, or any sort of data storage that is using this particular instance of it, that it is completely available for usage. And it is making sure that even though there might be multiple instances that get created and operated based upon that, well, in that particular case too, of course, it will be readily available to scale. The availability of programming power and the availability of how data can be scaled in a reliable way is the talk of the day whenever we talk about how we can go on to use upgrade domains. But when we're talking about a cloud computing platform and availability and the reliability in terms of security, one very important thing in my opinion is to talk about network and the storage availability, right? Because you can have your data to be copied in multiple storage areas in multiple different domains across servers in multiple different continents too. So why do we do this? We do this for one, required redundancy, where if there is a data failure, we can pull all the data back to make sure that we have sufficient backups. And the other reason is that if one of these servers, in case if you have accumulated all your data there, is under a DOS or a denial of service attack, in that particular case, you might not be able to access the content present in that server, and it might not be able to function effectively, right? In that particular case, your client, your business, or whatever it is that you're running on the cloud might come to a halt because the server is not able to provide services for you. To avoid all of that, we do have this kind of redundancy that's built in to today's cloud computing platforms. And then coming to the 11th question, it states, give the best example for open source cloud computing. Well, if open source cloud computing has to be spoken about, I think OpenStack always takes the center stage because it's a very, very good example of what an open source platform should be. It's extremely popular among the startups of today, mid-tier companies. It does provide a lot of functionality because, at the end of the day, you might be thinking, do you really have to put in a lot of money into Amazon Web Services, Azure, or Google Cloud Platform? And, if you are a small company or if you're starting up, you might not have the budget to allocate that much too. In that particular case, do think about OpenStack, because OpenStack is one of these platforms that will help you rapidly scale up, at least at the start. And it has, of course, thousands and thousands of developers across the globe pitching in to make OpenStack better than what it is every single day. That particular case, I do believe that OpenStack is in fact one of the best examples of open source cloud platforming we have today. Coming to question number 12, it says, what is AMI? How do we implement it? So AMI is basically short for Amazon Machine Engine. What it means is that it is a copy of your root file system itself. It feeds all the information that is required to launch any sort of instance on the AWS platform. So you implement this kind of a machine image whenever you actually want to go, launch a particular instance. Of course, you can have multiple instances that can be launched from one single machine image with the same configuration as well. Of course, if the configurations now become different, then you'll have to launch multiple instances and you'll have to launch multiple AMIs as well. But if you have a same configuration that you want to scale across multiple instances, do remember this important point that you can use the same Amazon machine image too. So the image on the screen I hope is pretty self-explanatory at this point of time. You're going to create an EBS snapshot. It's going to get registered with the AMI, which is the Amazon machine image, and once you launch an instance, you can directly start using the instance. And of course, if you want to copy it to another instance, that can be done directly if there is a similar configuration in the machine in the second instance that you want to launch too. So how can you implement it, right? So coming to the answer of the second part of this, AMI will include one or more of the snapshots of your EBS volumes. Let's say, in the case of backed AMIs, you will have the instance that will get stored. And of course, you will have a lot of other things as well. Think about the template for the root volume, because you'll have to copy it, right? So what are the contents of the template of a root volume? You'll have the application server, you'll have all the applications that bring with it. And what is the most important thing that you require? Of course, an operating system, right? So all of these will be contained in the EBS volumes. So we can go on to basically say that it launches the permission that we decide, based on what AWS account can use what AMI for what instances. That's a mapping that goes on depending on your account too. Now, one very important thing you have to talk about is that it will also require a block device mapping, because at the end of the day, you'll have to specify what volumes have to be attached to what instances whenever they're launched, right? Be it a copy of the same AMI or be it a completely different AMI, you have to, specify the volumes that you want to use, and of course, either you want it to be copied or you want it to start fresh and all of that too. Now, with this, we can move on to question number 13 that states, why are hybrid clouds so important? There are many types of cloud computing today, and guys, you really have to know the different types of cloud computing environments that we have today. And then when you talk about hybrid cloud environments, right, you do have to talk about how they are so effective at what they do. See, there's something called as cloud bursting where you can access all the capacity and the specialized software that are available, let's say, in a public cloud and not in a private cloud, right? So whenever you're thinking about examples, think about Dynamo, think about Amazon, think about virtual Amazon and others too. So why do we do this? We can leverage the best of both worlds, right? Now, when you're thinking about vCloud is basically a VMware cloud. It's of course a little expensive to use, but it will give you enterprise level quality. And then when the talk is about OpenStack makes sure that you have a commodity for servers and storage. Of course, it's a little less reliable, but then you can run all the web servers on OpenStack. The database can be built on the vCloud, so you can sort of have this kind of a collaboration between 2 or 3 cloud services and make a hybrid cloud based on your requirement of having it to be either in a private space or in a public space too. So for these reasons, for the effectiveness to bring about both kinds of requirements to use specialized software, maybe in an open source kind of a cloud environment, you do require hybrid clouds. And then with that, we can come to the 14th question that says list the platforms that are used for large scale cloud computing. Now, there's 2 main platforms that whenever we talk about extremely large-scale cloud computing or even generic large-scale computing is Apache Hadoop and the concept of MapReduce. These found to be very vital concepts of big data, and big data actually helps a lot in the field of cloud computing because you do have to think about how you can manage all the data effectively, right? So even though there are extremely big names like AWS, Azure, and all of these, even these guys will make sure that your data is stored in an effective way, in an efficient way. To think about all of these, well, you have amazing tools such as Hadoop, and of course you have MapReduce that will help you with storing large scale data and working with that data without you having to put much effort into it. Now with this, we can come to the 15th question that states mention the different types of model that are used for deployment in cloud computing. Well, there are a lot of deployment models that you have to talk about. As I told you, you have to know all of these guys. You have the private cloud, you have public cloud, you have community cloud, and as we checked out, you have the hybrid cloud. And then, of course, adding an example of how you would use a private cloud, what is a public cloud, why would you require a community cloud, and talking about hybrid cloud is definitely going to add a lot of value to your candidature. So depending on the interview, read the room, read the interviewer. If he or she is expecting more in detail, then do answer that. If they're expecting a concise answer, then at that point of time you can maybe expect a follow-up questions based on that, right? So you'll state private, public, community, and hybrid. The interviewer might ask you a little bit more about a community cloud in the next question. So if that's the case, make sure to read the room and then answer the question in a clear and a concise way. And then coming to the 16th question, it says explain security management in terms of cloud computing. Well, security has to be the prime thing whenever the talk is about cloud computing, right? Because here we consider identity management, which will make sure that, whoever is using the applications, whoever you using the cloud platform has an authorization to actually access it. And then with access control permission, we can check who's controlling what, who's using what kind of a services, what instance is being run by whom, who is in fact entering the cloud computing environment as a client or as a user or as a person, who could be a cloud architect or the cloud admin too. So you can restrict access based on all of these. You can have multiple layers of protection through, of course, authentication methodologies and authorization principles that will make sure that you will only have access to the people who need to have specific access to maybe data or in fact even applications as well. So based on all of these, you have to understand that today's world of cloud computing is extremely tight knit when it comes to security, and you can be rest assured that it is extremely good. Hacking into and breaking the security methodologies of a top cloud computing platform today is absolutely no joke at all. Considering that, I definitely think you should talk about the advantages of today's cloud computing security platforms out there too. And then coming to the 17th question, it states, what are the layers of cloud computing? Well, there are many layers of cloud computing, but the most important talk will be, of course, all of these layers. You'll have the cloud controller, as we discussed previously. You'll have the Walrus. You will have the cluster controller, or it's called as a CC. You'll have the storage controller, in short for SC, and of course, you have the node controller, which stands for NC. So these form to be some of the most important layers that get used in any sort of cloud architecture out there. There has to be a scaffolding through which everyone kind of uses uses that to scale upon, right? Be it the small brands, be it open source platforms, or be it even the big tier organizations too. These layers will be a common commodity for all of them. Now, coming to question number 18, it says explain the full form and the usage of eucalyptus in cloud computing. Eucalyptus actually has a full form, in case if you guys did not know. It stands for Elastic Utility Computing Architecture for linking your programs to useful systems. Well, that's a mouthful, right? Let me say that again. It's Elastic Utility Computing Architecture for linking your programs to useful systems. What is it now? Well, it's actually an open source software infrastructure that we use in the field of cloud computing, where we can implement any sort of clustering that we want in a platform online. So it's mostly used in today's world, where you can simplify the entire process of building a private cloud, a public cloud, or even a hybrid cloud too. So it will give you the complete capabilities to make sure that you can have your own data center, and you can use this kind of repurpose the data center into a private cloud. You can have complete functionality over it, and you can do a lot with the software infrastructure, in case if you're willing to use Eucalyptus in your native in-house cloud computing platform too. So it's a big name. It's gaining a lot of popularity in today's world again, and it's being used a lot. So there's a very good chance that you will be asked this question. And then coming to question number 19, it states mention the names of some of the large cloud providers and databases. Well, large cloud providers names, I'm sure you guys will already know. You have AWS, which is Amazon Web Services from Amazon. You have GCP or Google Cloud Platform from Google. And of course, you have Microsoft Azure, right? These three are the big names. Of course, you have OpenShift from Red Hat as well. You have multiple different cloud providers out there. So if you do know more than the 3 or 4 that I stated, do talk about that. And then coming to databases, the 3 most popular databases in the cloud computing platform from Google, we have Bigtable. From Amazon, we have the ASD or the Amazon Simple Database, and of course you have the cloud-based SQL. It's also called as the sequential query language too. So in that particular case, you do have these 3 databases followed with the names of the large cloud providers that you can talk about in detail too. And then coming to question number 20, it states explain the difference between cloud and traditional data centers. See, a traditional data center has one major difference, is that it is extremely expensive to run, because you'll have a lot of equipment running, a lot of hardware. You have to work. You'll have to spend a huge budget, in fact, on cooling these systems down and keeping it working effectively. You'll have a lot of electricity bills. Well, you'll have to have a lot of inboard security, where you need to have physical security to these servers to make sure that people don't access it directly. And there's going to be a lot of expenditure initially in the case of maintaining, and even in the long term, whenever you're running a data center too, it's definitely going to cost money. But then when we're talking about cloud can be scaled up whenever you have a requirement of scaling up. You really do not have to have a lot of cloud, and then you really do not have to have a lot of physical security. Of course, if you have clients connected to the cloud, you do require a lot of security to that. But at the end of the day, you are not you really shouldn't be extremely concerned about how your data can be misused in a physical way, or let's say you really don't have to worry a lot about cooling these servers down or paying the electricity bills. Of course, you will be billed for your usage, but it is definitely going to be a lot less rather than having your own data centers, right? So that is very important. Now, keeping that in mind, let's talk about question number 21. Question number 21 states, what are the uses of APIs in cloud services? Well, what are APIs, right? So APIs are short for application programming interfaces. We use this to make sure that, we remove the entire dependency where we have to write complete programs at every single point of time. This will be like a bridge. This will act like a bridge where we are, enabling communications between one or more applications very easily without having to rewrite both of them to run as a single instance. And then at the end of the day, you are doing all of these to make sure that it's easy for the cloud services to run on multiple systems. And of course, it's accessible for users who are doing the same too. So to keep it fast, to keep it effective, and to reduce the amount of redundancy that you will have to put in to write different programs is definitely something that we get to have full control over whenever we're thinking about application programming interfaces, especially in cloud services. Coming to question number 22. Question number 22 states, mention different data center deployments of cloud computing. Well, you will have two primary data centers that you will have to talk about. One is the containerized data centers and of course the low density data centers. When you're talking about containerized data centers, right? So these are basically packages that we contain, like think about a set of servers. You'll have a lot of network components. You'll have storage delivered to large warehouses where it will be completely sealed off. It will be cooled and all of that, right? So whenever you require a containerized data centers, 99% of the time it will be catered uniquely to your requirement. It's not like a one solution that solves for all the problems. So that is one of the I would say one of the advantages of using a containerized data center too. And then when you're thinking about a low density data center, right? So here, and then when we're talking about low density data centers, right? See, even before that, one thing you have to know about containerized data centers is that they will promote heavy density, which will a lot of servers, a lot of network components, which cause a lot of heat. And it's not only just heat and physical troubles, it's going to be an engineering challenge to keep solving all of these day in and day out, right? So to make sure that you really have good amount of hardware that you have the capability to handle and cater to, you will be using a low density data center. Here, as the name suggests, the equipment is established far apart to make sure that it's pretty cool. It doesn't overheat, it doesn't break down, and of course it's protected from the elements in both of the cases too. And then coming to question number 23. Question number 23 states, list down the three basic functioning clouds in cloud computing. Well, there are three very important functioning clouds that you have to talk about. One's the professional cloud, the second is the personal cloud, and the third one is the performance cloud. Well guys, let me state this again. If you're at this point of time where you might not know what a professional cloud, a personal cloud, or a performance cloud is, I highly recommend you check out our videos that we have for cloud computing. We do have a lot of videos that go in depth into the functioning clouds as well. So make sure to head to the search bar after this particular video and do check them out in case if you have to brush up on any of these topics. Now, coming to the 24th question, it says, what are the characteristics of cloud architecture that differ from the traditional architecture? Again, your interview can in fact start with this particular question, so make sure that you are prepared to answer this in a very clear way. So what happens in a cloud environment is that the hardware requirement that there is fulfilled as per your demand, right? So if you require a machine that can probably handle 10 clients, yes, that can be done now. If you require a machine that can handle 10,000 clients, yes, that can be provided too. And then when you have a traditional architecture, right, that makes it very difficult to do that. And when you're thinking about cloud architecture, of course, scaling up resources on demand is always there. You can manage workloads. You can have dynamic workloads in a way where you really don't have to worry or break your head about any point of failures. You can save a lot of time, a lot of efficiency. You can work from anywhere across the world. You can have your servers across multiple components. You guys, the characteristics of how a cloud architecture will differ from a traditional architecture, right? So you can save a lot of money in terms of manpower to maintain and handle these servers if you had anything on site too. Now, with that, we can check out the 25th question that states, what are the building blocks of cloud architecture? The three main building blocks or the scaffoldings of cloud architecture, in my opinion, is of course the reference architecture, the technical architecture, and how one can go on to work with the deployment operation architecture. So again, if you are at this point in time, you really have to know all of these concepts, guys. But then if you do not, again, I would urge you to take a look at the in-depth videos we have on the channel for this. And then coming to question number 26, it says, explain AWS. Well, it's very easy to get carried away with this question, but then keep your answer very concise. AWS is a short form that stands for Amazon Web Services. It is probably one of the world's best cloud computing platform that we have today. It's an IaaS, or an infrastructure as a service platform, and it provides a lot of services, right? It's a plethora, it's an ocean of its own whenever we talk about AWS, because 99.99% of what you can do on a traditional native in-house architecture, you can do it on AWS today. That is how convenient, that is how effective it is. All you would require is probably a laptop or a mobile phone that will help you get connected to these kind of services to make full use of that. So the basic requirement to have extreme amounts of computing power at your fingertips is just an internet connection, and AWS is at the top of their game. There's There's thousands of companies across the globe that make use of AWS daily, and even when you're talking about the aspects of how AWS is scaling up, when you compare it to Microsoft Azure and when you compare it to Google Cloud Platform, these guys are always punching above their weight. And you can of course talk about a lot of points when it comes to AWS. And then coming to 27th question, this is a very important question. It asks, explain how can you vertically scale on an Amazon instance. Now, vertical scaling is probably one of the very important features of AWS and using cloud virtualization too. So how can you do this? We go on to spin a new large instance where we can actually pause that particular instance, detach whatever volume that we have for it and discard that out. And then what happens when we stop our live instance and detach its root volume, right? So here basically we have to note down the unique device ID that comes with it, and using this particular ID we can attach the same root volume to the new server and scale it up and start it again. So what we basically did is we took an EBS volume from one server, we paused that particular instance, we detached it, we connected to we made sure to note the unique device ID and then you can go on to directly attach that same root volume to another server in case if it's a bigger requirement, you're scaling up or you're scaling down, and then restart it. That's really as convenient and as simple as it gets when you're using vertical scalability and of course cloud virtualization in Amazon's AWS. Now with that, we can come to question number 28 that says, explain the security usage in the Amazon Web Services model. And one thing you really have to know is that AWS supports security groups. Access can be provided based on the jump box, and you have SSH access, which is open for port number 22. But later, if you want to create a web server group or a database group too, yes, that can be created. You can have multiple ports that can be mapping into that. For example, you can have port number 3306 from the web server group. You can have port 22 from the jump box group, and a lot of other things too. So the addition of any machines to any of these web server groups, right, it can be stored in a database. And whenever this is done, one of the most important things in terms of security is that no one can directly SSH into any of these boxes and directly use them, even though the port might be open. So that is one of the ways on how you can solve for a requirement to make sure that no one SSHs into your particular box and accesses the data too. So in that particular case, AWS is doing a good job in terms of security groups. And then coming to question number 29, it says, what are the reasons that make Amazon so big as they are? You can have questions saying, what are the reasons that make Google big, or what are the reasons that make, Microsoft Azure so big and all of that, right? So based on your usage, based on if you've had experiences with that, you can answer this in a clear way. But, since AWS is the most popular one out there, we're talking about that here. So what happens in AWS is that we have the backup storage systems of EBS volumes. This gets maintained directly, so we can do this by inserting a snapshot facility. You can do it via either an API call, or you can make use of an interface, a beautiful graphical user interface called Elastic Fox 2. You can have the performance of your storage spaces improved by making use of RAID arrays. And of course, you can copy your data across multiple volumes and have your RAID array perform at its best while giving you good protection against failure and of course, good backup redundancy too. So it's not only just two reasons, it's just that it's extremely popular in a way that people are willing to spend billions of dollars, into AWS. And with that comes a lot of development from Amazon themselves to make sure that they're catering to, basically anyone who requires a cloud platform. So be it you're a person who's doing a recreational project, yes, or an entire multinational corporation who wants to scale their complete business into AWS, yes. So depending on how individually can you cater solutions to the problems out there through cloud computing, I think Amazon is doing a really great job of that, and that makes them the biggest cloud provider today. And then coming to the last question, it states, have you earned any sort of certification to improve your learning and implementation process? Again, if you're at this point in time in this particular video, you would already know the value of certification programs, right? So, you will have top of the line teaching, you will become experts in all of the concepts, you will be taught by, you'll be taught by experts across the globe, of course. A good certification program will give you a lot of industry level use cases, a lot of practical hands-on projects, and a lot of other things too. So basically, you can go from a beginner to an expert with a certification program. But what does this signify to the interviewer? See, if you are inclined towards cloud computing, and if you're coming from a very different background, maybe a digital marketing background, or maybe a commerce background, a finance background, whatever it is, even though you might not have a computer science degree at hand, it shows that you have put in certain time, effort, and of course money to become experts into this, knowing that you want to expand your career in this particular field. It shows your dedication, your passion towards cloud computing, and that you're a strong aspirer to get to from where you were to where you are today in terms of expertise in cloud computing, right? So all in all, it'll just tell the interviewer, and it'll give an impression that you are an effective learner, that you're really willing to put in the efforts to become an expert here. So what adds value whenever you're talking about answering this question? One thing is that you might have one certification, you might have cleared a couple of examinations, or you might have multiple certifications too. In that particular case, make sure to list the certifications that you have. But instead of talking about what the certifications covered, I highly recommend you talk about how you used it rather, right? So a certification program is meant to give you a lot of theoretical and practical knowledge. But why is this done? This is done to make sure you can practically start solving problems on your own. So instead of talking about what all you learned, do talk about how it's been helpful to you, how you have used it, and how you plan to put it to effective use in that organization that you're interviewing for now. Answering it this way will make sure that it will add a lot of weight to your candidates, and it's going to leave a good impression on the interviewer too.
Now that we are done with the session, don't forget to subscribe to Intellipaat and press the bell icon to get the latest updates on Intellipaat.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to upskill and land your dream job.